It's as if in this age people have all of a sudden been convinced that power structures are always benevolent, and yet they've never been that way. Ever since there's been a power structure, it's been more and more oppressive. And they become so oppressive that they ultimately collapse in on themselves, and then everything has to start over again. But you're asking me a question that we kind of already know the answer to.
So they on purpose prevent people from traveling and finding out the information because they just like controlling people.
Yeah.
But themselves, are they mistaken? Like, let's say the richest oligarchs that do this controlling, are they aware? Let's say the Earth is flat, or they know it's flat. They just don't want everyone else to know. So what's the? Or you'll say you have no idea.
You're asking me for an ultimate goal, right? The ultimate goal about telling people that the Earth is a ball. I actually can't tell you the answer to that. But I do know that there's always been slave masters and slaves. And slave masters tell their slaves whatever they need to make sure that they're quiet, calm, and good workers. That's why back in the old days, back maybe about 100 years ago, there's a quote from Rockefeller that says, "I don't want a nation of thinkers, I want a nation of workers." So they will tell people whatever they need to. And this is, by the way, about the time that he created the modern day education system. He was already telling you, I'm not really interested in whether or not you know the truth. I just want you to know enough to make sure that you keep working for me.
And it's easier to do on the round globe than on the flat one somehow.
Of course, because on the round one, you have this great setup story. The Earth is just this byproduct of a huge explosion back in the old days, 4.6 billion years ago, called the Big Bang. Nothing exploded and created everything. There is no God, there is no purpose to your life. You live on this ball, you could get hit by an asteroid at any time, and your life could be over. You could get cancer, blah, 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 but your life is ultimately meaningless. So you might as well do everything that you can while you're here to work, make lots of money, which, by the way, they'll take from you, and then they'll take that money, create more control systems to keep you enslaved. That's the way it's been. Mm-hmm. Now, you're going to ask me, what is their ultimate goal? Their ultimate goal is to have control of you.
See,
but why?
I'm just reading. So apparently, I wasn't aware of that at all. But the community is like, you're very religious, or just say you're religious.
I'm not religious at all.
Not at all.
No.
No. Okay.
No, religious indicates that somebody is following some kind of system and a process of earning their way to an ultimate, euphoric or idealistic state called heaven. There's no way you could work yourself to a heavenly realm.
Mm-hmm. But let's say I'm not sure if there was a Big Bang or not. But in general, do you believe? I know maybe you personally in the intelligent creation, or?
Of course. This realm operates according to a bunch of supernatural laws. You cannot get those supernatural laws without an authority that is supernatural, right?
Mm-hmm.
Right. So there is ultimately a supernatural governing authority over this realm, whether you like it or not.
Right.
Ask a question about predictability within the flat Earth model.
There is no flat Earth model. You have to go somewhere else.
So can I ask a question about what people would see if they are in two different spaces and they look up?
They probably see the sky.
Would they see the same sky?
There's only one sky, dude.
But like, let's say like the constellations above them, would they see the same ones?
Probably not. They're in two different places.
So if they were on the same night, let's say 12 hours later or whatever, from like Patagonia to Madagascar, and they look up at the night sky, would they see the same constellations in the same orientation, or would they be flipped or inverted?
Why are you asking silly questions that we can see in reality for ourselves every day by looking up at the sky and understanding that we don't all see the same stars in the south and the north?
So would you be able to predict what you'd be able to see tomorrow?
Yeah, of course. We have predictive models because they're postdictive. We recognize a pattern, so it's always going to be the same way. It's been that way since mankind has first always lived on the earth. The same repeating pattern every year is the same thing that we see.
But how do we predict them?
It's called postdiction. It's pattern recognition. Does this have anything to do with whether or not the earth is measurably flat or not?
I'm trying to figure out how if I was planning to go somewhere, how I'd be able to predict what I would see, like if I wanted to see a specific, like the Southern Cross.
Well, just go ahead and look up the Soros cycle. That'll tell you.
Look up what?
The Soros cycle.
Soros?
Yeah.
It's
the same system we've been using since the beginning of time. Babylon recorded it. We still use it. Even NASA uses it for them to, predict all kinds of things like eclipses and the night sky and meteor showers and all that stuff. It's a cycle.
Same way with the moon calendar, right? It's a cycle. So
yeah.
Why does the sun rise and set at the different times in different parts of the world at the same time?
It doesn't.
Really?
Yeah, no, the sun rises in the east and sets in the west for everybody. It just depends, on the time of year, where they're at, all that stuff. But it's different all the time for everybody. Like tomorrow, the sun will rise 2 minutes earlier than it did, or like a minute and a half, sometimes a minute to a minute and a half earlier than it did today. So it's not going to be at the same time. It's always different.
The sun now is rising in my country.
Okay, great. Was it earlier today or later today than it was yesterday, depending on what time of year it is? Why do you guys always think that the celestials have anything to do with whether or not the earth is actually measurably flat? I don't get this. Have you all lost your gosh damn minds?
I have a question about that actually. Let's say the moon is what shape is the moon? Is it also not? Is it flat or?
Why are you asking, dude? Okay, look, I'm going to do my best to not get frustrated. When you see the moon at night, if it's not cloudy out, is it always a circle?
At night, well, due to the shade, it might appear like a crescent, might appear like a circle. Yeah.
So sometimes it's a crescent, sometimes... You guys are asking me questions that you already know the answer to. Sometimes the moon is full, and we call that a circle. Sometimes we look at it and it's not full. It might be a quarter moon. It looks like a half a circle. It looks like a crescent sometimes. Sometimes there's no moon at all. And here's the funny thing about the new moon. No one can detect the moon at all with any device that we can possibly use. It's almost as like it vanishes during a new moon phase. Actually, nobody pays attention to that because they don't realize that the moon just vanishes for a couple of days out of a 28-day cycle. But when you see it, it's the shape that it is. Why are you asking me a question you already know the answer to?
So what kind of a question you want to be asked?
I want you to ask a reasonable question about the topic itself. Is the Earth curving or is it flat, and how can we prove it? Not what gosh damn shape the moon is.
I can explain why I'm asking this, because depending on, because let's say I assume that, again, because of the education, right, that most planets, or planets basically somehow, and the sun are globes.
Uh-huh.
I just posted it.
Right.
Zerg, I'm sorry to cut you off. I just posted a video. Wait 2 minutes to watch the video, okay? Then come back and tell me what is the shape of the moon. Is that fair enough?
Yeah, I'm gonna watch it. But you can just tell. I mean, I'll watch it in a second. But you can just tell me that you believe it's more of a flat object, right? That's what you.
No.
Look at the video.
My goodness, man. Here's the thing.
Oh.
It still does not have anything to do with the Earth. You're asking me about the moon. Let me ask you this question. Is the moon the Earth?
It's two different objects.
No, whoa. Are you calling the Earth an object?
So, what is it?
I mean, I can't really find another word for this. I mean, it could be a thing, if you wish. Two different things.
Okay, a thing. Yeah, fine, but they're two different objects. So you're asking me questions about the moon. Let me just explain to you right now a few things. I've never touched the moon. I've never visited the moon. I've never smelled it. I've never heard it. I've only seen it from the Earth. And I see the same thing that you see in the night sky above my head. Sometimes it looks like a circle. Sometimes it looks like a crescent. Sometimes it looks like a half a circle. And sometimes that sumbitch ain't even there. What does that have to do with the Earth?
I can explain why I asked this question.
Okay.
I wanted to know if you think, or you know, if the moon is round like a globe or more flat. And the same question would be about the planets supposedly that exist and stars. And I was either expecting you say it's also flat or they don't exist or something to that nature. But to be honest, yeah.
Why would you expect us to say that they're flat?
I can explain that because depending on that question, the answer, let's say if most objects are globes, you would also expect the Earth to be a globe just because of the statistics and how rare it would be not to be a globe.
Okay. So let's see if your reasoning holds up. Okay. So in the sky, sometimes we see a sun that looks circular. Sometimes we see a moon that sometimes looks circular. We also have stars. Those stars are twinkly lights, and there's a handful of those. Those are all above my head. Now, also in the sky, I see birds. They're bird-shaped. Sometimes I see clouds. They're all kinds of different shapes and structures and blah, blah, blah. And they have more dimension than the moon, by the way. Sometimes I see airplanes and contrails and chemtrails. Sometimes I see shooting stars, right? I see a lot of shit in the sky. Do you think I should also assume that the Earth is a bird, a cloud, an airplane? If I see something in the sky, should I just automatically think that that's the same as what's underneath my feet?
No, but massive.
No, well then why in the hell would I think that the Earth has anything to do with the sun, moon, or stars?
Well, I'm just curious, but I think I explained why. If depending on what you
No, I'll tell you what you're doing. You're projecting onto me what you were told, and the same thing that I was told is that the Earth is a spinning water ball in a vacuum, just like all of the quote unquote other planets. You are trying to project onto me your belief system and then ask me a question about your belief system having to do with the solar system. Right. And that doesn't make any sense because the Earth is measurably flat. So there is no way on God's green Earth that it would be anything like the objects in the sky.
Okay, well, but you could just, okay, I could be wrong, and I guess I can Google it, but it sounds like the moon is also flat. That's
Why?
Why?
here.
Why would you even think that?
Because it looks like a disc, or what?
I mean, kind of.
Sometimes looks like.
Okay.
Sometimes. But why would you associate the two? This is the thing. I'm trying to like Zerge, I actually think that you're here in good faith, and I hope that you are. But here's the thing. I'm trying to help you. Why would you even associate the two? It's a sky object. You're on the Earth. They're two totally different things. They're essentially unassociated.
Mhm.
You've been trained to think this way. You've been trained to think that the things in the sky have anything to do with ultimately the construction or the nature of what's underneath your feet, and that's just not true.
Okay. Okay, but
You don't wander
I'm
around
asking it
feeling
because I want to. I mean, I can Google it, of course. It's not going to be that interesting, but
What are you going to Google?
what's the world like? Because I think I can visualize the way you imagine the flat Earth looks like a disc, if you will, with some
No.
kind of a sphere around
No,
it, right?
I already told you this.
No.
Now, Zerge, you're starting to piss me off. I already told you that the Earth is not a disc shape because I have no
so
idea.
it's not, it's flat, but the shape is not necessarily disc. I'm
Yeah,
sorry, but
yeah.
is the moon we see is part of that thing? Is it within the bubble you see, or is it kind of outside
I
it?
have no idea. I have no idea, man. That's the crazy thing about this. And this is the part that for you probably is going to be super unsettling.
Uh,
Is that there are just some things I have no answers for and nobody does. Nobody has the answers.
why does Earth's shadow appear curved on the moon drawing the lunar
Gosh
eclipse?
damn it, dude. If you're going to
That's a
bust in here with a
loaded
non
question.
sequitur question, I am going to lose my shit. Number one, I'll tell you
Yes,
what I'll do.
my turn.
I'll answer that question if you can show me that you have evidence that the Earth, and this is a big deal, that the Earth is blocking out the sunlight that's reaching the moon. If you can prove that, then I'll answer your question. What a dumb question.
Actually, good question, to be honest. Again, I'm talking at
Why?
later because a next question would be if there the moon looks like a crescent sometimes, is it the shade that makes it look like this, or is it something else? If it's a shade, then whose shade is it?
My
Love this
goodness.
answer.
You're asking me questions according to your previous paradigm, and I know it's difficult for you at this stage of your inquiry into this topic to not separate the two. But according to heliocentrism, can you tell me, and most people don't get this question right, why are the moon phases the way that they are? Do you know why?
Phases of the moon? You mean like a 30-day kind of ish phase?
28 days.
20 days,
Yep.
okay. And why it has like crescent shape on the left and then on the
Yep.
right, and then it's like,
Yep.
okay,
Yep.
that's a good question. I never thought about this. I don't have an answer, to be honest.
Okay. I'll tell you why. All right. And I'm just going to give you the information according to the heliocentric model because it's amazing. Most people actually don't know how the heliocentric model works. But what it's supposed to be is our viewing angle to the moon, right? And the moon's relative angle to the sunlight. So let's say you're hanging off the edge of the globe Earth. You know, you're sticking out sideways, but somehow you're looking up and you're looking at the moon. And that face of the sphere, quote unquote, sphere moon, that side is exposed to the sunlight, right? So you're only seeing the side of the moon that's being exposed to the sunlight, and the other bit is in the shadow. It's in the darkness of space.
Yeah.
That's where the moon phases come from. It's all about the angular relationship of the moon to the sunlight and your viewing angle to the moon. That's essentially what it is.
Oh, I thought you would have a more in-depth explanation. Yeah, that's
No, that's
I
it.
imagine. Yeah. And you could see the
Right.
dark side with a powerful binocular or telescope and see the dark side as well.
Yeah, sometimes. It's interesting. Sometimes you can see that kind of outline of the moon when it's like a quarter moon or a crescent, and then there's some times that you can't. It's very strange. Now, what do you think happens on the new moon where the moon is nowhere to be seen? What do you think happens then?
Well, I assume like nowhere to be seen, or like not even the completely dark moon. Is that what you mean? If you don't
Well,
see
I'm saying that
uh-huh.
typically during a new moon phase, it's actually supposed to be during the day. Okay, so it can't be detected during the day. However, there's also times where there's a full moon during daylight. So it's very strange. There's all kinds of weird shit happening. But it turns out that no matter what kind of device that we use, we can't detect the moon during the new moon phase at all for about 2.5 days. It cannot be found. I don't care what instrument you use, it's gone. It's essentially disappeared. Isn't that strange?
I never heard of that, but interesting.
Yeah. Now, you can get on Google and they will tell you this. Oh, well, during a new moon phase, that's actually correct. We cannot detect where it is. It kind of disappears. Except the very first stage of the waxing crescent, where it's like this tiny sliver where you almost can't detect it. And they're like, oh, but that's still sort of the new moon, even though you can see it. And then you can see it. But what they actually are telling you is during a new moon phase, when no one sees the moon, it cannot be found at all.
Oh, I'm just.
That is very mysterious.
Yeah. Interesting. So basically, according to the heliocentric explanation, if I understand it correctly, it's completely in darkness, so you can't easily see it. But you also say there is no way to detect it using any technologies?
Nope. Every bit of technology they can use, moon's gone.
Because in theory, the moon would hide behind it the stars, so you would at least see the blackness with no stars behind it, so you can indirectly tell it's there. No.
Right. That's the whole funny part about it. It's like if there was an object, right, a physical object that was blocking out the starlight from zillions of light years away, it would block it out. Like you'd have this kind of silhouette of a circle, or a sphere or whatever you want to call it. And it would just kind of keep blocking stars out and shit. Not there.
Do you mean you could see through it?
I don't know how you'd see through a physical object, a big giant dust ball in space.
So, okay, interesting.
Very interesting. So that kind of like, bro, I understand you're asking the question, as to do you think that the moon is flat? And to me, it's like, certainly you understand from my position that I'm describing the Earth and the Earth only. And you're asking me about a celestial light, a moon, or whatever. And you're saying, well, is that also flat? As if somehow the moon is associated with the Earth in shape or nature or anything at all. And it's not.
Is your ass also flat?
Oh man, what a great question. Probably about as flat as your mom's chest.
Yeah, and that question would be odd because how would you be able to measure the surface of the moon to know whether it's flat or not? I mean, how would anyone be able to do that? Amazing question.
Any other brilliant questions from the peanut gallery?
Wait, so
I'm
if
still
the
trying to
Earth
find
is
a model
flat,
that
why
will
is
predict
there a
celestial
H in
bodies
hydrogen
outside
if
of the
the
moon and the sun.
chemical is not connectively bind?
Hold on, Sheik, you're going to have to wait. I'll tell you what, Shane. I'm going to give you all the time you need. Can you help me understand how anything about a predictive model, blah, 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 is going to help the Earth being measurably flat?
How it's going to help measure it to be flat?
Yeah, or debunk it or whatever. How would it even help your position? What a dumb question, Shane.
How's it?
Wait,
I
I
guess I'm not
actually
seeing how
think
it's a
the
dumb
Earth is
question.
flat, though. What are you arguing?
Maybe you should go to a different server where they're talking about predictive models and what good they're going to do when you're talking about geometric claims of the Earth's surface.
Don't understand, or is this a defensive mechanism, or are you answering a question?
This is not a defensive mechanism. You've been in here for days kind of hanging out, and you finally uncorked yourself and asked the stupidest question of all time.
Why are you coping so hard right now?
No one's coping. I'm just talking to somebody asking a dumb question. Do you have other dumb questions that you'd like to present? Like, you know.
I think his questions are very...
Okay, great. You tell me how his question has anything to do with the topic. I'll give you 30 seconds.
Well, it has a lot to do with how the Earth is flat because the moon is also flat.
The moon is flat? Great. Do you have any moon curvature or non-curvature measurements that you can give me?
Oh, but if you just look at it, it's just...
No, wait a minute. You just told me that the moon was flat. How did you get that information?
Well, if you just look at it, it's just flat.
It is flat?
It's not flat. If you look at it, it's not flat.
It's not flat? Can you help yourself out and tell us which one definitively it is? Is it flat or is it not flat?
Well, do you think it's flat?
Why is he asking you?
I'm asking you. You made the claim that the moon is flat, and then all of a sudden you made another claim that the moon is not flat.
Why are you trying to cope so hard? I'm just asking a question.
This is not a coping mechanism, friend. Your weird-ass burden of proof reversal fallacy coping mechanism of your own is not working. So, is the moon flat or not? Yep, back on mute. You should just stay on mute, friend.
Yeah, he didn't really help me, but I'm just trying to figure out like the consequences of a flat Earth. Like if it is what it is, then how would we be able to predict the sky? That's all I'm asking.
Why would a flat Earth be able to hold on a second. Dude, if the Earth is flat, what would that have to do with the sky at all? Why would you even ask that question?
Because I'm trying to figure out how you would predict the sky on a flat Earth.
How would you predict the sky on a flat Earth? You would watch the patterns. Go ahead, Jedi.
Yeah, nice. And you're absolutely 100% correct. We've kind of been having this chat in the side chat, and dude, we've been trying to point out to you that it's an observer-centric system, right? There's no geometry involved. We literally have observed the sky do the same things that it's done for thousands of years. And based on the things that it's always done, we can predict what it's going to do in the future. That's why I brought up the sun earlier, right? Over its yearly cycle. Guess what? It's going to do the same thing next year. Saros cycle with the moon and moon phases as well. These are observations of what this thing does over periods of time. And guess what? It repeats those cycles. Same with the wandering stars, Jupiter, Mars, XYZ. These things, they're repeating patterns. Now it's like I said, them doing what they've always done and us remembering what they've always done and noticing that they're going to keep doing the same thing.
Wait,
no geometry.
Zodiac sign are you?
Yeah, and this is a silly question, yeah? The fact of the matter is that the Earth measures flat. So what we see in the sky, what we use for predictions, postdictions, asking, that's happening over a flat surface now. So there's no use asking how's that going to occur over a flat surface. It's happening every day in reality over a measured flat surface.
I just want to know what zodiac sign are you guys?
No, we
Another
don't
question.
We don't subscribe to that. That's not something we subscribe to. And let me just make one prediction. In 2028,
if you know your zodiac sign, you could...
hang on. In 2028, Japan will be having a good summer because the sun will be in the Tropic of Capricorn. Okay, that's my prediction. Thank you.
So, Shane, you understand what we're saying, right?
I'm
Or
not
Shane?
sure how like this it keeps going back to sun and moon and to planetary bodies. So, but I
Okay.
understand what you guys are saying. I'm trying to figure out what model would I use to predict. Like, is there
Celestial
a
sphere.
math I could use, or is it purely observational based on past? So I wouldn't
I
be able to
posted one,
predict forward.
planisphere.
Okay, I'll look at planisphere. I'll go back on mute.
For Allah.
That's a basic model that you can use. I used to have one. Apparently it expired. I don't know if that's true or not, if it's not accurate anymore after a certain time. But you take it out, take it outside at night, and I think there was a time. So you'd align the time with your time. So the timer as and it'd spin with a window on it showing the star field, and you'd rotate it till the red arrow matched the time on your watch, and then you'd look at it, and it should show you the star field that's above you at that time.
But those
That
only
was
work
for
in a
this.
specific. They only work in a specific latitude, right? Like you can't buy the same one and use
I
the
think
same
that
one.
one was supposed to be Australia wide or quote unquote Southern Hemisphere wide.
Yeah.
Sounds like it exceeded its tell-by date.
I used it for a few years. It was pretty good, pretty accurate.
I use Google Sky Maps sometimes to, just kind of get an idea of the constellations and stuff. The weird part is that Google Sky Map shows me that I live on a flat Earth. And so I was curious if anybody had a globe Earth model that could predict for me what the sky does, and where the values came for that globe Earth model. I've always been asking globers for that question, for that evidence, and they haven't been providing it. It's weird.
Bunch of links, or what would you prefer?
No, I just want the model itself, and then I want the value, where they got the values for that globe Earth model.
Would you want a bunch of links, or you just want?
No, I want the model.
You want them?
No, can you show me the model of the globe Earth model where it can do all these predictions, and then where the values came from?
Yeah, I can do that. You want me? I'll drop it in chat.
Okay. Sweet.
The suggestion seems to be that if you're looking at the celestial bodies in the sky, you can predict the shape of the Earth. Is that possible?
Negative.
I'd say you can get really pretty close. You can actually get really accurate, but it's hard because we stand on Earth. It's hard for us to just put down a tape measure. Like you guys, you got an extremely strong, valid point that observationally, it's very hard for one human to just stand somewhere or even move somewhere and prove that there is a curvature or anything else. It's just, and
that's not our claim.
At least I don't think there's any astronauts on here. None of us have been up to have any other opinion. So we can't.
Shane, that's not our claim, bro. Why are you strawmanning us right now?
Oh, I thought I was saying what you guys have said. What am I?
What have we said? Have we said that the Earth is measurably flat, or have we said that if you just stand somewhere and look at it, it kind of looks flat? What did we say?
You guys,
you've been in here long enough, right? So measurably flat. What are we talking about? You've been in here long enough that we posting the links and stuff. What have we posted to talk about the measurements?
I'm going to focus on the other question I was answering.
Oh yeah, you're going to avoid that question hardcore, aren't you?
No, I don't know what you're asking. I honestly don't.
I'm asking you, what have we posted since you've been in here multiple days? I've seen you in here. What have we been posting?
What have I?
Have you not been paying attention, Shane?
What have I been posting?
What have we been posting? It's weird. I keep asking the same question over and over, and you pretend like you're not hearing me.
No, I just don't understand. Like, how am I supposed to tell you
what have we been posting in the side chat? Claims that we've made, evidences that we've presented. What have we shown?
Surely you've been looking in the side chat
a
at the
bunch
material.
of documents. I've been looking at those documents.
Laser tests, long distance observations, surveys, elevation angles, all that stuff.
Okay.
So all the things that we've been presenting is, which is, measurements of the surface of the Earth being flat. What is your gripe against those things?
I don't think I necessarily have a gripe against every single thing.
Oh, okay. So terrific. Then you agree that the Earth is measurably flat.
I don't see those things as being like equivalent.
Measurements are not equivalent to measurements? Sorry?
No, your question of what you posted and me telling you what you posted does not mean that I have formed an opinion.
No, I'm not asking about your opinion. We're talking about measurements. Have we presented to you measurements using especially lasers across the surface of water, looking for drop over distance? Are you not calling that a measurement? What would you call that, Shane?
I just don't understand what you're asking me.
I know. That's the best way to kind of weasel out of this situation, is to just go, I don't know what you're talking about, even though you've posted many laser tests and long distance observations and drop over distance measurements. I guess I don't understand what you're talking about. That's a great way to get out of it, Shane. Good job.
Let me try and help him out, yeah? You've just strawmanned us by saying that we believe, or we think the Earth is flat, yeah? Now, what Larry has said to you is, when have we ever presented this as a belief? Because we haven't. We presented you direct measurements. So our claim is not that we believe it's flat. Our claim is we know it's flat because there is direct measurements to prove so.
That's fair. That's clear. I understand that.
Shane, I'm still waiting for that globe Earth model with the values and where they came from. You haven't posted that yet.
I have not posted it because I've been dealing with the whatever this question is I'm being asked. So I'm trying.
Great. Well, then, no worries. I'll let you go. You go on mute and you find me that model and where those values came from, please, right now. Yeah,
Okay.
yeah, that'd be great. Yep.
Well, I'll do it as I'm bringing it up right now. I'm trying to put it together for you. It isn't something I readily have available.
Why don't you just shut the hell up and get it? I don't know why you're talking. You should probably be finding.
Cool. Thanks, man. Great approach.
Yep. Yep.
Yeah. Because remember, I said that, is it possible to know the shape of the Earth by looking up and measuring those celestial bodies? Is that a thing now? Is that what we're doing? Is that the most accurate way? Or is it measuring the surface of the Earth?
How is all my fellow Earthlings doing this day?
Jesse, do you have the measurements of the path of light between the target and the observer? Non-answer gets a ban. Fair enough. See, this is trolling, Jesse, what you're doing. You're hanging out in here, engaging when you want to, and then just going totally silent when you don't.
You already
Especially when one of the questions come to you that you do not want to ask her.
You asked me earlier, and I already answered it.
So the answer is no, you do not have any measurements of the path of light. Is that correct? See, once again, just total silence, which I guess is all the answer I need.
I mean, it's a fair enough question he's being asked. I'm surprised he doesn't answer it.
I did answer it. I've answered it multiple times.
What was the answer again? One more time. Was it affirmative? You do have it, or you don't have the path of light, Jesse, path of light? Just for everybody, for the record, please.
I don't want to have to go back and rely on second-hand to what you've already said, Jesse. What did you say? Do you want to say so?
Done.
Yeah, I think when somebody comes in and they don't present their case properly, and you ask them to present it, and they continue not to answer, I think they deserve a forfeit, for sure. You know, a short break so they can go and find the information. Because we afford, the door is wide open, provided you're going to be complying to the skill of speaking to one another, the normal rules. You ask the question, you answer it. That's it. Normal discourse.
Okay, so Shane, is this supposed to be the globe Earth model? A bunch of speculations based on pre-assumptions? Is that the globe Earth model?
Only gave you things that are observationally based. Nothing that is based on speculation. I only gave you things based on observational science.
Observational science? That's not even a thing. That's like a married bachelor.
Okay, so we'll say that term was not even available in 130 AD, and the first thing is Ptolemy's Alchemist star catalog.
Okay, so he measured. I'm asking you for a globe model.
That's what I gave you.
No, it says sidereal day, the rotation rate. What else we got here? Ptolemy's. Yeah, okay. Star position, yada, yada. I'm asking for a globe model. What's wrong with you?
100% what I gave you.
Okay, so where did these values come from? This is a globe model, the globe being the Earth. The Earth is a globe, yes? Is it a big sphere?
These all come from observations. And they all
Okay, so who observed the Earth to be a sphere instead of looking at the sky and then assuming that the Earth was a sphere? Who observed the Earth to be a sphere? Shane.
Who observed the Earth to be a sphere? I'm not asking to do that because that's.
I asked you to do that. I asked for a globe Earth model that makes predictions, and I want to know where the values come from. And you're giving me sidereal bullshit based on speculation. I want to know what the globe Earth model is. I want you to present it, and I want to know where the values came from.
I gave you all of that.
No, you didn't. Show me where it says globe in here, and then where the values came from.
Have you clicked any of the links?
You haven't even given a link. You've got a bunch of copy pasta here. Where's the links?
Copied 1, 2, 3, 4, 5 links.
Great. And any of those links, is it going to give me a globe model, or is it just going to talk about stars?
They absolutely all are based on a globe model.
Oh, based on a globe model. No. That's the thing I want. Where's the globe model at?
What do you want me to send you?
You see, you just admitted to me, hold on a second, Shane, you just admitted to me that you didn't present a globe model. Everything that you gave me is based on a globe model, and the globe model is the thing that I want values came from. So can you post that?
In 140 AD, they didn't have the concept.
That's fantastic. I don't really care about 140 AD. I want the globe model, and I want to know where the values came from. Is that hard enough or easy enough to understand? You're not going to give it to me. There it is.
I completely understand, and it's been given to you.
Okay, where is it? Where does it say globe model and where the values came from? Just in all the copy pasta that you gave me, where is it?
Click any link.
Which link?
Any link. All of them.
Okay, there's one there. It says P-bar. Is it pbarbier.com? That's one link I got.
Link.
Is that the one that you want me to click on?
Any one of them. You want to click on the, how about axial tilt?
Axial tilt. Terrific. Where's the, okay, let's click on that. Let's go check that shit out. In astronomy, okay, so that's not science. Axial tilt, also known as obliquity, is the angle between an object's rotation axis, blah, 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 blah. I'm not seeing a globe model in here.
You're looking at, you don't see a globe right there in the images? I mean, I don't know how.
No, there's some spheres. Are the spheres, are those, is that where you think you live, on those spheres?
I'm just giving you the model. I mean, I give you exactly what you.
There's no model here, dude.
That's exactly what this is. What is the?
No, it isn't. It's. They're talking about axial tilt, and the axial tilt they're talking about is on a sphere, and apparently they're pre-assuming that the Earth is a sphere. So are you talking about this idea of a sphere being a model, and then where did the values come from? Remember how I asked about the values? Where does the value for the sphere come from?
Where does it come from? It comes.
Yeah,
I mean, it's 23.44 is the axial tilt.
No, I'm asking you for the value. I would say it was 20. So according to what? What is that at 23.4 degrees? According to what? What is that angle measured against, Shane?
Observation.
Observation, just generally observation. We just generally observe. Okay, in your everyday life, do you observe a 23.4 degree tilt?
Yeah.
According to what? Okay, measure it against what? What are you going to measure it against?
I can measure it against star catalogs. I can measure it against a.
No, do it.
Yeah, we do it every day. Everybody does it.
No, okay, you do it. You do it.
What makes you think I haven't? I mean, why?
You said we do it. I'm not talking about whether or not you have or haven't. Just go ahead and do it for me.
Okay, I'll look up right now and figure out where is the Big Dipper. I'll go outside. And
oh my gosh, dude!
The Dipper is.
How about let me dumb this way down for you, Shane. Let me just make it like kindergarten level. Maybe you'll get it. You think that you live on a sphere. Where did the value for the curvature come from, Shane?
Done responding to you. However you think you won, you won.
Oh, I did. I know I did. So you're going to go away, or do I have to mute you?
I mean, I'm just trying to participate, man.
You're not trying to participate. I'm asking you direct questions, and you won't answer. The last troll that we had, and I let him go for about an hour.
I gave you the answer.
So
I gave you the
No, you didn't. Okay, so where did the curvature measurements come from? That value, where did they come from?
We want me to recite the history of it? What is?
No, I want you to tell me who measured the curvature of the Earth.
I mean, Tychos would be a good example of one person.
Great. How did he do it?
Related to the axial.
How did Tychos measure the curvature of the Earth, please, Shane?
Observation. With his eyes.
No, I want the method, Dick Brain.
With his eyes.
So he just looked at it and saw it curved. He's the only guy that could do it because everything I look at, especially when I go to the ocean, flat as fuck. You're terrible at this, Shane. You're a failure. You should go on mute and just give up.
Sure, cool. I'll wait till there's more a person who's willing to converse.
I'm willing to converse with you. I just need you to go ahead and answer the questions honestly, and you won't do it. You're not here in good faith. All right, ZZ, you're up. Give us something. Or anybody else that's new.
So you think the Earth is flat?
No, I don't think that. It's just measured that way by everybody. I mean, don't shoot the messenger.
How do you measure it?
Well, like, you know, if you have a building project and the surveyors come out, they have a theodolite or whatever, they measure the Earth flat. But the crazy thing is that they reference.
A building flat?
It's weird. I was explaining it to you, and then you just cut me off. Are you going to cut me off when I continue to explain it, or are you going to shut up?
Whoa, cope. Why are you coping so hard, bro?
Oh, he's still this guy. All right. Back on mute. Anyway, everybody who is new, don't be afraid. I'm just dealing with a handful of trolls that are, you know, obsessed with us. But if you're new, if you have any questions, concerns, comments, we're talking about the Earth being flat, the globe being a complete mathematical fiction, and then everything after that based on that mathematical fiction, like old Shane showed us earlier. But anyway. Welcome. You know, Shane, that's an excellent point. I'm looking for a predictive model too. I've been asking for a globe model for all this time, and nobody's been able to. I mean, no one can present it. No one can show me where the values for the globe model even come from. No one's presented a globe model at all with predictive capabilities. They will show me star charts. They will show me the sky map and all the relationships to where we can observe the stars from. That being a flat plane, especially their elevations. The elevation angles to the stars, stellarium, all elevation angles. That's a celestial sphere model, and that also is measured from a flat plane. So, are we going to have any globe models that you can prove where you got the values from, or are you just going to talk about the sky being a sphere, and that's the end of it? Like, I guess the sky is a sphere, no problem, but the Earth definitely flat. I can't find a star model that is globe-centric as well, Shane. So I guess you and I are in the same boat. There's no globe model that will show us anything predictive about the stars.
That's kind of funny. So that guy's globe model, right? You asked him for a globe model. His globe model was two links to two different Wikipedia sites, and Stellarium, which is basically just a celestial sphere model, which was created by flat earthers centuries before anyone even thought the Earth was a globe. So he had a globe model, which was Wikipedia, and a celestial sphere that was made up by flat earthers.
Yep.
Would you like me to explain why I use those?
Well, okay, so do you understand the celestial sphere originated from cultures long before anyone even suggested that the Earth was a sphere? And that's what Stellarium essentially is. It's a mathematical model based off the celestial sphere.
Based on your location on that sphere, on the interior sphere.
No.
It's determined by your latitude. It's your angular
the
position
celestial
on the
sphere
surface.
was created long before anyone suggested that the Earth was a sphere, right? All they did was they inverted the celestial coordinate system into a terrestrial coordinate system. It doesn't mean it exists in reality.
Oh, I see what you're saying.
Yeah.
Okay. I see what you're saying.
It was like the ancient Babylonians, the ancient Indians. They needed a convenient way to map out the skies, so they invented an imaginary celestial sphere, so they could make a coordinate system, so they could predict things, in the sky. And then people like Pythagoras, Aristotle, Plato, they came along and they inverted that into a terrestrial sphere over time. And that's why, that's where the equator comes from. It comes from the sky. It comes from the celestial sphere. Same with the celestial poles. They became terrestrial poles. And so on.
So is it a directional problem?
Can I say something real quick?
Please.
Yeah. So, you know how we know that what DJ just said is true? Because if you can't see the sky, you can't find your latitude and longitude. You can't use solely terrestrial references to find your latitude and longitude. It's impossible. If I said, hey, dude, you can't use the sky, you can't use the stars, sun, moons, planets, anything to find where you are, you can't find where you are. Not within the latitude, longitude coordinate system. Do you agree with that?
I mean, I agree that if you can't see the sky, it does make it pretty damn impossible if you don't have some other means, But yeah, it definitely does. It tells you where you are, latitude and longitude wide, based on what you see above you.
Yeah, latitude is based, or longitude is based upon the sun, and we use the clock to figure out where it is, right? And the longitude system is, well, because we have the Greenwich Mean Time, right? And when it's noon in Greenwich and where you are relative to that time tells you your longitude, and latitude is based upon where the celestial equator is in the sky. North or south. So if I can see the celestial equator, which you should be able to see everywhere on Earth, right? If I can see that, if it's 45 degrees above the horizon, I know I'm at 45 degrees. Pretty simple. If I look at my watch, I know I'm at -5, right? And it's 5 o'clock in Greenwich, then I know it's noon where I'm at. And I know what longitude I'm on. It's pretty simple. But independent of the sun and the stars, you got nothing. You just can't even find where you are. There's no way to find your latitude and longitude.
But if we don't account for the curvature, how do we do that? How would we continue to do that same thing? Like look at the sky and determine our latitude and longitude.
Yeah, because you're under a section of the sky. You're under the section of the sky at a certain point in time. And we can look in the nautical almanac and figure out what part of the world that sky is over.
In the future? So we could, predictively?
Yeah. Sure. But it doesn't assume the Earth is a globe. Not in the mathematics. In fact, it doesn't assume you're on anything. It's an observer-centric model. So the viewer, you, person making the observation, is at the origin of coordinates, right? You're in the center of the coordinate system. You're in the center of the celestial sphere, which is assumed to have an infinite radius. And if you want to know where you are, you calculate how that sphere rotated around you. That's how it works mathematically. Now, you can say that you're on the rotating sphere, which is, and everything is so far away, you can assume the Earth is a point. You can do that if you want, but that's just a mental gymnastics.
And according to his data that he posted, right, it is this celestial bodies that are rotating up the Earth, at the same time. So he has to do that calculation at the same time. That doesn't even make sense, but whatever. The other thing is, wherever you are on the planet, right? Your coordinates are always the same. So if you are rotating, that means your coordinates should not be the same all the time because you are spinning around at the same time. Does that make sense?
In the past, in the 1800s and stuff, when people were better educated, they explicitly would say things like you're under the equator and you're under the tropics. They wouldn't say you're on them. Only in modern times do they say you're standing on the equator or you're standing on the tropical Capricorn. We know from surveying that that the so-called terrestrial sphere doesn't match the celestial sphere. And they do all sorts of things and band-aids to compensate for this, such as curving plumb lines, saying it's an oblate ellipsoid, saying that there's, you know, a wobble to the Earth, and there's precession, and there's all these other things, right? All these band-aids that they have to add to it.
I was talking to Shane, by the way, but yeah,
Oh yeah, I know. I was talking to him too. I was just adding on to what you said.
Oh, okay, got it.
Like, so I guess my answer to that is like the usefulness of the celestial sphere is that it's only as accurate as you knowing what your terrestrial sphere geometry is. So let's say like a star that's at like a 45 degrees is visible at 45 degrees north, but it's not visible at 80 degrees south, like south latitude, right?
Yeah, why would it be? You'd see a different sky.
I am as an observer. Oh, sorry. Go ahead.
Well, yeah. Certainly. I mean, yeah. Of course. We've put places on Earth and we've mapped. You know, we've given it a coordinate, and that coordinate designates something where it's going to be, because this celestial sphere moves, right? So it moves over time. So we don't have just a spatial coordinate. We have the coincidence of space and time. Right, and we know what is coincidence of space and time by the motion of the celestial sphere is observed from, say, New York City, that you're going to see a regularity of occurrence of, say, the Big Dipper, or not the Big Dipper, say, Orion over your head, you know, every, who knows what it is, every freaking 48 days or something, let's say. And there'll be one place on Earth where that happens, and there'll be another place on Earth where something else is observed. But the relationship between points on Earth are not spherical.
So how would we account for something like if I was, I mean, every example I have is something I can't just like do right now, right? Like I can't just like look up at a star and walk away from it and then see it get dimmer or something, or for the perspective to shift on.
Sure, you can. They get dimmer on the horizon.
Get
they get dimmer as they get closer to the horizon, and they slow down. So in say celestial navigation, they don't do any observations below 30 degrees, right? For navigation at least, and none above 70 degrees. So they're looking at basically a ring within the celestial sphere for navigation, and that's good enough for practical purposes. That'll get you 15 nautical miles per day, and that's pretty much close enough. If you're within, say, you're trying going from, I don't know, the Congo to, you know, well, not the Congo, Lagos, Nigeria, and you're going to sail to New York City. If you're within 15 nautical miles of New York City, you can see it. We know there's no dispute on whether the celestial sphere model works for navigation. Of course it works. That's why we use it. It's not the only method that works, but it's the most, I guess it's the easiest and kind of, well, it's just ubiquitous at this point. We just use it. Just like using meters or feet or something. It's just a convention. But that's the sky, right? But when we go on the ground, right, and we actually try to measure the ground, the Earth, and we do surveying, and we run around and we go, okay, I'm supposed to be at this coordinate based upon my geodetic surveying, right? I look at the star and go, well, the almanac says I'm at this coordinate. But if we take, say, so they actually did this. So they, in the 1927, they did the North American datum, and they started at one coordinate. They did 6 months of astrogeodetic surveying and got themselves a latitude and longitude coordinate based upon observation, making nightly, daily observations. They said, okay, this is our coordinate, latitude and longitude, blah. And then they started surveying out from that point. Okay, they surveyed all the way to the East Coast, all the way to the West Coast. What they found out is that even though they're measuring the ground directly through triangulations, they're pretty much measuring it as directly as you can measure it at long distances without doing like ridiculous chains, which would be, you know, probably could do it, but be very difficult. They found out that they don't match. If they assume the Earth is a terrestrial sphere and they map coordinates, and then when they go some distance and they look at the sky again and go, well, our ground coordinate is this latitude and longitude, but the sky says we're at this other latitude and longitude. And in fact, in 1983, when they did that North American datum, when they compared the surveys, they found systemic errors that increased as you went to the West Coast, meaning the geodetic markers that they had placed in 1927 that are stamped with coordinate and they hammer it into fucking rock, right? And you can just go there. It's a geodetic control point and you can read the coordinate. Instead of moving it on the new survey, they just stamped it with a new coordinate. And as they went from the Ohio River Valley west, the spacing got further and further apart, and as they went from the Ohio River Valley east, they got closer and closer together. This shows that there's some systemic error in their assumption, and that they've actually known since the 1400s that the ground doesn't match the sky. People just think it does. It does good. It's enough. It's close enough for us to use it. Doesn't have to be super accurate. Because we course correct. Whenever we go somewhere between A and B, we course correct constantly. You know what I mean?
Yeah. Yeah. Oh yeah. That's interesting. So what did they say to explain why those were in the wrong places, or that they were not?
I don't think there ever was an explanation.
And so
I'll post a graphic that shows it.
I thought the explanation was that on the globe, latitude and longitude, the spaces, as you get closer from the North Pole to the equator, the spaces all get wider.
What I'm talking about is two different surveys done in America, one done in 1927 and one done in 1983. And when they compared the surveys, they didn't match. And the error, the difference between those two was systemic, meaning it wasn't. So the 1983 one is based upon the International Terrestrial Reference System, which is based upon the WGS 84 reference ellipsoid, which is a datum, right? Whereas the first one, the 1927 one, they assumed a sphere, but they didn't start with the quote unquote center of the Earth as the origin of coordinates. the origin of their coordinates was the surface of the Earth, not inside the Earth.
Okay.
And when they did that, there was a mismatch, which I'm going to post the graphic to in a second. Because whenever you map something, you got to have a start, right? A starting point, an origin of your coordinate system.
Yeah.
Yeah, it's like, the first measurement you make has to be the right one, right?
Yeah.
That'll be your most accurate one.
Which makes you wonder how they got the distance of the stars with a radius they can't measure.
With a radius they can't measure.
Yeah, how would you measure the radius of the Earth?
69 miles north, over and over again. Polaris, 1 degree.
Yeah. Has anyone actually measured that?
Yeah.
Oh, okay. Show me.
It's always show me, man.
Yeah, because you're like the 300th glober. Well, no, because you're like the 300th glober that has said this 69 miles per degree, and not a single person has ever come up with a measurement that this is actually the case, ever. So you can be the first one. Measured baseline, please.
No one's been able to show that to you?
No. It's a claim that doesn't have evidence. It's just repeated over and over again, like a myth. Like the same myth as like if I shoot I gotta account for the Coriolis effect to be a sniper and shit like that. It's just a myth.
I'm not a sniper. I don't know that one.
Well,
I mean, I know the concept. I've heard it several times, but it's not something I've used, in order to do anything.
Or that in same with like artillery has to do this, all that. Like it's just a myth that like if you ask for the evidence of it being true, okay, then you just get bupkis. Here's another one. Things way less at the equator than the poles. You ever heard that one? Because the spin of the Earth.
I've heard things like that before. I don't remember that like
completely not true.
I remember that probably like elementary school, but I don't have anything modern that says that. There's a lot of stuff I was told in elementary school that is shifted and changed.
Oh, of course. So Neil deGrasse Tyson was telling people for 30 years that this is the case. Now think about this guy's a PhD. You figure he went and actually looked up the evidence that this was true. The data, the measurements that someone actually made to demonstrate that something weighs less at the equator than at the poles. Well, about a year ago, he said, shit, I was wrong. He said, because there's a bulge, there's more mass at the equator, and that would exactly cancel out the less gravity from the spin. So no, they wouldn't measure. And he said that, and he doesn't have data for that either. You see, these are just like myths that have made it into, the modern consciousness. There's no basis for any of these things. That's why I asked you, okay, where's the measurements of the 69 miles per degree? Never gotten them. And I guess I'm not going to get them today either.
What context would you want it in? Like you wanted
a measurement of the baseline. No, a measurement with a measuring device.
A measurement with a measuring device?
Yes, that's how you measure things with measuring devices.
But so what I'm trying to ask you is, what would be a method like in a document or in a video? Like I don't think a video would be that compelling.
It doesn't matter what it needs to just be. Look, man, the format of the medium and the media, it doesn't matter to me. It can be on fucking cuniform. I don't give a shit. It can be on papyrus, vellum. I don't care. YouTube.
It's just going to be repeatable, right?
Yeah, like you just evaluate the method, right? Like, how did they do it? What instrument did they use? What were the sources of error? What were the assumptions? The same way you look at any experiment, measurement. How many times did they do it? How much is an extrapolation? Meaning, did they actually measure the entire 69 miles? Did they measure some other shorter distance and then extrapolate the 69 miles? How did they measure the angle of the stars? Which stars did they measure? Were they on the horizon? Were they above the horizon? Like, you know, how many measurements did they take? This is just something that's said. And maybe it's approximately right. I don't know. I've just never seen any evidence for it. I don't think I should have to believe it if nobody can produce the evidence. Though I have been accused of, usually the normal response we get is, are you claiming we can't measure things? No, my claim isn't that we can't measure things. My claim is nobody did measure it. They could, but they didn't. What's my claim about the radius?
Yeah, there's one guy that says that qualifies us as solipsists.
What? Oh, I saw that this morning, dude. I saw it in the side chat. We're solipsists if we ask for evidence. Yo, that dude was cooked. What was his name? Fen. He has that freaking Lord of the Rings name.
Fenrir or something like that. Yeah, that's him.
Yeah, I was in here just looking at the side chat skanking, and I saw that.
Aren't you talking about flounder or floundering?
No, it's like Fenrir.
Oh, he said it too. Yeah, Fenrir. I think Fenrir has too. But
yeah, he was in the side chat, and floundering was saying it in the VC at the same time.
Okay. Yeah, flounder. Mic check.
Yeah, cut out for me too. That was weird.
Whoa. Yeah, I was just saying,
Get out for
floundering's
everybody.
been for the last 2 days, dude, and he's fucking something else, man. It's crazy.
What the?
Started an event, by the way. Who measured the radius of the Earth? Should be a fun one.
I can't find my map thing. What the hell?
Hey, Indio, got a challenge for you. Check the side chat. Which one of these is the real one from Artemis? All of the rest of them are made in ChatGPT.
Okay, let me clear my mind of garbage. Well, that's possible. God damn. Took way too long to find. Which one? Oh, geez. Good question. Which one is from NASA? Well, obviously the real one is. So all of them. It's got to be all of them, man, because they're all real. I can't believe they, dude, that was a total cock up what they pulled. Like, I find the globe earthers, like, they're on X, like, spurring out and shit. They're like super, it's triggered them because they know that it looks that bad.
Yo, X, oh my god, how are you, dude?
How am I?
No, XPX.
Yeah.
The guy, I haven't talked to him in so long.
So I post a longitude datum shift. These are not like these all shifted. The plus and minus. These aren't lines of longitude. This is these north-south lines are the shift lines. So why it would compress at one side and stretch on the other, I mean, that's a mystery. I don't think they ever figured that out. That's what I got in here. I got all sorts of stuff on maps.
So Shane, what you posted is more like a how would you measure the radius of the Earth, not someone who did measure the radius of the Earth.
Yeah, how could you even in principle?
The first one was a peer-reviewed study where they replicated the stick and shadow method. And then the second one is also another peer-reviewed study on the along the Catalan coast in 2005. So none of these are like, how would you do? I mean, they definitely have their methods in there. They actually have their data in there, and that's what I thought I was being asked for, was something that showed the data of someone who actually did these types of experiments to determine the 69 miles, one degree.
Okay, maybe you're not understanding. They calculated a radius. They didn't measure any radius. It's not even possible in principle. Because you guys think the core of the Earth is a molten iron core. So who the fuck's going down there to measure the radius? Nobody. Can't even be measured in principle. So nobody's measured the radius of the Earth. Now, you should be wondering, why do they say people measure the radius of the Earth when they calculated a radius, when they measured other things? For instance, the sticks and shadows, what was measured there? The length of a shadow. Which presupposes that the rays of light are in parallel, presupposes a globe. And I doubt they even have a directly measured distance. I'm sure their distance came from using their coordinate system and the Heliocentric formula and doing a calculation on what their distance is, which makes that all circular.
Both of those were. You're right. Yeah, isn't that like are you asking, like, did they take a tape measure and measure it from one point to another?
Yeah.
Okay, so like if they took a tape measure, let's say 69 miles, and then they showed the 1 degree of change in tilt.
Yeah, that'd be a good start.
Okay.
That'd be a good start,
that
dude.
Makes sense.
Doesn't mean it's uniform.
Yeah, that makes sense. I mean, so we wouldn't be able.
Look, these guys, they pay $2 billion to measure gravity waves. You saying they measure with a precision of 1/10,000th of a fucking proton diameter, okay? I'm sure they can measure 69 miles for less than 2 billion instead of measuring fucking bullshit. Yeah, you see what I'm saying? Is like the fundamental things that all this shit is based on, right? They claim to be doing all this high science, right? And it takes all this money and they're measuring all these things with precision. But then when you apply it to the things ostensibly that is the foundation of their entire endeavor, it's a bunch of trash. They're measuring fucking sticks and shadows. That's their high science. We stuck some sticks in the ground and measure the shadows. You know, everybody didn't become a flat earther with Eratosthenes, even if he ever lived. People weren't convinced during his time.
Yeah, I don't think he thought. I mean, I don't think he was like trying to prove a globe Earth, or I don't think that was his approach.
It says the most accurate circumference produced in the experiment is 38,674 kilometers. This exceeds the accuracy of Eratosthenes, although not of the modern recreation of the experiment between Syene and Alexandria. This experiment described in the paper might form a useful model for cooperation with schools in different countries. Let's see what they did. Yeah, they didn't measure their distance between points at all.
Now I understand more. So you'd be looking for more something like a U.S. transcontinental traverse, which was over a very, very long distance. You don't really need. We'd look for something a little bit.
Well, the thing is, I mean, all these things have problems. They all presuppose the Earth is a globe, and when they do their calculation, they're calculating from that position. They use what's called a reference ellipsoid, which is a imaginary mathematical surface. So they take measurements of the surface of the Earth, right? And they have angles that they make a triangulation network using theodolite measurements, right? Measuring angles, azimuth angles, elevation angles. But they have to take these measurements and put them where? They map them to a reference. You have to think about it like this. Imagine you had a plane, and then there was a sphere underneath the plane, and then you took the points on the plane, and then you mapped them to the surface of the sphere. Well, that don't work. So they presuppose with this reference ellipsoid that the angles are tilted, but they also have to rotate the azimuth, and the azimuth is if you don't know what azimuth is, it's the angle, the compass, right? North, south, east, west. Azimuth is the direction you're pointed in relative to fucking north. So they're not doing any measurements of a globe either. They're just doing calculations based upon what they presuppose the Earth to be. And we run into this over and over and over again. That we presuppose the Earth is a globe, we look at something in nature, and then we shoehorn that observation into our presupposition.
So if let's say something like, like the well, that's too hypothetical. Never mind. Not even going to bring it up.
Well, I mean, do you think that that's a valid method to do science, is come up with a presupposition and then take observations and try to make it fit what you already believe is true?
Okay, and I can go down the hypothetical. So, but well, I'll take it out of that framework. I don't think that that's how we arrived at that. How we arrived
exactly
at how the radius occurred.
Yes,
I don't think we started with that.
Yes, it is. It's exactly that. Eratosthenes presupposed the Earth was a globe. He presupposed the sun was very far away and that the rays were hitting the Earth in parallel. He had to presuppose those things. This isn't my opinion. It's in academic fucking journals. Here, I'll post one. Oh, they just deleted all that text. God damn it.
Even I saw the warning message it gave for some reason. Yeah.
Okay.
I saw what you started to post and it immediately deleted and said, "Hey, this is too long." And
Did I post that backwards? What the hell? What did I do? Okay.
Mitchell's scientific study.
I mean, all this shit comes from the cult of Pythagoras, dude. It doesn't come from fucking any type of scientific endeavor. See, the practice of the natural sciences now is way different than it was then. And people, they project what we do today on what they did then and how they came to their conclusions. Things like
undoubtedly we were nothing without those before us, undoubtedly.
Yeah, but they came to their conclusions using logic, which we would find shaky at best.
Yeah.
Confirmation bias. They didn't even know what confirmation bias was. They didn't know what cherry picking was.
It's probably a good, useful tool for them for quite a while, and still is today.
Cherry picking and confirmation bias?
Yeah, it's a useful tool for a lot of people. Not for me. I try not to.
It's a useful tool, I guess. If you don't want to know the truth, yeah, sure. I mean, you don't have to be freaking. It's like what is it? The rational actor problem, where you think everybody else is a rational actor, and what they're doing is they're being rational, and then you try to tailor your behavior around what you think is their supposed to be rational motives, and then you get confused when someone does something irrational because you assume that they're going to be rational. And then you sit there, rack your brain trying to figure out why they did that. If they did it because they're irrational, there was no reason.
The document you produced, I'm reading was that you that put that in there? The observation data and scientific verification PDF?
Yes. Talks about Eratosthenes' assumptions, and that he used different assumptions, he would have reached a different conclusion. See, we could equally say that Eratosthenes measured a flat Earth. We could just say, well, sun's local. He measured diverging rays, so the sun's rays diverge. So he measured a flat Earth. And the Chinese actually did this. The Chinese did not think the Earth was a globe. They did the same methodology that Eratosthenes did and reached the Earth is something like 10,000 miles across. I got a citation for that too.
With this
In fact, the Chinese were flat earthers into the 20th century.
This document that you gave, so you're saying the presumption is what drove him to his conclusion?
Yeah. He doesn't know whether look, what do you even know what they're saying he did? Do you understand the geometry? He's intersecting them at the center of the Earth. He's intersecting the angles at the center of the Earth. He has to presume the Earth is a globe.
I see what you're saying, yeah. Yeah. What?
Yeah. It truly amazes me how many of you guys actually argue for Eratosthenes. It blows my mind.
Yeah. People seem to have this misconception that he was just fucking around and went, oh shit, look at that, that's a globe. Oh, from what he was doing, but that's not how it works, right?
It's also really crazy how little evidence there is of these mystical characters like Pythagoras and Eratosthenes. If you listen to the the experts in, like the mathematical historians, they say we don't have any evidence of these people doing or saying any of the things they're credited with. And they kind of explain how the Greeks seem to love making up these characters that did these things. He said there probably was a Pythagoras, there probably was an Eratosthenes, but whether they did or said anything, there's really no evidence for that. Right? He's like, we don't know anything about them, especially Pythagoras. He says everything that you get taught in school about Pythagoras is just nonsense.
Oh yeah, that was a great video.
Yeah, a good one.
Is that an attribution error or an error with the information? Like Socrates, Plato, is it an attribution error or is it that
it's just made up bullshit? People make shit up, dude. I don't know like what world you're living in, dude. People make shit up.
Yeah, I agree with that.
And this guy he's a scholar, an expert on the cult of Pythagoras. It's basically
it could have even been that.
Oh, go ahead.
Well, it could have been that he came up with the thought experiment, and then over time, Chinese whispers developed that into he actually did it.
Yeah, or if
he existed,
just the guy in charge, right? Like at a university, when you're doing research, you don't get credit for any of the research. It's whoever has the most tenure to put their name at the top.
This goes to what I was just saying earlier. You're applying our ethical mores to people in the past that didn't have problems like to us in modern day. We think that if you write down a history, it's supposed to be factually accurate. That's us. It doesn't mean that's how they felt when they wrote down a history. Maybe they thought it was supposed to be entertaining.
Yeah.
And that was their priority, to make this entertaining. Or maybe they made composite characters. It wasn't even like a standardized language back then. There was no dictionaries. There was no Greek dictionary.
But didn't some of them still believe that you could go to the altar in Delphi or whatever and pray to the fucking god and get divine knowledge from it? Like a voice spoke out of this rock or something?
Yeah. We attribute all sorts of modern things to people in the past, that feelings that they didn't have. These people weren't scientists. They didn't do anything what we would consider science. And Eratosthenes, the first mention of him is like 1,200 years after he was supposedly alive. The first written record is in 1200 AD. Discovered in 1200 AD, let's put it that way. There's supposed to be Cleomedes who supposedly read Eratosthenes, but we don't have Cleomedes, so we have Pliny the Elder who talks about Cleomedes, who talks about Eratosthenes. But then we didn't have his shit until fucking 800 years after he was dead. And you notice about these Eratosthenes replications, there's a famous one. It's got millions of views on YouTube. I proved the Earth was round with my bike. He did the same thing, and he had inadvertently filmed in the parking lot that the sticks and that the shadow lengths were different lengths in the parking lot when they're 3 feet apart. Well, that doesn't work because they should be the same length in the parking lot. They should only be different lengths when he's far apart. The artist formerly called Pythagoras.
So, hey Fox, what's going on this group? Which kind of discussion are you discussing? May I know about it?
What are we discussing? We're discussing the cult of Pythagoras and how they foisted a ball earth on everybody. But the question is, who measured the radius of the earth?
Did you see the link that I threw in there? It wasn't extremely compelling for me, but so it may not have much value to you on the longest continual measurement of 210 miles.
What'd they measure that with?
Let's see. Let me pull it back up again. I wasn't too compelled by their
my
the style.
My information was 7 miles is the longest directly measured distance.
What is?
7 miles. Done in the 1800s with a chain. With a 7-mile chain.
Let's see here.
And then they extrapolated the rest. Where's the link? I'm looking for it.
I'll post it again. I'm not too compelled by it, so I'm still reading through it.
Longest line. The American Surveyor. Oh, this is like the 3-peak triangulation. Yeah, I'm familiar with this. But this is the same problem. They're assuming the Earth is a globe in the first place. They're using like I said, all these measurements. At first glance, they seem like they're just measuring something, but they're doing something called reduction of the horizontal direction after the measurement, which calculates a different value than what's actually measured. So let's say I measure a 100-mile line of sight between the top peaks of mountains. We make a isosceles triangle, 100, 100, 100. Well, that's not going to be the arc length between those 2 points. I measured 100 miles.
I think they're
calculated 100 miles.
Peaks. They're using those mountain peaks because they're because you could see the 2 mountain peaks at that height.
Yeah.
Right.
Yeah, but okay, that's great. But the line of sight isn't the surface of the Earth. You understand that, right?
The sight is not the correct. Yeah. I see where this fell.
So how do you get that line of sight to the surface of the Earth? They do something called reduction of the horizontal direction. They project that planar triangle onto a reference ellipsoid and then use that arc length as the distance. So if I had a plane above a sphere and I took it and I just projected almost like a shadow, like say we have a triangle and we're just casting a shadow, the shadow cast on the sphere, if I measure the length, like with a string, of the projected shadow versus the actual triangle, the projected shadow's side lengths are going to be longer than the planar triangle. Because it's curved, right? So it's going to have a longer length. It's going to have an arc length. So that's what they're calculating. They're not actually measuring that. I was talking about an actual measurement. Like,
yeah,
what did
you're talking about like actually having something that's.
Yeah, the longest was like 7 miles.
Yeah.
It was done, I think it was done in India or something during their little survey. Though they used, directly measuring with a chain, I'll give them credit, man. That must have been a real pain in the ass. I wouldn't want to do it. We can leverage other
It would only
things,
really have
right?
value if you did both, right? If you did, like, if between those two mountains, if somehow you were able to get into like the center of those mountains, well, then it'd be hard to calculate that. But it'd only be if you could get towers or something with open feet on them, so you could lay down like a fishing line or something, I don't know, something that you could get with that amount of with a good distance on it, and do the visual surveying and carry the two, or carry the two together. Or would the visual knock it out of the realm of because it would still have to make the assumption of the curve? Because you'd have to have two tools, one that's on the ground, one that's above, right? Because you, like you said, that the triangle's above. I don't know how you'd make like a 7-mile long truss system or something to span that, to cast a shadow, to then run the physical measurement against the ground.
I mean, there's other things that we can do which are a lot simpler. I mean, like just measure the Earth, dude. It's simple. It doesn't take all this. Look, like I said, dude, it's like they have an idea what the Earth is. They go, fuck, dude. We need to make these measurements, and we're gonna assume that the Earth's a ball, and we're gonna take our measurements, we're gonna make it fit onto a ball, and that's just the way it is. It's what they keep doing. They could have picked something else. I mean, they just happened to pick a ball and they had their reasons for that, right? They go to the cult of Pythagoras and Plato, where it was an aesthetic reason, meaning they thought spheres were the perfect shape. That was the reason. It's what Copernicus says, what Plato says, what Pythagoras says. Well, maybe not Pythagoras himself. But Plato directly in the dialogues of Timaeus, and Copernicus directly in the revolutions of the heavenly bodies, say of all the shapes, the sphere is the most perfect. So quite naturally, the Earth must be a sphere. Does that sound scientific?
Repeatability sounds scientific to me. So the historical documentation leading to repeatability. But then I'm stuck now at your question of the measurement over the physical, but also having some type of a straight line that doesn't account for that remains straight, like the truss or the something else that remains perfectly straight.
Yeah, you'll hear this stuff all the time. You'll hear like things like spherical excess. Oh, surveyors measure spherical excess. They couldn't, because they're not on the surface of the Earth. They have a theodolite, a telescope, and they're looking out and they're looking at something else. In that place, let's say they got a telescope there too. So we got 3 points of a triangle. They all have telescopes, and they're all looking at each other. Those are all lines of sight. Yeah, they're not curved lines of sight, right? They form a planar triangle. And this is what's actually being measured. This is the device, the actual measuring device. What they're actually measured, they never measure greater than 180 degrees. It's not possible. So what they do is, because they think the Earth is a globe, they do a calculation. It's called reduction of the horizontal direction. They assume the Earth is whatever reference datum they're using. WGS 84, the bezel spheroid, the Clark ellipsoid. There's a couple other ones. There's a custom one they're using, frickin' Australia. They have like over 100 datums. So they just pick their datum, right? Which is their baseline, the horizontal. But, on a globe, the horizontal's curved. And they have to converge the plumb lines, right? Because they think that the plumb lines of each locations are tilted away from each other. Right, so they have to change everything. They have to do calculation. They change the measurement into a calculation, and just map it to a globe. It's not complicated. It's very simple to understand what's happening. And it's like, it's not devious because all the people doing it think the Earth's a globe. They're not trying to deceive anybody. They just actually think it's okay to do it. Now, the reduction of the horizontal direction means they're reducing the measurement to sea level, which is the geoid, which is something else than the reference ellipsoid. It seems complicated, but it's really not. Like I said, like the projection of the triangle, that's mapping it. That's the dropping it to sea level. Just think you have a triangle that's hovering above the surface of the Earth. You just drop it onto the Earth, right? And if the Earth's curved, then the triangle is going to wrap around it, and it's going to form a spherical triangle. Then if you went to each corner and measured the angle, it would be greater than 180 degrees. But that's not what they're measuring from the tops of mountains or even at sea level with theodolite. Even if the theodolite's 6 feet above sea level, they have to reduce it from 6 feet to sea level. Wonder how they mapped the frickin' Dead Sea. That's under sea level. Shouldn't the Dead Sea be like have concave plumb lines? Shouldn't it be a big divot? Ever seen images of Bolivian salt flats?
Yeah, I've seen images of it.
How is it that the reflection is not distorted and it's perfectly symmetrical?
Oh, the reflection's not.
The reflection, so you got the sky, right? A bunch of clouds in the sky. And then there's the reflection of the sky, a bunch of clouds reflecting in the water. And if you measure the distance between them, right, half of the halfway point, the horizon will cross through it, meaning it's symmetrical. It's a symmetrical reflection. That's impossible on a sphere. The reflection should look squished compared to the sky, right? Because A, there's more surface area, B, the rays of light diverge, and C, if the surface is curving down, then, you know, your angle to seeing that surface is going to compress it even more. But we don't see that. We don't see anything like that. We just see a perfect symmetrical reflection. If it was a convex mirror, it wouldn't look like that. You can run through the fucking AIs, the ChatGPTs, and Gemini. They all say the same thing. It's to certainly be visible on a 3,959-mile sphere, especially when the sun reaches, from your viewpoint, the horizon. You'd only see the sun. You wouldn't see the reflection of the sun. But we've all seen reflections of the sun in the water on the horizon. Because the sun only takes up half a degree. This, to me, is the strongest proof of flat Earth because there's no refraction, there's no gravity, there's none of these other confounding variables, possibly confounding variables. And you just have a reflection. You have the law of reflection, and that's it. You can just do the calculation. Should I see this? Should I see a symmetrical reflection? Answer is no, but we do. Now, the only argument against this is it's a flat spot, or Earth too biggy. But Earth too biggy is not actually valid. And it's a flat spot. I mean, if you say so. How many flat spots make a ball? Yeah, I love pictures of the Bolivian salt flat. It's so beautiful. I mean, literally, they should just like the Bolivian salt flat should be like a historic site or something, like one of those UNESCO sites.
Oh. You guys are a little silent.
I was just talking, man. I was just talking like 30 seconds ago. I've been talking for like an hour straight.
Oh, okay.
Okay, now I'm talking to you. What's up, bro?
I'm just chilling. I can't remember how to talk in English.
Oh, you came to talk in English?
Yeah?
What is the best story you've ever heard in English?
People generally don't talk to me, so I haven't heard a lot of stories in English.
Have you ever heard Jack and the Beanstalk?
Yeah, I have seen the cartoon.
Cartoon? Dude, you gotta read it,
Yeah.
man. It's a classic.
Oh, okay. I will
Fee, fi, fo,
someday.
fum. I smell the blood of
Okay.
an English mum.
Uh-huh.
Yeah, so let's look. If you want to learn English, the best thing to do is do what English children do, or American children. Read children's
What
books.
they do?
Read
Okay.
children. Will you
Oh.
read children's books?
Oh, but that's like really basic. I want to do something advanced.
Okay, like what?
Suggest me, like,
Can you
seems like
can you prove the Earth is a
you got
globe?
what?
Can you prove the Earth is a spinning space ball?
It is a spinning space ball.
Yes, globe. GLOBE, globe.
Actually, I cannot prove it. I mean, I have just seen it down to the pictures and in the movies and by saying of some scientists. So I cannot prove it personally.
Okay, good for you. I mean,
Yeah.
I appreciate that you're honest. A lot of people fight that. They just don't want to admit that they don't actually know. But thank you for being honest.
Yeah, you're welcome. Hmm.
I mean, I don't know how advanced you want to get in English. I mean, what are you trying to do, man?
I also don't know the purpose of learning English. I guess I can communicate well, but still,
I could teach you how to swear.
Oh, swear.
I could teach you how to swear. I can teach you idioms, cliches. Those are like things you would only learn if you were like a native English speaker.
Yeah, teach me.
Oh, what's a good
What's the good?
I don't know. It's hard to think of them. Like I have to be talking really to think of them.
Oh, okay. Where are you from? Are you American?
Yes, I'm American. Yeah.
Can you do the Donald Trump impression?
No. Don't make.
Oh,
What are you trying to do to me, man? Come on. Ugh.
His accent is really cool.
I don't do Donald Trump.
Oh, okay.
Why would you want me to do Donald Trump impression? Oh, gross. He's so man. He's a crazy person. I want to imitate a crazy person.
Oh, yeah, that's why.
He needs to be locked up somewhere.
He's a funny guy.
Yeah, he is in his own way, I guess.
And what do you think that where am I from?
What do I think you're from?
Somewhere in
Yeah.
Southeast Asia.
Okay, guess the country.
Oh, Jesus, that's a big choice. Let
Just
me
make a
think for
guess.
one. Let me think for 1 second.
Okay.
Malaysia, Nepal, or Indonesia?
You're pretty close, but not the exact one. Closer to Nepal.
Closer to Nepal. You're Tibetan?
No.
Indian?
Yeah.
Burmese?
And yes, I'm an Indian.
You're Indian. Oh, so you're Northern India. Are you Northern, Eastern?
Yeah, I'm Northern Indian.
So you're white.
Not white, but kind of like a coffee color.
Coffee color. I like that. I
Yeah,
like that.
the
Call it
milk.
coffee
The
color.
milk. Yeah, the milkish coffee.
The milk is coffee. Extra cream.
Yeah. Yeah.
We call that the Steph Curry.
The Steph Curry.
Yeah. Just call me curry color.
Man, I can't believe how dark some of the people in southern India are. They're dark. Like, jeez. They can be straight
Yeah.
out. Just their skin color is just really, really, really dark, man. Like, I swear
Yeah.
they're darker than some Africans.
Yeah, they might be Indian niggas.
Yeah, it could be.
Yeah.
So what do you do in northern India, dude? What do you do? Are you a student?
Oh. Yes, I'm a student doing the obvious thing, computer science engineering. What else I can do? I'm an Indian. Yeah.
Dude, you're gonna end up working in a call center trying to rip off my grandmother. So stop playing. I'm kidding, man.
It's fine.
Computer engineering, and hardware or software? You coding, writing code?
Yeah, it's software coding.
You know you're going to be obsolete. The AI is going to put you out of a job, man.
Yeah, that's why I'm doing cybersecurity. Previously, I was into the web development and then the machine learning and deep learning, and then I've shifted my branches to the cybersecurity.
Why can't the AI do that too?
There are a lot of AIs like Strix AI can find out the bugs in the machine and even can do the intrusion detection. But there are a lot of stuff in the cybersecurity. It's not even close.
You
It
do
hasn't put
network
its hand into
security or just network?
I'm just learning it. I've started it.
Oh, okay.
Yeah. I guess it's,
Well, I'm going to test you on IT security. What is the number one way people get into somebody else's computer or computer network? The number one way.
Through the IP address? I mean, I'm just beginner at cybersecurity.
No,
I just
no, no,
started
no,
learning
no,
it.
no, 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 no. It has nothing to do with a computer. Social engineering. They get people to tell them their password. They call them on the phone and say this, that, the other thing. It's the number one way. Social engineering.
Yeah, that's right. Okay, I guess it's a lot talking now, and it's been really nice talking to you. And I gotta go back to work now. And bye bye. Take care.
All right. Have fun at work.
Yeah, you too.
Yeah, Flat Earth is my job. Dude, just say Magellan. Jesus Christ, man.
Yeah, hello. What is that awkward silence?
We're all just thinking about how stupid the globe is. Who said that? Identify yourself.
Wasn't me.
The voice sounded familiar, like he's been in here before.
Why? What did he say?
He said, "What's up with all the silence?"
Oh, who said that? Was it you, Yon? Did you say that, Yon? Valley? Was it Valley? Come on. Who's the culprit? Own up.
No, I'm guessing KO, or I don't know how the hell you supposed to pronounce that, but I call you K.
Was it KO?
Yeah. Well, I'm just saying that because his mic is open. I don't know. We scared him off that easily. How disappointing.
What's that you posted there, Shane?
I'm sure it's something you guys have seen before, but I was just thinking more about the what Indio had proposed and trying to find something where it's gotten close to that type of thing, or at least where that's been tested, and running against the same kind of struggles that that he mentioned. Just a modern take on this, as everything was like 1700s or around then that I keep finding when it comes to like laying something, like having some type of a physical thing that you would span between two spaces, measure that distance, and then uh, um, see what the calculation would be. But it still doesn't get to his question of comparing that to a straight line above that span between that same distance that isn't on the ground, and then being able to compare. Now this one's just like they use like glass rods to measure the distance between two observatories, and then check that data against. Well, it's been. I mean, they keep doing the measurement, but they're checking the data against what the radius would be to account for what would be the straight line of sight versus the physical measurement. But I see so many
Did you say
problems.
glass rods?
Yeah. So they tried to do chains, but they kept changing in length with when it would get warm or cold, because it took them a very long time to span the English Channel. And so they ended up moving to glass rods because they had less variability.
Like linked glass rods? Like chained?
They were each a meter long. That's what I'm trying to figure out. Is like, how do they connect them together in order to not get back into the same situation of if they just had them touching each other? It would help if they would just have like photos of these damn rods.
So there's a bunch of like glass rods lying at the bottom of the channel, or what?
Let's see.
Or how did they use them?
Yeah, this is really weird to me. Manufactured, they're 20-foot links. Okay, so they're 20-foot links, 3 calibrated rods. Supported on trussels, and the ends aligned to the accuracy of 1/10 of a part of an inch. Whatever the hell I mean. So they did it almost like a leapfrog thing. So it wasn't it had to repeat it 1,370 times. So they had like 20-foot rods that they would then move one at a time across a trussel they had built to measure it. Or they are actually supported by trussel.
What?
So you had like two, almost like a sawhorse. I guess I'm trying to explain this to myself at the same time I'm explaining to you. but it sounds like they had almost like a sawhorse, and in order to support it as straight as they could, and then they'd set one down, then they would carry, then they'd set the next one down, touching in the end of that one, and then they would carry the first one forward to the next one, or to the other end of the second one.
It's almost as good as how they measured the depth of the ocean in the 1800s in flimsy little wooden ships. with tons of chain aboard or wire.
Come on, Globers. Defend the globe. Tell us how proud you are about the Artemis mission. They just touched down this evening, right? That's what they say. What about you, Princess? What about you, Valley?
I'm not a glober. foto Lebron, bebé.
Son extranjeros, playa.
Hi, nobody here. Hi. Hello.
No, pero todo el mundo está silenciado.
Oh, you listen, my friend. You're thinking you very clever, man, with your spinning ball and NASA plan. But in the earth, coming with their foot stand. अरे बाबा wait zoom कर दिया horizon straight no cover coming fully flat plate globe हैया now it's too late Indio 007 destroying the globe dreams 24/7 ever laser beam from 1111 sending curvature back to heaven hiding from me India smiling very calmly perspective only beta G Masegarabi crowding ocean spinning faster than emotion but water sitting without commotion hey where is your rotation gyroscope not even dancing airplane on at backwards glancing Glepiari slowly collapsing India 007 enhancing India sharp like kitchen churi weapon you bring CGI imagination he brings zoom lens demonstration Are bhai listen carefully Karvach hiding permanently refraction doing magic trickery but in the seen clearly pictures flying high but never ask the reason why NASA on thermal animation big rocket presentation but ground level observation giving you frustration Theodolite on tripod standing across the water expanding 6,000 feet misunderstanding globe argument disbanding Arey bhaiya check your calculation refraction variation of devastation to your spinning imagination India 007 sending globe to early heaven dreams collapsing flat horizon looking steady globe excuses always ready in the 007 heavy globe logic very spaghetti Indio 007
It's the email. What? The email. Hey, Strongbad, you like techno at all? If you do, what kind? Silent J. Oh, that's very clever. Well, it's not really my style, but I heard a techno song one time that went like, dum, 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 doom, doom, doom. And then this other part came in and it was like, doodle-up, doom, doodle-up, doom, doodle-up, doom, doodle-up, doom. And then there's always some kind of high-pitched noise, you know, or like a siren that's like, doodle-up, doom, doodle-up, doom, doodle-up, doom, doodle-up, doom. And of course they have to put in the obligatory old movie quote from some sci-fi movie. It's like, the system is down, doom, 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 doom. The system is down, doom, the system is down, doom, the system is down, doom. The cheat is grounded. We had that light switch installed for you so you could turn the lights on and off. Not so you could throw light switch raves. Now let's go break open that glow stick and pour it into Homestar Runner's Mountain Dew. I heard they have to pump your stomach when you drink that stuff.
Still nobody talking. It is. It is a very sad story.
Yeah, we're all sad that the Artemis 2 mission is over.
Yeah, I just heard on the radio. Next year they're going to do like a crude mission. I don't know if they meant like CRUDE, like or CREDWED. A crude mission to test docking and potential whatever this and that, blah 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 blah. Right, landing sites or something. I don't know. They plan to land with men there. Well, people, I should say, because they could be a woman. 2028.
Hello.
Yeah, I'm not holding up. I won't be holding my breath for that one. But all the anti-flat earthers think, oh, flat Earth is dead now. They sent a capsule around the moon. Except nobody can verify that. Nobody can verify there's actually people inside it.
It reminds me of when they finally got those astronauts who were stuck in space, right? They got them back, and they did the whole splashdown thing and everything. And dolphins came out to meet them, and like even though they were supposed to be like 30 minutes away, there was a chopper there immediately, and it was. And everybody, even the normies, criticized how like CGI it looked and set up and fake, all that, and pointed out things about their outfits and whatever, and the normies are doing that again this time as well. Like they're pointing out inconsistencies and errors and whatever, the fakery. The diehards, they're you can't sway them. Ones that they could literally do it in cartoon form and tell them it's real, and they believe it.
Well, how many minutes of live video did they record?
Well, it was supposed to be 10 days worth, but it wasn't.
Not that I watched it very much, but the only time I saw live video was about crew members talking inside the freaking capsule. Sorry, I'm not interested in listening to you morons talk. Tell me what's outside the window.
We were watching it there one day in here, and there was it was inside the capsule, and there was a couple of astronauts there, and then it faded out and quickly cut back, and they were gone, and this different lady was there in front of the camera with her big head and hair like in the camera, and yeah, it was like, how'd that happen? What happened there? I thought this was live and uncut. Like, what the heck?
Yeah, and I also find that they're using like this outdated equipment. Not that the Nikon D5 is a terrible piece of kit, but I get the feeling that the reason why they use these old types of cameras is because they've already learned how to crack the firmware on them. Whereas the newest versions might take them a little while before they can crack that firmware.
I think it's kind of funny how they try to make it seem to the normies like it's a little more realistic by saying, "Oh, it didn't go entirely smoothly. The toilet blocked up twice."
Well, you know, space toilets are an enigma for NASA. Like the new toilet they're using on the ISS, that one only cost $23 million to design and build. And apparently it's the same toilet on the ISS and on the Artemis too. And the high cost is due to specialized engineering required to operate in microgravity, including improved odor control and automatic startup shutdown sequences. I'm pretty sure if you gave it to some high school students, they would build it for like $2,300.
Filme que escolhesse uma mulher linda e abençoada. O que pode? Vem com a bola. A meia altura, Luan, facilita o trabalho do Gomes que mete a bola. Todo mundo virou zagueiro, canto de intermediária para.
Eu sou streamer, eu sou casada, eu não quero ouvir sua cantada. Se você for comentar que coroa linda.
Vocês viram isso aqui, pelo amor de Deus?
Eu sou streamer, eu sou casada, eu não quero ouvir sua cantada. Se você for comentar que coroa linda, gordinha linda, eu espero que você tenha diarreia até seu rabo explodir. Se você não gosta de mim, me bloqueia, porque daí eu não tenho trabalho de te bloquear. Se você me seguir, eu te sigo de volta. Eu sou streamer, eu sou casada, eu não quero ouvir sua cantada. Se você for comentar que coroa linda, gordinha linda, eu espero que você tenha diarreia até seu rabo explodir. Se você não gosta de mim, me bloqueia, porque daí eu não tenho trabalho de te bloquear. Se você me seguir, eu te sigo de volta. Eu sou streamer, eu sou casada, eu não quero ouvir sua cantada. Se você for comentar que coroa linda, gordinha linda, eu espero que você tenha diarreia até seu rabo explodir. Se você não gosta de mim, me bloqueia, porque daí eu não tenho trabalho de te bloquear. Se você me seguir, eu te sigo de volta. Eu sou streamer, eu sou casada, eu não quero ouvir sua cantada. Se você for comentar que coroa linda, gordinha linda, eu espero que você tenha diarreia até seu rabo explodir. Se você não gosta de mim, me bloqueia, porque daí eu não tenho trabalho de te bloquear. Se você me seguir, eu te sigo de
acting. That's called Snell's law, and that requires yeah, okay, so you were asking about gravity?
Yeah.
Yeah, gravity, as described by most people as mass attracting mass or space-time, right? One of those two things, they're to do with the globe. Okay, so you guys need to be able to explain your model. You need to be able to explain how you can have oceans sticking to the outside of a ball and that kind of thing. Okay, and how we can have gas pressure here on the Earth next to a big giant space vacuum without all of the gas, filling the available space of the vacuum. A whole bunch of reasons. Why don't you float off into space? How can we have water inside this big space vacuum? All these kinds of things. You guys need to have something to be able to explain all of these things that kind of defy what I would call logic and common sense and practical demonstration. So to have a globe, you have to have gravity, and to have gravity, you kind of have to have the globe as well. So it's something that's globe dependent. In reality, okay, in a flat, stationary, enclosed system, we don't need to have gravity in the same way that it would be necessary if the Earth were a globe.
So how does it work?
Well, it's very easy. It's very simple to explain as well. So if something is more dense than the air, then it's going to sink through the air. And if something's less dense than the air, it's going to rise, right? It's going to go up, like a helium balloon, for example. It's less dense than air, and it's going to go upward if you let go of a helium balloon. But if it was more dense than the air, it's going to sink downward because the air is a very light medium, so it doesn't have anything to support it. So if you drop a rock or something like that, it's just going to sink back to where you picked it up from, which is just downward.
Like, what's causing it to go downwards? Because when I drop something, the air is all around it. Why it's not going like up
Well,
or down?
it's because you picked it up. It was already down, and it never would have moved. Right? That whatever you picked up, it would have just stayed there, unless some outside force actually forces it out of its state of rest. So it's only going to drop because you picked it up. Okay, and you've given it potential energy, you've displaced it, and it's going to re-seek equilibrium based on its density.
So I gave it potential energy, which causes it to increase the energy. Since you're taking the example, since you're comparing it to equilibrium state, as I understand with equilibrium state, when a system or object is moved from its equilibrium state, it tries to get back to its equilibrium state. Okay, for example, a spring, when you stretch a spring, like when you stretch a spring and put potential energy into it, just like I picked up the stone and increased its potential energy. So the spring applies a force on itself to decrease that potential energy and get back to its equilibrium state. So in that context of stone, what's applying the force? Like, what's the force that's being applied on the rock? Like, in context of gravity, I could say the gravity is applying the force, but I wouldn't understand what would I say as a flat earther, you know?
Well, it's as using a spring as an example is just a false analogy, right? That's just one object. Okay,
But both are the examples of equilibrium state and potential energy. Why is it a false analogy?
Well, it's a false analogy. It doesn't compare. You could use the equilibrium state for different examples that aren't analogous to each other, like the spring. This is something falling through a medium, okay? And this is what we can do, okay? We can test this. Let's say we get an egg, and then we have a cup of water, fresh water, okay? And then we put the egg in the water. The egg's going to sink down to the bottom of the cup. Now, we can vary and manipulate the medium by changing the density of the medium. Now, that's the water. Now, if we add salt to the water, okay, now the egg is going to go upward. The egg went downward, and now all we've done is vary and manipulate the medium, and now all of a sudden the egg's going to go upward. Nothing's touching it. Nothing's forcing it. All you're doing is changing the medium, and then the object will behave differently.
So
that's the
what
only
is
thing.
density exactly? It's mass upon volume, right?
Well, no, I would say that the density is simply what the object is made out of. Okay, so whatever natural elements the object is comprised of is going to be what I would consider the density of the object.
How do you calculate the density of an object? Like by science, I would say we'll calculate the mass and then its volume, and then we'll divide these things like mass upon volume, and then we'll get the density. Is that not right?
Well, it just depends. I mean, you can do it any way that you choose to do it. I mean, if you have a ball of lead, okay, it's just a ball of lead. So you can try to calculate the density all you like, but it's just a ball of lead. I'm not trying to calculate the density of things. So I'm not needing to calculate the density of things. I'm just showing you
No, I'm not denying on the observation that we are experiencing. I agree with that, but I don't understand why it's happening. For example, as you said, the egg is denser than the water, so it's going down, right?
Yeah.
Density of egg is higher than density of water.
Correct.
And that difference in density is making it go down. But why? Like,
because it was lifted. Because it was lifted up and placed into
what
that.
Force is being applied on it? As like
force,
we know, the thing
so the force,
won't move unless we expand.
The force that displaced the object is what's being applied on the object, right? Like put it like this, right? Let's say I get a tennis ball and I have a fish tank of water. Okay, and just say there's like a ledge inside the fish tank under the water, and I push the tennis ball down under the ledge. Okay, now the tennis ball is under the ledge. I've forced it down there. That tennis ball has potential energy, right? And as soon as that tennis ball comes out from under that ledge, it's going to come back up to reseek equilibrium. It could stay down there for a week. Okay,
Well,
it's still that initial force. It's still that initial force that I applied to it.
But I can explain the force that's being applied for it to go up.
Yeah, it's the buoyant. It's because of the buoyancy.
Yeah, it's because of the buoyant force. The water is
the
trying
only
to go
reason
down.
the only reason it's going to happen, the only reason it's displaced is because I forced it down there in the first place.
Well, still, for it to come up again, there should be a force that should be applied on it to make it move from down to up after you left your hand and the ball is down in the aquarium or sink.
No, the initial force is the cause, right, of the
So
potential
are we
energy
saying
that the
something
ball
is
has.
moving without a force required for it to move?
Okay, so what do you think's pushing? What do you think's pushing? Do you think gravity is pushing the tennis ball upward through the water?
No, the thing I understand
Obviously
is
not.
this is what's happening there. So the water has more density than the tennis ball. Okay, so the gravity is pulling water down. The gravity is pulling water down where the ball is with the lesser density. So the water will try to push it up so that it could go down, and this is
Right.
called buoyant force. That's
On a
that's why it's
globe,
being pushed
if
up.
the Earth were a globe, then sure, you would need to have that buoyant force that has gravity in the equation. But in reality, we don't have a globe, and we don't have gravity, and we can easily debunk gravity. Easily.
But really, your explanation is going against basic laws of motion, Newton's laws of motion.
No, it's not going against laws of motion. It's going against the globe claims. It's going against the globe theory that claims gravity, that claims mass attracting mass, that claims a downward force or pseudo force. That's what it's going against. It's going against pseudoscience. It's going against pseudoscience is what it's going against. And we can easily debunk mass attracting mass. We can easily debunk that. That's been done thousands of times.
Okay, so according to Second's laws of motion, as far as I understand, at any instant of time, the net force on a body is equal to the body's acceleration multiplied by its mass or equal to the rate at which the body's momentum is changing in time, right? So there should be a force applied on the ball for it to accelerate from the rest state, which is down, to coming back up. What is that force? Is what I'm trying to understand.
The potential energy was the initial force that displaced the object. Potential energy. It's the same thing with the spring. Yeah, it's the only reason that the spring is going to move is because you pushed the spring down and compressed the spring.
But
if you didn't apply that initial force. Yeah, so there's an easy way we can just debunk this whole globe and gravity. Okay, so would you agree? Okay, so let's just debunk it really quickly. Okay, so gravity is pulling everything towards the center of the globe, right?
Yeah.
Okay, so that would mean that the water that covers over 70% of the globe would have to be curving at a specific rate because of gravity. Yeah, so if you have a large body of water, like a lake, for example, then it has to be curving at a certain rate, and we can calculate how much the water would be curving over a certain distance based off the radius of the Earth. Do you agree? Okay, so if that water is not curving, that would debunk the theory of mass attracting mass and everything being pulled towards the center of a globe. It would have to be happening if the Earth were a globe, right?
How would you test that water is not curving?
Very easily. There would be certain characteristics that would be visible over the surface of the water, right? That we can check very easily. Okay, because we have high-powered lasers, we have high-powered optics, zoom cameras, telescopes, radio wave signals, all sorts of light propagation, wave
But how
propagation
exactly?
technology. Okay, so firstly, just a simple observation. Okay, so we could find a 10-mile body of water, and then we could set up a camera, a high-powered zoom camera on one side of the body of water at a certain height. Let's say 1 meter high. And then we could have a target on the other side of the body of water, say 1 meter high. Okay, and if there's curvature there, okay, we can calculate that over that 10-mile distance, there would be 66.7 feet of curvature, which is about 22 meters of curvature. Okay, so you shouldn't be able to zoom in across that body of water with your camera and
The
see.
thing you're saying is that we can't see far after the curvature, right? Is that what you're saying?
Yeah. So what you should see is you could calculate the distance to how far the cutoff point is, which would be called the horizon. Okay, so the horizon would be at a certain distance based off the height of the observer. So if you have a 1 meter high observer, the horizon would be at 2.3 miles away, which is about 3.4 kilometers, I think.
Well, that's assuming Earth is a perfect square, right? Earth is not a perfect square, even in theory.
Yeah, but it would be approximately 2.3 miles, maybe 2.3. Yeah, so the Earth is so close to being a perfect sphere, you know, like it's basically a perfect sphere, except technically it's slightly off. So they call it an oblate spheroid, but it's only 0.33% off being a perfect sphere. So it's only a tiny little bit wider at the equator than the poles. Overall, right, on a grand scale, the drop over distance formula doesn't change enough that they even take that into consideration. So it's going to be approximately 2.3 miles from a 1 meter observation height anywhere on the Earth at any altitude on the Earth. It might change by like 1 point or something like that, 1 or 2 points, but it's just a point. Like it's not much, not enough to take into consideration. For example, if you take NASA's pictures of the Earth that they claim, and you put a perfect circle around them in Photoshop, it fits. But anyway, so we can do this observation, and we've done this observation over and over and over again. It's like it's been done probably thousands of times now. And we can not only see a little bit further than what we should be able to see on the globe, we can see only flatness, and we can see many thousands of percent further. Okay, so that water is absolutely not curving, and there's absolutely no evidence throughout all of history that the water is curving. No evidence that that's empirical. Maybe faith-based evidence if you want to trust NASA, for example. But that's not something you're going to be able to test. You're going to have to take their word for it. But when we test it in reality, there's no curvature. The water's not curving. And if the water's not curving, then the theory of mass attracting mass, or the bending and warping of space-time fabric, these theories are just theories. They're just concepts.
So even after, like, I believe that Earth is not curving, the water is not curving, that still doesn't explain why the stone is going down or the ball is going up. Like, I understand there's potential energy in the ball now, or in the stone, but what's the force that's being applied to the stone to for making it go down?
It's the initial force that's the displacing force.
Yeah, the initial force was me pushing it upwards, like pulling it upwards, right?
Yeah.
That made the stone left the ground. Okay. So when I stop applying that force, it should stay there.
No, it will sink because it's more dense than the medium.
And what's the force being applied on it?
You applied the force on it to displace it.
I'm not applying a force on it anymore.
Yeah, so it's got its own density. So it's able
density
to
is a property,
it's
it's not a force.
That's the property of the object. Okay, so the property of the object means that it's more dense than the surrounding medium, so it cannot be supported. It can't be supported by the surrounding medium, so it's going to sink through it. This is Archimedes' principle. It's called
Why is it going
specific
down
gravity.
though?
Archimedes came
Okay.
up with this. Have you not heard of Archimedes' principle?
I have heard of it. Again, as you said, I'm trying to understand here. Okay, the stone is surrounded by a lesser, denser medium, but it's also upwards, right side and left side. Why is it going down?
Why would it not go down? That's where you picked it up from. It never would have moved from where it originated unless something displaces it.
But like there should be a force
it has an original place. It has an original place of rest, right?
That's
Like
cool.
a
That's
rock.
fine. That's fine.
Yeah.
But as I said, according to second law of Newton's laws of motion, a body should only accelerate when there's a force being applied to it. I'm asking, what's the force that's being applied to it? When it's accelerating downwards. No, you don't understand. I think
you've applied
unable
the force.
to. Yes, I applied the force.
This is the thing. This is what it comes down to. Okay, you can just test. You can test what I'm claiming over and over again. Okay, if you're claiming, okay, so what do you think? Okay, let's switch it over to you. Okay, this is what it comes down to. Why is down down? Why is down down? And why is up up? Is that what you're really asking? Why are there two primary directions that things go?
No, I didn't ask that.
Okay, well that's what you're talking about. Why is it going down and not going up?
Well, because of your explanation, you're saying that it's surrounded by a low denser medium.
There are two primary directions. Do you agree with that?
You're just mocking me at this point.
No. There are two primary directions. You can test this very easily. If you drop something, it goes straight down. Right? If you have something that's less dense than the air, it goes straight up. It's never going to do anything other than go straight up or straight down if there's no extra forces at play. How is that mocking you? That's something that anyone can test. Okay, so if you have a incense, a stick of incense, and you put it in a room and there's no breeze. Okay, that smoke, what direction's the smoke going to go? Up. It's going to go up in a perfect straight line up. Okay, and if you drop something, let's say I'm in that same room and I pick something up and I drop it, which directions it's going to go straight down in a perfect line, straight down. Okay, that means that there's two primary directions, up and down.
I'm not denying that. Yeah, there are.
Well, you just said I was mocking you for suggesting it.
No,
like you agree.
You don't have to explain me directions. Is what I was trying to say.
Yeah, but we need to try to get to the bottom of this. Okay, so obviously something's going to go up or it's going to go down, right? It's not going to go any other direction.
Okay, so
you're asking me why is up up and why is down down? That's what you're asking.
No, I'm asking why it's going down. I'm not asking why down is down. I'm asking why it's going down. Why the stone is going down. I understand there's a difference in density between the stone and the air that's below it.
You're asking it assuming that you live on a globe and that you need to have a force because because you're in space. You're thinking that you're in space, in a big giant space vacuum.
Don't you think we have to have force for something to move?
You forced it. You applied the force. That's the only reason it moved. It never would have moved without you applying the force to it.
Do you know what? Do you know the three laws of motions that were introduced by Newton back in the days?
Yes.
First is law of inertia, that one thing won't move unless there's a force being applied to it. A body remains at rest or in the constant speed in straight line unless it is acted upon by a force, right? So when there's a stone at rest on the ground, I applied a force on it for it to make it move upwards up to a certain height.
Yep.
For it to move upwards, I had to apply a force on it, right? Okay, now second laws of motion states that an instant of time, the net force on a body is equal to the body's acceleration multiplied by its mass, or equivalent the rate at which the body's momentum is changing with time. Is that true or like not?
No, I think mass is a convoluted term, to be honest. Okay, yeah. Look, let's just get straight to the heart of the issue. You're claiming gravity. You're claiming gravity exists, and that's the reason, right?
No,
You're
I'm not claiming anything. I was saying,
Yeah, you are.
actually, the thing that happened
so
was
do you
yesterday I
believe?
was in a debate with Says who he was sitting in this VC. So I was talking to him, and I wanted to read more about it. So I asked him if there's a resource or something that I could look into. So he shared me a Discord link, and it had ton of YouTube videos and articles. So I looked into it, and as a truther, I would say, I looked at the arguments that contradicts that beliefs or claims. So while I was looking at it, that why Earth could not be a flat surface, um, gravity was the first thing that people mentioned. So to explain that, I was thinking what could explain that, but I couldn't come up with anything because
Archimedes' principle. So if we don't claim the Earth is a disk in space. Okay, we're not in space. We're not in a big space vacuum that doesn't have any specific directions. Okay, we're in a contained system where the Earth is the floor and the sky is the ceiling. Okay, we're in an enclosed system. There's only two primary directions, up and down. Okay, nobody knows why up is up or why down is down, but we can very easily demonstrate that things that are more dense than the surrounding medium will sink through them, and things that are less dense will rise. Okay, we don't need any magical force, mass attracting mass. That's a globe thing. Okay, and we debunked that easily doing countless amounts of long distance observations, laser transit tests, radio wave propagation tests, infrared photography of all distances. Okay, showing that there's no curvature. There's no curvature of the Earth. Okay, so when we go out and we do empirical evidence, all of your theoretical concepts, your mathematical constructs, these things, these pseudoscientific theories, they don't hold any weight against real-world empirical evidence that's testable, repeatable by anyone. You could go and do this yourself. So you can parrot textbooks all you like. Memorization and regurgitation of indoctrination is not really going to help you in this argument. So you can be really, really good at memorizing and regurgitating textbooks. Books are bullshit in many cases. Okay, but if
principle was part of what we read in textbooks.
Yeah, so Archimedes, yeah, that's why I said some. I didn't say all textbooks, did I?
And again, Archimedes' principle won't work without the force of gravity.
Oh, really? There's no G, right? There's no gravity in Archimedes' principle. No, there was no concept of gravity when he.
Why do you think the water that's down has more pressure than the water that's up?
Why do you think the water is flat? That's the question. If gravity is real, okay, we can go and test it.
It's flat on a smaller scale, is what I think.
No, it's flat on any scale, as far as we can test. Okay, so I can show you a test right now that shows you that there's hundreds of feet.
Smaller scale. Let's get back to stone first, because I am still not convinced, or I could say I'm still not understanding why the stone is going down.
Yeah, why is down? Okay, so just a moment ago, I said that there's two primary directions. Okay, you agreed with me. Okay, and then I said nobody knows why down is down and why up is up. Okay, when I drop something, why doesn't it go up? Why doesn't it stay still? Or why does it go down? Okay, nobody knows why there's two primary directions. Okay, down is down for every single person on the Earth. Up is up for every single person on the Earth, and it's the same direction. Someone in Australia can point up and someone in India can point up. They're both pointing the exact same direction. They're not pointing away from each other like you would be on a globe. Okay, so there's two primary directions. We have up and down. Nobody knows why down is down and why up is up, but we can easily do scientific experiments and show cause and effect relationship, showing that there's a density relationship with the medium and a displacement effect that causes things to rise or sink. That can be demonstrated over and over again. Okay, now what you're suggesting is something that requires the Earth to be a globe. It requires the water to be curving, and it requires a force of gravity.
What's your point exactly?
My point is that those things can have been debunked because we've gone out and tested the Earth over and over again over distances where there should be a huge amount of curvature, and there's never any curvature present. If there's no curvature present, the Earth cannot be a globe. That's the one thing.
My internet got disconnected for a second. What were you saying?
Yeah, so if there's no curvature, the Earth can't be a globe. It's very simple.
It could still be a sphere.
So what's the...
No, you can't. Well, hold on a second. I'll just answer this person's question. Okay, so it cannot be a sphere. If 70% of the surface of the sphere is claimed to be covered in water, and the water is all flat, then you can't have a sphere. If someone wants to try to draw me a picture of a sphere that has 70% of the surface covered in flat water, go ahead. I'd like to see what that artwork looks like. Go ahead, RK.
So what's the... If the second principle of Newton's laws of motion is wrong, then what's the correct one?
I'm falsification. No, I'm not even claiming they're entirely wrong. I just claimed how things work. Anyone can test and demonstrate and repeat what I've claimed.
Do you believe that
today.
Newton's laws of motions are right? Newtonian mechanics, is it right or not?
Okay, well, I don't know. Let's put it to the test. Does it mean the water should be curving?
It just means three simple things.
No, let me ask you. Does it mean the water should be curving? Yeah, most of the surface of the Earth is covered in water. So do Newton's laws mean that the water should be curving?
Why are we going back to water is not curving thing again and again?
Well, that's what this is. Okay, so you know what because that's what this argument is about. This is about whether the water is curving or not curving. Because that's what's required. Okay, so this is a flat Earth debate.
I understand that, but my question
so
was
you believe the Earth's a globe, and that requires the water to be curving. And if you want to claim gravity, then you need to have curving water. Okay, and I can prove to you.
Have curving water.
Can you? I understand that as I said, if I believe what you're saying is true, and I want to believe that, okay, what would cause the stone to fall down is what I'm asking.
I already explained it. I already explained it. Yeah, I already.
Down is down and up is up.
Yeah, I already explained that it was displaced, and then it's simply sinking by its own, what it's made of. Its own density is causing it to sink through the medium, only because you lift it up.
That's against the Newton's laws of motion.
Okay, well, if you're claiming that that's going against Newton's laws of motion, then that's wrong, isn't it?
Who says Newton's right?
So,
Newton didn't even say Newton was right. Newton said that he was anyone that believes in his theory of gravity lacks.
So are you saying Newton's laws of motion are wrong?
I didn't say anything about Newton. You seem
so if they are not right, if they are not wrong, then what they are? What are they?
I don't care.
It's just at the end of the day, it's still a theory.
Yeah, I don't care about Newton or Newton's laws. Okay, we go and test the Earth.
So we don't care about physics anymore.
No, I care about physics. I don't care about Newton's laws right now because we've gone out and tested the Earth and it's not curving. So whatever you think.
Archimedes' principles also uses laws of motion. Do you know that, right?
Okay, that's great. Things move. The water's not curving. You don't even want to see the tests. You're not interested in the truth. You're trying to get a little gotcha. Or something like that.
I'm just trying to understand it better.
Okay, so if the water is not curving, the Earth is not a globe.
Okay, it's not a globe. It's not a globe, okay? I agree with you there. It's not a globe.
All right, well, that's it. That we're done here.
No, we're not done. I still want to understand other phenomena like stone falling downwards or other things.
Yeah, I told you why something falls down. You didn't like the answer.
No, it's like against the basic physics is what I'm saying.
Oh, okay.
We do believe in physics, though, right? Even though
Yeah, like the
I
physics of
agree
water.
that Earth is
The
flat.
physics of like the physics of water, for example, fluid dynamics.
You just mentioned Archimedes' principle is the reason that the ball is going up or down.
No,
in
I
the
told you
water or air.
exactly. I told you exactly what it was. It was because it was displaced because the density is higher than the density of the surrounding medium. That's the reason. You don't like it because you've learned something else.
No.
Okay,
Let me just read.
this is.
It's not that I don't like it. Let
It
me
is
just.
because you don't like it. This is your
Let me just say.
You're coping
Let
right
me just
now.
say.
Is what you're doing.
No, it's not. Okay.
It
So
is.
you said that the difference between the density is causing the movement of stone from up to down, right?
Yeah. No, I said the cause is whatever the energy was that displaced or forced the rock out of equilibrium. Okay, and then it's simply going to reseek equilibrium due to the density
Without
of the
any
rock.
force on it.
The
Like there's
force was
no force being applied on it, right?
the force was already applied. Yeah, there was a force applied.
Well, that's against just basic physics. How do I explain
Oh,
that?
okay. Well, your basic physics that you're talking about thinks that the Earth is a globe, right? And that water's bending around a ball that's spinning at millions of miles per hour through outer space. Cool. So yeah, maybe your textbooks are just information that you've learned how to regurgitate, and you think that that makes you smart because you're able to parrot information that you learned.
Is there a research paper or something that I could read about the density difference? That's
Go read up on Archimedes' principle.
Archimedes' principle requires Newton's laws of motion, and your theory
No, it
is
doesn't.
directly going
It
against.
doesn't.
It does.
No, it doesn't have anything to do with anything about Newton. Okay, so he's from BC.
Okay.
Archimedes is from BC. Okay, do you think he was writing anything of Newton?
So do you think that knowledge doesn't carry forward to the future? Okay, let me just. Should I screen share? Can I screen share?
Mm-mm.
Okay.
Nobody can screen share.
Oh shit! Okay. The Archimedes principle that explains the buoyancy force, right? Right. The formula of it is force of buoyancy is equals to rho g and v. That's rho is density of the fluid.
What's the G?
G is acceleration due to gravity.
No, gravity. Okay, that's not in the original Archimedes principle formulas. It's not there. Okay, because this guy was from the BC. He didn't believe in gravity. Newton didn't exist then. Okay, remember Newton discovered gravity when the apple fell on his head or something like that? Right? So it's been modified in modern times to fit the globe narrative. The ball in outer space, which we can debunk very easily. Archimedes' principle didn't have anything to do. Didn't have a G. Go look it up, bro. I gave you the basic, testable, repeatable description of what it is. If you want to go into more detail about it, go and learn about it. I'm not going to teach it to you here right now, and I probably can't even get in to the specifics of the actual formulas that Archimedes used. Okay, but it's simple enough. Okay, that you can test it right now with an egg and a cup of water and a bag of salt, like I explained to you, and you're going to get the same result every time. You could set it up using. Okay, so why anything falls or rises in nature can be easily explained using this principle. And you're not going to be able to give me a single example in nature that goes against it.
Okay.
Okay.
Fair enough. Okay, the next question was, as I said, I had a few questions, right?
Mm-hmm.
So first thing was about gravity. Okay, I understood that. Second was seasons and days and nights. How would I explain that as a flat?
Okay, so we would say that the sun is not 93 million miles away. It's much closer to the Earth. It appears much smaller than the Earth, as does the moon. Okay, and that we see the sun moving across the sky. Okay, and it moves in particular cycles that reset each year. And that's what creates daytime, nighttime, and the seasons. Okay, so we live within a completely different system than what you're thinking about. Okay, try not to insert the flat Earth inside the globe model, inside the heliocentric model of the universe with a 93 million mile away sun and planets and a big vacuum. Okay, try not to incorporate flat Earth into that system. It's not compatible. It's a completely different way of thinking about this. So we would say the sun is much more local than what we're told. It's much smaller than what we're told. It takes a particular circuit, you could call it, I guess, a particular cycle. Just like all of the other, things in the sky, the moon, the planets, the stars, right? Everything is like a big clock in the sky. It moves in cycles. It's responsible for seasons, daytime, nighttime, all sorts of things.
I think we are denying a large part of physics here, especially since we denied the truthfulness of Newton's laws of motion.
No, I didn't deny anything. I just told you that when we go out in reality,
well, they are two contradicting
there's
things.
no curvature.
If one is true,
okay, so Newton's the same person that says that the water should be curving, right? Because of gravity, yeah?
Newton simply said there needs to be a force for things to move. And since I was asking,
okay, well,
the original question was why.
Newton also said that the water's curving because of gravity. So obviously, we can't take everything Newton says seriously.
Yeah, because the water's not.
What part of what he said can we take seriously?
Yeah, hold on. Eternal was trying to say something. Eternal, what did you want to say?
No, I just wanted to say the water's not curving.
Yeah, the water's not curving. That's correct.
Yeah, so you said that we can't take everything seriously what the Newton says, right? So what part can we actually take serious? Because he's a physicist after all. So if you are actually...
I don't know. It doesn't matter. It doesn't matter. You can take seriously
what... It does.
No, it doesn't. Because at the end of the day, when we go out and test the Earth, it's not curving. That's what this conversation is about. It's not digging into every single thing that Newton said and trying to work out which is true and which is untrue.
Then I don't think we can explain why the stone is falling down, because there's no force being applied and without contradicting Newton's laws of motion.
Okay, well, you can test what I said, and it's gonna work every single time. What do you think? What do you think's the reason
with
that
gravity?
So with gravity, the same gravity that would be causing the water to be curved, that's not curved.
I can convince you there. I can't convince on that.
Okay, well, that would debunk gravity, wouldn't it? That would debunk gravity, right?
That would debunk gravity. Then that same thing would debunk the Newton's laws of motion, which is the very basics of physics.
Okay,
and that would debunk the whole physics then altogether.
Okay, well,
so
I have empirical evidence.
Physics anymore?
No. We're believing in measurements and reality. We're not believing in science, pseudoscience. So I have tests, empirical tests that I can show you that the water is not curving, but you don't even want to see them. You don't even want to see them because you're not intellectually honest. No, you haven't.
I was investing my whole day since yesterday about this.
Yeah, you've never seen any of the tests. You've never seen.
I have the laser test you were talking about.
When did I mention a laser test?
You did.
I wasn't going to present a laser test.
You did a while ago. You did. You did mention laser. Okay, think you're fair enough.
Okay, I mentioned laser tests. No, I mentioned laser tests. Okay, but I wasn't going to present that. Okay, you haven't seen all the tests. You might have seen one or two tests. And in the test you did see, was there any evidence that the Earth is curving?
Well, I also saw a lot of tests that showed Earth is curving.
Okay, which test showed the Earth is curving?
Part of it was the ship sinking down when it crosses the horizon. But you'll just say it's refraction.
What's the horizon?
It's the end point that we can see with naked eyes.
Yeah, due to the curvature of the Earth. Is it a byproduct of the curvature?
Yeah, it is.
Yeah, now we're getting somewhere. Now I like the way the conversation's going. So we can calculate the distance.
But then
you don't like this because now we're talking about reality.
No, we are going on a bigger scale. I want to start from a smaller scale and go there. Okay, continue. You should continue.
No. This is the thing now. We're up to talking about horizons and long distance observations.
Mm-hmm.
So you said that the water's curving, and you're saying that the horizon is a byproduct of the Earth curvature.
Mm-hmm.
Do you have any evidence to support that claim?
Simple observation that when the ships go towards the horizon, and then when they cross the horizon, the bottom part starts to disappear.
Okay. Do you have an example to present that has the variables taken into account?
An example, how would I present? I could present a video.
Well, you made the claim. Yeah, well, you posted in the side chat. You go in the side chat. Control C,
Video
Control
of
V.
it?
Well, you're the one making the claim. Now I'm asking you to support your claim, so we have a side chat where you can post information.
Wait, let me see.
Because we can show things disappearing bottom up on a small scale over a flat surface. Okay, and mainstream optics of light, okay, subject matter experts in optics, okay, they say that things can appear to disappear bottom up, and it's not due to curvature. Okay, it's due to the propagation of light through a medium. This is mainstream.
Okay, show me the document that I
about.
could read about, because I could understand the thing that you said. I understand the phenomenon that's causing it, but how it's causing it, I don't understand.
How do you understand? Okay, so what's causing it? Tell me. If you think you understand it, tell me what's
I
causing
understand
it
the
and what's the meaning of it. I think
the
you don't
propagation of light
understand
is
it.
causing it. You
Okay,
just
so
said the
how?
propagation of light is causing it. For me to better
Okay.
understand the phenomenon, I
Can you
have
get
to read
into a
about
little more
it.
detail? Okay, so you don't understand it. Just the propagation of light. So now you agree that things can appear to disappear bottom up due to the propagation of light, and it's not physically obstructed. It's just apparently obstructed. So you agree with that now?
Can you repeat yourself again? I was so
okay. So you said things disappearing bottom up is your evidence that there's Earth curvature. Okay, things that are beyond the horizon.
Yeah.
Yeah. Okay. Now you're agreeing that it can happen due to the propagation of light.
No, I'm not agreeing to that. I'm saying as you said that, and I want to read why it's happening or how it's happening due to the propagation of light.
All right.
So what can I read about that, and where can I read about that? That's what I was asking.
Okay,
Is there a resource that I could read?
Yeah. I'm going to drop some citations with links to the original source in the side chat. We can go over them right now. Okay, so just give me a second. I'll just find it.
But explain exactly how Earth is flat, because look at the professor in chat.
Yeah, you go outside and you pay attention to the surface, of the Earth. You just got to ask yourself one question: that when I go outside and make observations, does the surface of the Earth curve at all? If it curves, then yeah, the Earth is a globe. But if it doesn't curve, then how can the Earth be a globe? If you find no curvature.
I sent proof that's.
I did make some observations, and
No, I'm
apparently we don't believe
getting
in physics anymore.
Yeah, so I'm just getting you some citations. So just give me a second.
Yeah. See, curvature is a big deal to justify the globe. You just got to find the curvature, and the Earth is a globe. If you find no curvature, how can the Earth be a globe? Because curvature is a big deal. You do realize that, yeah? When they show you the globe, it's a ball, it's a sphere, yeah? It's an oblate spheroid. The surface has curvature. Curvature is a big deal. And if there is no curvature, how can the Earth be a globe? It's very simple.
All right, so we have exactly great point, T. Yeah, spot on. Okay, so
I think we are cherry picking the physics at this point.
Yeah. So
we believe
no, we're not denying any
but
physics. We're talking about the physics. We're talking about light propagation right now, and you wanted some material by the mainstream, okay, that can explain things appearing to disappear bottom up, but not actually being physically obstructed. Okay, so first we have Oxford Dictionary of Weather. Okay, sinking. This is called sinking, which is a type of low-level inferior mirage. Okay, so here's Oxford reference. A refraction effect in which an object normally visible... You listening?
Wait. It requires me to sign in first to read the actual paper.
Yeah, we've got citations right here that cut straight to the point.
Refraction effect is on which an object normally visible on geographical horizon and endless things beneath it.
Yeah, so I'm going to read them out for you and for the audience that's listening on YouTube and in the channel right now. Okay, so
Live?
syncing.
That's good.
But why would NASA lie to us
Eternal, you
about
got like Eternal, you got
Earth.
like background noise. I don't know why would the government or agencies lie? I have no idea. I think most people aren't lying. Most people genuinely believe that the Earth's a globe. But Eternal, you got like background noises when you're not talking.
That's not me. That's our guy, whatever his name is.
No, that's Arcade's trying to read stuff at the moment. But you got like some. You on a headset or something? I guarantee if I'm. It's okay at the moment. Okay, so Oxford reference. Okay, so syncing is a refraction effect in which an object normally visible on the geographical horizon apparently sinks beneath it. Okay, so it's not actually sinking beneath the horizon. Okay, even though it's appearing to be behind the horizon partially, it's not actually. It's just apparently. Okay, and this is an effect which under the mainstream is classed as atmospheric refraction. Okay, it's a type of miraging effect. It's like a low-level inferior mirage, where you have a layer of warmer air down lower and cooler air above it. And as the light comes back off the object towards the observer, it's going to deviate upward towards the cooler portion of the medium, because the cooler portion of the medium has a higher refractive index. Okay, and it's going to cause the object in the distance to look like it's sinking. That's why it's called sinking. Okay, and then we have Andrew Thomas Young. Okay, he's like the subject matter expert on optics of the atmosphere. This is from Optics of the Atmosphere, Reports in Progress in Physics. Okay, it's got the page numbers there. It says atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. Okay, just like the boats over the horizon claim in some cases. Okay, then we got Perkins, David, and atmospheric refraction in geodetic and astronomical observations, surveys in geophysics. Refraction is caused by temperature gradients near Earth's surface. This causes distant land, sea, or urban features to appear distorted or partially visible when they would otherwise be fully visible in the absence of non-such uniform atmospheric conditions. Okay, you could even go on Google right now and type in what is sinking refraction. It's going to say exactly what Oxford reference said up at the top there. It's going to say things look like they're sinking, but they're not actually hidden behind anything. Okay, other times we can have ocean swells, which are waves out in the ocean, that can also make things look like they appear to be disappearing bottom up. We can replicate both of these effects that I just mentioned on a small scale on a flat surface. Over and over again, happens every single time. You put the right conditions there, and this happens every single time. So if someone wants to make a claim that a horizon and something that is beyond the horizon is partially obstructed is because of the curvature of the Earth, they're going to have to take these things into account first, and they're going to have to account for these variables to make sure that these things aren't causing what they're seeing in the distance, and that it is actually the curvature of the Earth.
Okay.
Okay, but if I were to go up to the moon, take a picture of our Earth, would you believe it?
Yeah, sure, but that's not going to happen, unfortunately. Even NASA, when interviewed recently, okay, they were asked, how come NASA doesn't go back to the moon? NASA said, we'd go back to the moon in a nanosecond, but we destroyed that technology, and it would be a painful process to build it back.
And I bet that's a lie.
Well, that's what NASA said.
But who's saying they're not working with the government, saying that's...
NASA is the government. In fact, NASA has just been reclassified as an intelligence agency. similar to the CIA or FBI, for example. Right? They can blatantly just lie to people with no
So that's
repercussions.
exactly why. Yeah. So then,
So we
like, the
can't.
entire
All I'm
thing.
saying is that we can't like go to the moon ourselves and take a picture of the Earth to confirm this. We have to have faith in this intelligence agency called NASA, with the pictures that we're showing us. And then when we see the pictures that they're showing us, and we say, "Hey, look, that water is curving in the picture." Then when we go out and test the water in reality, it's not curving. We have a problem.
We don't know who to believe.
So can I get
the
back
water's
to the
not lying.
reflection part?
Yeah.
Yeah. Can I just quickly ask one question? Is that okay?
Yeah, of course, bro.
Sure,
Go ahead.
Sure.
Yeah. Many times I heard people say, "Why are they lying? Why are they lying? Yeah, why governments and scientists are lying?" Look, my point is, yeah, you don't need to question if they're lying or not. You just need to test their claim. That's it, to know if they're lying or not. Do you understand? You don't need to go directly to them and ask them if they're lying. You can test it, like whatever they're saying, their claim. You can test it yourself in reality.
Yeah, and if I could just back that up, sorry to cut you off there, let me just back that up. Once you've discovered that lie, then it's upon you as to what actions you take. Okay? You know, you have to work it out for yourself.
I agree. Government lies about a lot of stuff you don't even know.
Yeah, I know. We agree. We can all agree on that. We can all agree on that. So, RK, did you have a look over the citations that I put in the side chat?
So I understand the refraction is causing the light of the ray of light to bend upwards.
Correct.
But when I read more about refraction, the light bends because when it moves from a lower density medium to a higher density, to the change in medium, basically.
Well, not really.
So,
that would be referring more to Snell's law, which is the law of refraction, which is depends on a specific situation where you have two different mediums and then you have a sharp boundary layer, kind of like that experiment where you can put a pencil into a glass of water and you can see the pencil is refracting. That's called Snell's law. And that requires two separate mediums. That doesn't apply to a single medium, which is the atmosphere. Okay, the atmosphere and Snell's law, right, they don't go together because you only have a single medium with a gradient rather than two separate mediums with a sharp boundary layer. So you get that kind of like it looks like a bend kind of thing in the pencil when you put the pencil into the water. So for Snell's law, you need a specific situation where you have two separate isotropic media with a sharp boundary layer, and then you need as the object, as the light travels from one medium into the other medium, it's going to deviate towards the medium that's more dense.
But Snell's law can work on a gradient atmosphere as well.
No, you would have to use a differential. You would have to use a differential form.
Using differential.
Yeah, but that does, you're not able to use the differential form of Snell's law in the real world observations because in the real world everything's changing constantly. So you could use the differential form of Snell's law in a lab setting or in a classroom setting or something like that where you had extremely controlled conditions where you have a constant gradient, right, that stays the same. Then you could use the differential form of Snell's law. But that doesn't apply when you're out in nature doing observations because everything's changing. You've got constant shifting of temperatures, pressures, humidity, winds, all sorts of things are taking place. So you're not going to be able to accurately make a calculation using any form of Snell's law through the atmosphere. What you have in the atmosphere... do you have any problem?
Talking about calculations, but actually the direction of the refraction, because since we are on the ocean, above the ocean, the air is actually, it should refract as per the Snell's or gradient Snell's law, using the
no.
You see, I have a question. I do have a question. And the question is this.
Bend the light way downwards, actually.
Yeah, well, hang on. There's a question that has to be asked here because we're talking about the air. As my colleague has informed you, it's constantly in flux. The gases are in flux. So whilst that's going on, can an object, like in the Black Swan, we have the two oil rigs, can they be lifted from behind a curve up to where I can see them over 10 miles? There's a question there for you already, because that's what you're asking us to accept, that refraction is happening at such a rate and it's continuous that it's able to pick up an oil rig from behind the curve that you're supposed to be living on, that ball, and it's lifting it up so I can sit, and it's keeping it there, and I can stand there for 2, 3, 4, 5, 6, 7, 8, 9, 10 hours still seeing that same thing. What kind of refraction can do that?
Well, yeah, hold that thought, Jin, because that's a great point. But at the moment, we're talking about refraction in relation to what this guy was saying, is that because sometimes we can see things like boats and things like that, they look like they're hidden bottom up. Okay, and then he said that that's proof that the Earth's a globe, because things can appear like their bottom portion of them isn't visible behind the horizon. And I was bringing up some citations showing that there's actually, according to the mainstream, there's effects called sinking that can explain that things that look like they're disappearing bottom up are actually geometrically unobstructed, even according to the mainstream. So you can have like a boat or an oil platform or something like that where you can't see the bottom portion of it behind the horizon. Okay, and even according to the mainstream, that doesn't mean that it's hidden behind the curvature. So then I just shared him some citations where Andrew Thomas Young and Oxford and a bunch of places explain how that works. And then he's looked into that, and now he's trying to wrap his head around that.
Yeah. There's another test he can do. There are two, very quickly, short tests. One is when you're on the streets, walking on the pavement, and you're approaching a manhole cover. That cover, when you don't see it, suddenly something oval shape is appearing on the pavement. And as you approach it, that oval changes and changes as the angle to which you're seeing it at is changing. And suddenly, when you're right on it, it's a full circle. When you back off from it, it starts to change, right? And then you'll get to a point where you'll no longer see that manhole cover, and yet you're on the pavement and it's level. And another one is in a basketball court, where you can take your mobile phone and you place it face down under the basketball net. Walk to the other side of the court where the other net is, lie down, and you won't see your phone. And you're just lying down. You won't see it because the level surface has obstructed. That's not refraction, is it? That's a level surface obstructing what you put down on the floor. It's not until you create an angle at which you can sit. And when you do create that angle, you're seeing your phone as a slither, just a white sliver on the ground. But then when you walk towards it, that sliver changes eventually to the rectangle when you're right above it 90 degrees. So level surfaces can indeed obstruct, and that would include the ocean. I'll stop there. Very good work you're doing there, by the way. Thank you.
We can still see the height of the phone while lying down on the basketball court.
Just the height of what?
He said I should put my phone at the one end of basketball court, right?
Yes.
And then go back to the other end of the basketball court, lie down with my eyes.
Yeah. You won't see your phone.
In line with the flat. I would see the height of the phone.
No, you will not. You will not see. No, you will not see your phone when you're lying down. You will need to get onto your knees before you see your phone.
I would see so you're saying there's no depth in
Have you actually? Hang on. Have you actually conducted that test? Have you done that? No. So go and do it
right now in my room.
I'm wrong. Go and
in your room.
do
it's
it,
not going to
and
be
then
long
say
enough.
I'm wrong. Don't tell me. Yeah, that's silly. Go and check it out.
It's not going to be long enough of a distance in your room. So what can happen is that it's very difficult.
Okay, so I can use telescope to actually see my phone at least. Telescope or some kind of magnifying.
Look. What my point I'm trying to raise to you, young man, is that a level surface can obscure what you're looking at, and that's one example. Wait a minute, don't interrupt me because you're not listening and you're just fighting. Don't fight me. Just listen. When you go to the basketball court, put your phone down under the net. walk to the other side of the court, lie down, and you will not see your phone. Please do that. You haven't done it yet. So don't be telling me no, 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 no. Go and do it first. Then come and tell me I'm wrong. Thank you.
Yeah, thank you for your input. And coming back to the reflection part, can we agree that reflection is caused because of difference in the mediums?
Yeah, so it's caused by the change in the refractive index of the medium, which is primarily controlled by temperature, and the light's going to deviate towards the denser portion of the medium if it's a single medium. Okay, so if you have cooler air down lower, the light's going to bend down towards the cooler air, and if you have cooler air up higher, then the light's going to bend up towards the cooler air. Each one's going to have the opposite effect of each other. This is called looming and sinking.
Exactly. So when we were talking about the ship sinking, you're saying the higher air is colder, right?
No, it depends. It depends if the heat flux is up or down. So it depends. Sometimes, let's say you have 20-degree ocean water, for example, and you have 10-degree air. Okay, so the warm water of the ocean is going to create a warmer layer of air just above the surface of the water. And then there's going to be a gradient. It's going to get cooler as you go up vertically. Okay, so in that situation, you would have the sinking effect. Okay, and if you had the opposite effect, say you have 20-degree air and 10-degree water, then you're going to have the opposite. You could get a little bit of looming. Okay, and it's only a small difference in the refractive index, a very, very tiny difference, but it's enough to cause these optical effects in the distance. Okay, and we can replicate it on a small scale. We can get a flat floor, right, like in someone's house, and we can manipulate the temperatures, and we can make it look like something disappears behind the horizon on the flat floor. Okay, obviously it's not disappearing behind the curvature. It's just appearing to become obstructed because of the temperature, the pressure, and the humidity.
I see.
Yeah, it's called sinking.
And then in the basketball court, that's called it's an obstruction because of the distance you are and the angle you are trying to look at the object at. This is why it's being obstructed. So what the point we're trying to make to you is that one cannot claim refraction when you're seeing an object at 10 miles, 20 miles, 30 miles. And if you stay there for several hours, it's still there. What kind of refraction is that? That is perfectly set, and it doesn't. We all know that air changes all the time. So there must come a point where I can sit and there's no refraction going on. So you've got to work that out. That's why to claim refraction is really a very poor and weak argument, because the refraction levels are minuscule. They're not able to pick up an object 20 miles away and lift it up so I can see it. So that goes against the laws of nature straight off the bat. So, you're going to have to go out and do some more tests to find out, measure curvature is what you have to do. Measure that curve. And you're not doing that because Earth is measured flat anyway. We know that.
Are you there, RK?
Yeah, I'm reading more into it. Just a sec.
Okay, can you have a look in the side chat? I'll show you a real-world example of what I was talking about with the sinking. Can you see the side chat?
I saw an image that you just shared.
Yeah, there's a boat. Okay, that's a big giant container ship. It's called the Mandarin Arrow. Okay, so that's the ship that's going to be present in this observation. So this guy went to the beach in the morning and he was able to spot that ship. Okay, that ship was anchored out in the ocean, and here is the screenshot from the ship tracking radar. Okay, so it says that it's anchored and it's 12.4 nautical miles out to sea, which is about just over 14 miles away. So he sets his camera up in the morning at the shoreline, and when he zooms in on the ship, it looks like most of the bottom of the ship is hidden behind the horizon. Can you see this next image that I posted?
Yeah.
Okay, so here's an even closer zoom. Okay, so we can only see the little top bit of the ship. We can't. The whole bottom of the ship looks like it's behind the horizon. Okay, this is the kind of thing people are talking about when they say, "Oh, ships disappear bottom up." Okay, because sometimes we see this effect. Now, if you look closely at that image, you can actually see a mirroring effect right where the horizon and the sky meet, and you can actually see sky, what looks like sky, at the base of the ship. Okay, between the ship and the ocean water. Now, what he did was he actually stayed in that location for the next 3 hours. And he kept zooming in on that ship. Now, what happened was over the next 3 hours, more and more of the ship started to become revealed. Even though the ship wasn't moving, it was anchored, the weather conditions started to change. The temperature of the air started to warm up, and the sinking effect started to go away. Now, 3 hours later, he could see the whole ship 14 miles out. Okay, so this here is the same location. Okay, the same day, the same person, just 3 hours later. Okay, so 3 hours later, we can see the whole ship. Right, there's none of the ship missing now. Showing that what was happening in the morning wasn't actually the ship hidden behind the horizon. It was just an effect that was taking place because of the weather conditions. And it makes logical sense because what happens is the air temperature cools down during the night. The water temperature doesn't cool down during the night. It stays pretty much the same. It might cool down a tiny bit, but the air is always going to get much cooler, especially in some locations. It'll get really cold during the night, but the water will still be warm. Okay, so in the morning when he got to the beach, it hasn't heated up yet. Okay, it's still cold. It's still a cold day. So the water's still warm, and it's creating that warmer layer of air down lower, which has a lower refractive index. And then you've got the cooler air above it. It's going to cause the sinking effect to take place. Now, as the air temperature above the layer of warmer air above the water, as the air temperature surpassed the sea temperature, that sinking effect went away. Okay, so 3 hours later, when we have a much warmer temperature, now the sun's out, it's the middle of the day, and now all of a sudden he can zoom in, he can see the entire ship. Okay, this is showing that the ship wasn't actually hidden behind the curvature of the Earth. It was just what you saw in the citations, right? It matches sinking perfectly. It matches the definition of sinking perfectly. So what I'm saying is most often when you think you can see a ship disappearing over the horizon or something like that, or something that's obstructed bottom up, you need to take these things into account. If you want to claim that it's because of the Earth curvature, right, you need to dismiss this possibility, and then also obviously the possibility of ocean swells as well. Because ocean swells.
So DJ, it's important to point out that this phenomenon never seems to happen where people think it should if Earth is a globe either.
Oh, yeah, that's a great point, actually. Yes, so the horizon should appear closer than it would be geometrically, right? If you had this essentially like negative refraction coefficient.
Yeah, that's why I was mentioning the black swan and that, and 10 miles away you're seeing objects that cannot be lifted up from. That's impossible. That's just not happening. So this is why we call it into question when they keep saying refraction. What type of refraction are they referring to? And then when we're talking about units of miles, one nautical mile or one statute mile, that is a horizontal linear measurement of a distance. It's not curving. You're not measuring curve there. 1 mile is not curved. It's a straight linear. Has to be. Because as we've said before, Earth is measured flat. And in order for you to determine whether or not Earth is deviating, either convex or concave, you need a horizontal baseline to establish first. This is what we're doing with the miles now. 1 mile straight horizontal. And when you extend it, we find that Earth isn't curving. That's what we flat earthers are finding. We're finding constant horizontality. we're not finding the curvature there using the standard statute mile or nautical mile, or if you want to use your kilometers as well. These are linear measurements. They're not curved. Okay? Now you can get a piece of string and wrap it around the ball, but then you're still going to have to lay it down flat to get the actual measurements correctly. We don't have curved miles everywhere, in the sense of measuring, that is. Oh, yeah, well, so TW done a good job there. Oh, no, that's DJ, sorry. Yeah, DJ, you done a good job there. I thoroughly enjoyed what you were doing. The young man hopefully will have some more food for thought, and so do the listeners now, you know, because refraction's often claimed, you know, 9 times out of 10, they're going to claim refraction. And then they have to determine what refraction is that, and then they're going to have to calculate the air quality, the temperature, density, the gases. They've got to do that to prove to us that's what's going on. It's an impossibility, ladies and gentlemen. It's like your fingerprints. The air is similar, constantly changing. You can't measure that. Sorry.
Great point.
Very, very. Yeah. Go ahead.
So when they say refraction is their worst nightmare. As soon as they bring it up, they're done. All of their bottom-up disappearance observations, right? If that wasn't accounted for, that could be what's happening, right? And a refraction effect causing things to appear to sink. Okay, that's an invalid observation now. It's inconclusive, unless they wanted to try to do the impossible and calculate exactly what's going on between point A and point B.
Yeah.
With the refractive index.
It's an impossibility to do that. It's just not.
Well, they could get a rough idea.
And like I've said,
Oh, go ahead.
I was just going to say, I, as an ex-military man myself, if I had the opportunity to use a weapon, I say to you, get your target down there, set it up. I will hit it. I don't know where you're going to put the target, but put it up. Then I'll find it and I'll blow it up. And I won't be looking for refraction. I'm just going to point and shoot, ladies and gentlemen. That's all I'm going to do with my weapon. I'm not going to calculate the distance, and I'm not going to do that. I'm just going to aim, line of sight, laser beam. We've lit it up, fire, and that will be gone. So it can't be refraction. That's the test that I'd love to do. So when they say it's refraction, it's refraction, is it? Let me blow it up. Then is that refraction now? Thank you, because it's just very annoying all these 10 years that they keep bringing it up, and it's impossible for them to calculate that, and the military don't factor that in when they're shooting at firing their weapons of mass destruction at targets in war events. Okay, they're not calculating for curvature, maybe wind speed, but not curvature. Okay, and definitely not refraction. They don't calculate for that. So just to clarify, I would love to be able to give a test where someone's claiming refraction and we could hit that target, especially on the ocean, where you set it up. And we're now seeing it. They say, well, you can only see that because of refraction. Is that right? And then you fire your weapon, boom, and you blow it up right in front of their face. I didn't take refraction into consideration. How comes I hit it then? If it's a refracted image, I shouldn't be able to hit it. It should be a mirage. That's what a refracted image is. It's an optical illusion. That means I shouldn't be able to see that then, but I'm seeing it. That if I can see it, I will hit it. Now, if I hit it, it couldn't have been refracted. That's the point where I'm trying to make. And those tests need to be done, I think, just to put this refraction silliness to bed.
Well, what about some of the images that DJ was just posting of the ship?
Yeah, those were beautiful images, and those were clearly refraction, of course. You could tell that's right. The thing. Yeah, that's the thing. That's refraction, of course. Yeah, but I'm sure if I went to aim to hit that, there would be a miss there. If I aimed at that would be a miss for sure. Yeah, I'm referring to the images like the Black Swan, images like that where we're seeing beyond the geometric horizon, and then it would mean that the object has been lifted up from the geometric horizon up to our eyeballs. But that can't be true. that were the case, then I wouldn't be able to blow it up. But I'm sure I could blow it up. And another point that's overlooked is that how long is this image being refracted for? Because like you can stand at the west coast of California, look at those oil rigs, and you can look at them all day, and they're there. So that's some kind of refraction that keeps it up all day. Conditions don't happen in such a way. Constantly in flux, and as DJ said, as the temperature variation starts to equalize with the ocean, that image starts to disappear. There's natural phenomena going on there. Right. So it cannot be that when I see the oil rigs at 6 miles and 10 miles, that those are refracted images due to atmospheric. No, it's not. Those are the real images. That's what we're actually seeing over that actual distance.
So, RK, most often with the ships, they don't appear like they're sinking. Okay, most often when you see a ship sail out into the ocean, it doesn't disappear bottom up. Most often what happens is the ship will get smaller and smaller and smaller until the optic that you're looking through, whether it be your eyes or a pair of binoculars, can no longer resolve the object due to the angular size of the object becoming too small. Once it gets below 0.02 degrees, the human eye can't resolve it anymore. It's the angular resolution limitation of the human eye. Now, you can't see the boat anymore, but you can still see the horizon because the horizon's giant. So you could think that, oh wow, I can't see the boat. I could still see the horizon. The boat's gone over the horizon. Well, actually, we can zoom in on that boat and we can bring the entire boat back to view again. Okay, that's on a nice still day where we don't have the effects that we were talking about before, like sinking happening. We don't have the ocean swells. Now, if you introduced some ocean swells, that same boat will look like it's disappearing bottom up, even if there's small ocean swells. Okay, so I would challenge any globe earther to present a single observation where something disappears bottom up, where they've accounted for sinking refraction and they've accounted for physical obstruction, which could be ocean swells / waves. It doesn't exist. There isn't one.
On YouTube, there are distance of 14 miles zoomed in. So you're an individual looking at a ship. It's disappeared from your eyeballs' ability to focus on it. Of course, you can see the horizon because the horizon is much bigger. You're talking of a massive expanse there, bigger than the ship. Remember, the ship is moving away from you, getting smaller and smaller and smaller. Now you can't see the thing. Still there, but you can't see it. So you pick up your binoculars now, take it out of its case, you put it up, focus in, and there's the ship. Now, if it had gone over the curvature, which you think the horizon is, it's the curve there, then I would never be able to see it. It wouldn't be in my view with my binoculars, but there it is. Now, if I keep looking, that ship will disappear from the binoculars' ability to focus on it. Then I would have to take a telescope, which gives me longer range of distance and visibility, and I zoom in there with my telescope, and there it is. I can still see the ship. So when you're working out the time and the distance, there should be X amount of curvature there, but it's not there because the object I'm looking at, although it disappeared from my eyesight, was still able to be visible with my binoculars and then with my telescope. So the question there is, ladies and gentlemen, where is that curvature? Why is it I'm still seeing the ship if we've got curvature going on? Yeah? And 10 miles, 66 feet of curvature should be there, 66.6 feet. It's not there at all. I'm able to see across that 10 miles. I can still see the ship. And then 14 miles, etc., etc. So, there's a lot there people need to take into consideration and digest.
But still, anything that could lead one to think there's Earth curvature is going to be presented as Earth curvature. This includes being able to zoom in at long range on these boats, because the claim is that, well, the Earth is curving, but this is upward looming refraction.
Yeah, and that's why I end up laughing when they say that.
And they'll say that the further down you take your optic, closer to the ground, the further you should be able to see, because the layer of air just above the ground is such that it looms. And so the opposite of what we experience in reality occurs with them. They think the lower that you get, the clearer vantage point you have to distant objects.
Yeah, that goes to show you that they have no idea what they're living on and how Earth works and how nature is operating. They just don't have any idea. We have 14.7 psi at sea level, mean sea level, ladies and gentlemen, where we all live at. 0 level there. That's where we're at. 14.7 psi. And then as you go up in elevation, altitude, the air begins to thin out. So clearly, when we're at sea level, we're looking through the most densest part of the air, where all the factories are, all the ships, cars, traffic, smog, and then you have your early morning dew and everything else going on. So there's a lot to obscure the visibility of what you want to look at through the air. The air will be something that can obstruct what you're looking at also, the air itself, especially at sea level, mean sea level, horizontally looking. If you're looking to the sky, well, there's a difference there because you're looking through the dense, but then you're looking through it as it gets less dense, as you look towards the stars. Okay, but when you're looking horizontally across the Earth, you're looking through the most dense air you could look through, and it will obscure what you want to see over a given distance. Okay, depending on the distance, it'll determine whether or not you're going to have good visibility, and also the weather of that air you're looking through. So if you wanted to look through, let's say, 2,000 miles, 3,000 miles, as some of these globers think you can, why can't I see Paris from New York? Well, the reason you won't be able to see Paris from New York is, one, the distance, and then within that 3,000 miles, you've got to consider the weather systems between New York and Paris. Okay, there's weather systems there. Sunny here, but raining over there, for example. That's going to obscure. So the distance and all that air will turn, it just gets more and more opaque the further you look across. So it's not possible to see that. Impossible.
More importantly, did you just call Paris Paris?
Well, yeah, that's French, gay Paris, né?
Okay, fair enough.
Oh, he's a spy.
Nice one. Happy New Year to you, sir.
Happy New Year, brother. Good to see you.
Yeah, Jedi. The French call it Paris, don't they? They call it gay Paris. They don't say Paris, as we say in England.
It's like, I've noticed this since the Ukraine war. We used to call Kiev, because that's how we say it. But now all of the news announcers and throughout the world, everyone's pronouncing it Kiev. So that means an instance, then we've got to call Paris, Paris, like you just did.
Yeah. But I still call it Kiev's. And when I want to eat a chicken, I don't say chicken Kiev. Can I have a chicken Kiev, please? Do you know what I mean?
Yeah. We're supposed to go around going New York with the accent all the time. As long as we say place names, we have to say it with the accent. I like it.
Yeah.
But good morning, everybody. I hope everybody's doing well. I say good morning. It's actually afternoon. I slept in a little bit today. I hope everybody's doing well. It's raining outside. Winter is so bloody miserable in the UK. But I hope everybody else is experiencing maybe some better weather.
Dude, it's so cold here. It's like negative 12 here, and I went out to start my car and it wouldn't start because the cold drained my battery.
Your car just turned around and you went, fuck off, it's too cold.
Yeah. I held the key, it's like turned. I'm like, it's going to start any second, and then the battery just stopped working.
No.
It's out there buried in snow.
DJ, do you not have a battery charger at home?
Yeah, we got a battery charger. Yeah, I got to hook it up to the charger.
Right. So basically, in winter time in particular, you need to do that at least, twice a month. If you're not doing the mileage, then you do that twice a month. So every 2 weeks, just give it a little bit of a charge. Only through, let's say, your cold months. Let's say like maybe December, January, February. Those 3 months in particular, and then that's it. Then you'd be okay with your battery.
Yeah. I guess I learned the hard way.
Yeah. But I know that back in the old days, motorbikes wouldn't start in the winter, especially old British bikes. But the way to solve that was to remove the spark plugs, for example, and then put them on the gas cooker. So you heat them up, literally cook them on the cooker, then wrap them up in a cloth so you don't burn your hands. Run back out to the bike, plug one in first, and then put the other one, and then the bike would start because the spark plug had some heat in it.
Oh wow!
See that? Yeah. Yeah, that was only with the British bikes. Japanese bikes never had that problem of starting up in winter. All the cars, they start up all the time. But British bikes, they seem to have a problem with the winter, and it wouldn't start up. But there are times when you just do that, use that method, and yeah, good as gold. Boom, and where you go.
I've got one word for you, DJ. Gold rush.
Oh, I've watched some videos on that before. I need to brush up on that. Well, I have, but I don't remember it very well. Definitely interesting. Yeah. Remember what I saw was interesting. What did you watch?
It had kind of just some kind of reclamation event, as in shit goes down, everyone can't live there, and then they spend like 50 years going back over old ruins and stuff and pulling out all of the ancient technology, melting it down and turning it to gold.
What? Wow.
So you know the gold rush in America, right?
Yeah.
So not going into mountains to pan for gold, going into cities to try and pull out the technology that was buried underneath the mud and the rubble. So not panning for gold, reclaiming gold.
Ah, interesting.
I mean, I don't know, do that.
Yeah, because it does surprise me, when they have these seams of gold, veins and seams of gold, and you think, how did Earth make that, but not make the whole rock, only that little vein? You understand? Because that's what they talk about when they're actually panning for gold or drilling and digging for gold. They're looking at veins all the time. Strange. What happened for that phenomena to happen to make the gold? What happened? Strange.
But yeah, just been coming across a lot of interesting subjects recently that I'd never even considered asking about.
Yeah, it's a trip, isn't it? Yeah, me too. I can't wait to watch some stuff today. Actually, I'm about to log off and watch some stuff while I work. So it'll be all of that old world stuff for sure.
Good shit, dude. I did watch a really interesting one yesterday with regards to the education system in the early 19th century. How it was implemented, what was and what was not taught, for example. Yes. At the same time, the education system changed at the same time that there were lots of children being moved around the earth, so like the orphan trains and so on. So the education system looks like it started as re-indoctrination camps.
Yeah, if you could send me a link to that, Jedi, I would be really thankful. Okay?
Yeah, man. No worries, dude. Yeah, no worries.
Yeah, wicked, man. Wicked.
Yeah, man. If you're handing out links to that, I'd definitely take one. It sounds like a good watch. I'll watch that first.
No problem at all. But what's the vibe been like in here today? Anything interesting been going on?
Yeah, I was having a pretty long chat with this guy, RK. Started off with gravity, and then I sort of switched it over to if gravity were to exist the way he was explaining it, or how it would be explained on a globe, then the water would have to be curving. And then we sort of got into long distance observations and horizons and that kind of thing. And then it was towards the end of that you came in.
Yeah, such a great learning curve that was. Pun intended there, ladies and gentlemen, because you don't get any curve out there in reality. But, as is the year 2026 is the year of the horizontal constant. But that was a great learning curve, what DJ did there. I had a little bit of an input, but 90% and 95% of the work was done by DJ earlier. It was good. Oh yeah, definitely. Good one for the people who are listening, because because you're jogging, you're prompting them to question. You see what I mean? That's what's good about it.
Can I ask you a question?
Absolutely, Holmes.
So, if a ship is on the horizon and then it disappears, what do you think that's because? If the Earth is flat, then you should be able to see it. You should be able to see everything on the horizon.
Okay, fair. Okay, so there's two claims there. One is, if the Earth was flat, I should be able to see everything at all times. That's
not necessarily.
Not true. The second,
not necessarily.
Okay, then, fair enough.
Listen. Let me finish. A ship passes over the horizon. Say you have no fog. Shut the fuck up, Reed. Say you have no fog. Say you have nothing on the horizon. Right? It's a clear day. A boat passes right from your distance of view, the same exact distance, no matter what. I'm pretty sure it's like 9.
No, it's not true.
Yeah, it is.
It's not true.
Yeah, what do you mean?
No, it isn't.
Okay, tell me how it's not true.
It's not. It's not true. It's just hold on. It's not true that the boats always disappear at a fixed range. So, for example, there's boats sighted 30 miles out. Now, 30 miles out, the boat would have to be 400 feet tall to be seen, but there's no boat that exists that's that tall. So it's not true that there's a fixed distance where things disappear. In fact, you see things much further than they should disappear all the time.
Can you tell me what boat that was?
Dude, I could give you. Listen, I'm not going to do it right now because I'm busy working. But I can. We've got all kinds of observations, dude. And this one I'm speaking of is from Indio, and he's actually a member of our server, and he could actually show it to you and show you the marinetracker.com where it shows which boat it is. He could show you where he is in the Boston Harbor. And I'm not, and this is just one example, dude.
Okay, I'll give you.
And not only that, so check this out.
Can I ask you another question?
Well, no. Let me finish.
Oh, I get
so
your
I'm just
point.
doing a teeter
if you're not willing to show
no.
If you're not willing to show me the evidence, then I'm not going to listen to this because I'm not going to listen to you if you don't show me the evidence. Okay, can I ask?
Okay, listen, Nick.
Well, if you're not willing to show me the evidence, I'm not.
Nick, I don't need to show it to you. I can validate it with an argument. It's very simple.
There's no validating with an argument because
let me explain it.
I'm not going to take your word.
Let me explain it, and then you can discount it after I explain it.
No, I don't.
For the past 10 years,
if you can't show me the real evidence, then I'm not going to listen to you. You can say,
okay, whatever, dude.
It wasn't. Can I ask you another question?
Posted up bottom-up obstruction. On a flat surface in the side chat if you want to look at it.
Can I ask you another question?
No, because I might have to present evidence, and then we can't have a discussion and actually talk it out.
How about this? From now on, you could just explain to me why this is true or why this is not true.
Well, I want to stay on the other point real quick.
We're going to go past that right now because you're not willing. You said that you have evidence, but you're not going to show me the evidence. So
it's not just that I have. Listen, Nick. It's not just that I have one piece of evidence. It's that over the past 10 years, including before the past 10 years, hundreds upon hundreds upon hundreds of observations of objects being seen further than the geometric horizon have not only been proffered by globe argumenters and flat Earth argumenters, but they're all over the mainstream. Like it's so ubiquitous. Okay. So there's actually this whole. Hold on, let me finish.
You're still not going to show me the evidence. I'm not
hold on.
I'm not going to.
Hold on, dude.
You can't show me the evidence or can't.
Okay, that you don't have to believe me, but let me finish this point. So the point is that on the globe side,
I'm going to go for a next question.
On the globe side, they have a rebuttal for this, but it's not that they deny this occurs. So go ahead.
Okay, whatever. So. Let's go for a more complicated one, if you can explain this. So why do you think the stars change position based if you're on the north side or the south side? Or, why did the stars change positions in the sky depending if you're on the north hemisphere or the southern hemisphere?
Well, the stars don't really change position. They're just like different stars.
Yeah,
I don't know of any star that changes position. Oh, that's simple because you're in a different location. Yeah, you're in a different location, so you see different stars.
I understand that, but the closest star is like it's like 3 light years away, which is so far away in the scheme of things.
Okay, fair enough. Fair enough.
Yeah,
fair enough. How do you possibly know how far away the star is?
Do you want me to explain to you the science behind it, or do you want me to send you a link?
There isn't any science behind it, but go ahead and try.
Okay, let me pull up the science, because I don't know by heart, because I'm not a scientist. Let me pull up the science for you.
There's nothing, dude. There's only angular sizes. There's the assumption of the cosmic distance ladder. There's the assumption of the luminosity, and then there's the assumption of the parallax measurements, which they have to assume the Earth is in a different location in space to get the base leg of the triangle to get the parallax. So all of it is a bunch of assumptions.
Okay. It's okay. Here, I'll explain to it. I'll explain to you. So
yeah, go ahead. Go ahead and explain it to me, even though I already told you everything. Go ahead.
So they find distances, and this is how they found distances 400 years ago, right? So if you have I'm just reading this is what it says on what's it called on NASA's website. I understand this somewhat. They say using parallaxes, tiny shifts from nearby
stars, parallax,
measuring brightness compared to known types of stars, so they can tell.
Luminosity.
Listen, let me explain it. Let me go into more detail.
You're just saying what I said, dude.
I know, but let me go into more detail than you did. Okay. So you have a red dwarf or a white dwarf or a any types of star, a main sequence star.
Little person. No, listen. It's a red little person, okay?
What?
Yes, dwarf is a derogatory term.
You call them little people.
Okay, a red midget star. You have a your main sequence, all these different types of stars, which we know we've studied in the past. Let me say, in the past century, in the 20th century, we have studied more about stars than any other time in history. We've learned the ins and outs of stars. That's what we've done. This is what NASA has focused on for literally 50, 60, 80 years, whatever. When I think they were made in the 50s, so let's just say 70 years.
So in 70 years, they're still doing an assumption-based ladder rather than actual measurements.
A redshift. You know what the redshift is, right? When light.
Yeah, redshift is circular. Yeah, redshift is circular reasoning.
How so?
Because you're assuming the thing is moving away based on the spectral bands, based on how they match the
away. You're not assuming it's moving.
Oh, yes, you are, dude.
You're not assuming it. No, you're not.
Yes, you are.
And our perception is at a fixed distance, right? Because we assume obviously they are moving away in a sense, but because the expansion of the universe. But
you can't have a redshift. You can't have a redshift being caused by anything in there except movement.
Shut the fuck up and listen for a second, dude. You interrupt so much. Just listen, okay?
Yeah, but we're buddies.
Oh, that's true. There you go. That's
right.
You got me there. All right. So you have a redshift, right? So when light travels along a distance, it loses some of its energy, and it stretches out. And this is just a very simplified version.
What? That's not what redshift is, dude.
Well, light stretches out and the wavelengths become much low. The frequencies of the wavelengths become much lower, changing the color to a dimmer red color. So if you look at stars,
hold on, friend. The color of what, though? The color of what?
The emission of the light, the luminosity.
No, you're wrong.
No.
Yeah, let me explain it to you. So what they actually do is they take a spectral analysis of the light and they look at the element bands. So on Earth, when you do let's say copper, if you look at copper through a spectral analysis, it's going to have certain bands of stripes, right?
Yep.
And that's going to represent the gamut, and they have an identity by that gamut, and then they say that's copper. And so what it is when they see from these stars these bands, they match the bands of, let's say, copper, but the bands have shifted towards the red side of the spectrum. That's why they call it red shift.
Yeah, so when the wavelength of the frequency of the light gets stretched out over a distance, and it becomes redder and redder because red is the lowest color that humans can see.
Yeah, fair enough. So let me ask this question, dude. What if, now here, this is important, because remember how I told you how they do it? They try to match it to things on Earth, right? What if it's the case that stars just emit red shifted light and it has nothing to do with them moving?
Yeah,
and if that's true, let me finish this conclusion. If that's true that they're not actually moving and they're actually just emitting red shifted light, there'd be no way to know because nobody has ever been to a star to validate it.
Yeah, well, they can tell with 100 different sciences that what type of star it is based on, like you said, whatever, seeing what type of chemicals are in the star, seeing what type of elements are in the star. They can. I'm not a scientist. I'm going to tell you this. I
know you're not a scientist, brother. Check this out. If you're doing science in a lab, and you have the sample in the lab, and you have very accurate machines, let's say they're 0.3% accurate. The standard that they need to check the star and to validate it is orders of magnitude greater than what they can do in a lab. So what they're trying to tell you is that they can get a certain parts per million reading in a lab, but they can get a greater accuracy reading from a star. That makes no sense, my brother.
Well, stars a billion trillion times bigger, dude.
Hell, whatever, dude. Yeah, so in other words, they haven't validated any of their claims about what the stars are or how far away they are.
So you think NASA is just lying to everybody that the Earth is round?
No, I think they're so stupid they actually think they know what a star is based on their stupid little readout that's way more accurate than what they can produce in a lab.
We're not talking about a star right now. We're talking about why the Earth is round. This is your argument. So you think NASA is lying that the Earth is round, right? You think they're just lying about it?
That depends what you mean by they, because there's many, many people in different organizations. I was in an organization where I had secret information that nobody else had, and everybody else just had to go about their business without knowing what I knew.
Okay, so that literally had nothing to do with my question.
Yeah, what I'm trying to tell you is that just because NASA is involved in quote-unquote space missions doesn't mean that everyone's lying. There'd only be certain people that know truth and are constantly saying the against the truth. But if you're just believing what you're doing, so for example,
that's what I just said, bro. They're lying to them.
So
they're lying to the public to say
no.
Is that true or false?
No. Just check this out, brother. There are many employees at NASA who absolutely believe the Earth is a globe. They even do missions, and they can't even tell the difference between a training mission and a real mission. So I don't know who's lying, but most people just believe the Earth is a globe, bro. They just believe it. And that includes NASA employees. Most NASA employees have no firsthand knowledge of whether the Earth is a globe or not. They just believe it.
Okay, hold on.
Their jobs have nothing to do with any firsthand knowledge of the Earth being a globe whatsoever. And they certainly haven't seen it with their own two eyes.
Okay, so how do you explain, how the moon and the sun behave? How do you explain day and night?
Oh, perfect. So during the day, the sun is out, and then it go away, and then the moon come up a little while. Sometime it come up during the day, and then it go away. So the moon and the sun, they're kind of like here, and then they're kind of like there. So they just go around and do, they're never in the same place.
Okay, that doesn't explain it. No shit, Sherlock. Explain why that happens.
Listen, fair enough that you desire an explanation. All I know is what I see. I don't need to know anything more than that. I don't need an explanation. So if you want an explanation, I'll give you one. So Ratchet and Clank, the video game characters, are actually real. And Ratchet uses his gravity gun to make the sun go around, while Clank feeds him tacos.
Okay, I mean, honestly, that's fair enough. I'm a flat earther now. Now I agree on everything. Actually, no, the Earth is a banana. Prove me wrong. The Earth is a banana.
No worries, brother. But see, the point why I'm being so tongue-in-cheek is that what the stars are doesn't change what the shape of the Earth is. What the sun and the moon are doing doesn't change what the shape of the Earth is. So, for example, I'm in a kitchen. I'm in a kitchen, brother. Just check it out. I'm in a kitchen, and there's a granite countertop, and it is beautiful and flat. And then there's a light fixture above the countertop, which has 1, 2, 3, 4, 5, 6 globe lights. Rest assured, my friend, the shape of these lights in this light fixture has nothing to do with the fact that this piece of granite slab is flat.
Okay, that is a completely irrelevant analogy that has nothing to do with what we're talking about.
No, it has everything to do. It's that the ground is what the ground is. It has nothing to do with the lights in the sky, bro.
Do you want me to explain to you why that's an irrelevant analogy?
Yeah, go ahead and tell me why two things that are different things have nothing to do with each other. Yeah, go ahead.
Okay, so I'm talking about motion, not the shape of a star. I said nothing about the shape.
Oh yeah, fair enough, brother. Fair enough. So let me do something. I'm gonna up my experiment. Flat granite countertop, 6 globes in a dangly light by a chain. Now watch this. I'm gonna take my finger and I touch the chain. Now the lights are moving. Oh look, my countertop changed its shape. My countertop. Oh my goodness, it's no longer straight. Wow, the countertop just curved in front of my eyes because I made the lights move. Did that happen? The answer is no, it didn't. What?
I really don't understand anything you just said, but
I know, brother. That's the problem. So now I'm going to take a tool. The tool I'm taking out is called a square. It's actually the shape of a triangle, and I'm going to lay it onto my granite countertop. And let me tell you, brother, it lays right on that, flat as can be. Now, since I have my tool showing me that the granite countertop is indeed straight and flat, I'm going to take the lights on top of the granite countertop and I'm going to turn them off. It's now dark. The granite countertop is now in the dark. Is it now a globe? Oh, whoa, the light's back on. Is it now a globe? Oh, whoa, the light's off again. Is it now a globe? No, it's never a globe. It's always flat.
Okay, can I ask another question? Bring up another
sure thing, brother. Hit me up.
So let's give you an example. A city in Egypt, I think it's Sainin. You probably have heard this one before. Sain, whatever it's called. During noon, on whatever day of the year it is, there's no shadow. You don't have a shadow because the sun is directly above you at noon. And some other cities, it's very similar.
Yep.
So if you go to the city next to it, if you go to Alexandria, city next to it, you can measure your shadow and it's at an angle of 7.2 degrees. Right? It's not a city right next to it, but it's a city in Egypt as well.
Yeah.
So if the Earth was flat, how would you explain that? If it's round, that would check out. But if the Earth is flat, how would that not check out?
Well, you see, what you're talking about is shadows, right? And so you're making assumptions about the nature of the light and the shadows and geometric relationships.
No, we're not making assumptions. We're not making assumptions. We know this.
No, you are.
Science.
No. Listen. That's not
an assumption.
No, the non-assumption. Listen, Nick, dude. Okay,
shadow is just the absence of light. It's just it's not.
Okay, listen, dude. How are shadows created?
They're not necessarily created. It's just not necessarily a complete.
Hey, listen, let me ask you this question. If it's pitch black, are there shadows?
In our eyes,
no.
Yes. Yeah, well, I'm not saying because there's obviously
if it's pitch black, there's no shadows, homie.
Well, if you want to, that's just way too.
So then the only way to get a shadow is to turn on a light and the path of the light to illuminate the area. And the shadow is where the light is not hitting the area because it's being blocked by something, right?
Yeah, yes, that's a shadow. There you go. That's what we create when we're sitting outside of the sun.
Shadows are blocking the path of light. Now, in order to make geometric claims about the light
that's blocking the shadow, that's casting the shadow by the blocked object, you have to make certain assumptions. So, for example, Eratosthenes, which is who you're speaking about, made the assumption that the sun is an infinite distance away, that it's larger than the Earth, that all the lights are that all the rays are parallel, et cetera, et cetera. He made a bunch of assumptions. So it's not. He measured shadow angles. He didn't measure the sun, and he didn't measure the Earth.
Okay, so why would those two things
Oh, it's very simple, dude. It's if the sun is over here and the rays of the sun are not coming in a way that's uniform, then you're going to have different shadow lengths. I mean, look, I have my granite slab again. Watch this. I take my square, which is blue. It's from Empire Squares, and I'm placing it on the granite countertop. I see a shadow. Okay, this shadow is, since I have it, I'm going to turn it this way so I can measure it.
Wait, also.
Okay, the shadow is, hold on, brother. The shadow is 6 inches. Now I'm going to take the square and I'm going to put it directly under the light fixture. No shadow. Now, let me ask this question, friend. Is my granite countertop a globe?
You're doing it at such a small scale that it really doesn't matter.
Doesn't matter, dude. The principle's the same.
No, it really isn't. Not at such a small scale. Scales have a lot of to do with things. It has a majority of the things to do with everything. A scale can change your experiment drastically.
Sure. I would agree that scale can change things. That's fair.
All right, can I ask you another thing?
Sure.
So why does the bottom of a ship disappear first, then the middle, then the top when it hits?
Okay, I agree. I'm glad you asked that, because now we're going back to where we started. So I said that the ship doesn't disappear at the geometric horizon claimed. It disappears much further sometimes. But did you know this? Check this out.
No, I just answer my question.
Hold on, brother. Hold on.
I don't care what you have to say. Just answer my question. That's all I want is you to answer my question. Why is that the case?
Okay, dude. I'll tell you why. If you can't see the bottom of something, it's because resolvable light from the object is not being resolved in the optic. There you go. That's the answer.
Okay, but why is that the case? That's just.
I just told you. I'm gonna listen. If you don't let me expound, I'm gonna reduce it to the most absolute technical reduction, and you're just gonna have to live with that answer.
Yeah, but that's not.
So you don't get to take a dial. You don't get to take a dial and then dial the color of the television till you like my answer.
It's like I'm speaking to a brick wall, bro. Just answer the question in detail.
Yeah. You can't see things because you can't resolve light from that portion of the object. There you go.
Why can't you resolve the light from the bottom, then the middle, then the top?
Oh, because I'll tell you why. Because you have a limited angular resolution, and the packet angles that are available to render are below the threshold of resolvability.
Go a little bit more into detail with that.
Yeah, so if you took a checkerboard and you look at it, standing up, and you're looking down at a table and there's a checkerboard, you could see all the squares. But if you took that checkerboard, put it directly into your eye, and then turned it horizontal, it would disappear. So the angle of approach matters to whether you can see something or not. So once light falls below a critical angle, for example, a human eye is 0.02 degrees. So if light is not entering greater than 0.02 degrees, there's no resolvable information. Any information that's coming in that triangle will be conflated with each other and become one value. So if that's the bottom of a boat in the ocean, disappears. If that's the bottom of a building and the sand, disappears.
Okay. Can I ask another thing? What
no, only if you let me finish. No, only if you let me finish my previous thing I wanted to finish.
Well, then, sorry, you're not going to say another thing because I don't really care about that. I'm not going to ask another question.
Nick, how's that fair? I've been trying this whole time to tell you a very cool observation that I've done with you. I've done my own observation on my own lake, and you won't let me talk about it. Why are you such a bigot, bro?
I'm not a bigot. I just don't care about your observation because I don't necessarily.
Yeah, see, you're a bigot to my observation.
I don't trust your observation. It's just like you saying something.
You know. Hey, bro. The best part. Listen, friend, the best part about my observation is you can reproduce it yourself if you're within driving distance of a 1,000-foot lake.
Okay, well, I'm not. So can I ask you another question or no?
Listen, I want to tell you my observation, dude. How about this? You put your fingers in your ears, and I'll tell the audience since they want to know.
How about this? I just leave.
Well, dude, if you're going to say, I'm not going to let you tell me your unique, curious observation that has relevance to the flat Earth globe Earth discussion, or I'm going to leave. How is that fair?
I don't trust your observation. That's the thing.
You don't have to trust it, dude. I'm just going to tell you what it is. It's reproducible.
Well, what would be the point of you telling? I'm not going to reproduce it because I don't care that much about if the Earth is a globe or flat.
It's not only reproducible. You can also go find other people that have already done it, dude. So besides me.
Okay. So can I just ask you a question or no? Or is it just a no?
Dude, I'm just trying to give you my observation, bro. Why are you so scared of my observation? Are you afraid that it's going to shatter your paradigm and you're going to have to realize that your globe cuck religion isn't as true as you thought it was?
No, I really don't care if the Earth is a globe or flat. I just was.
No, you do care because you're too scared of my observation, my bro.
No, I just wanted to ask a question.
It's like your girlfriend is holding your phone and she's like, I'm going to flip through your messages. And you're like, oh my goodness, why would you want to do that?
For the sake of privacy.
Yeah, but see, the difference is you know that there's evidence of you cheating on the globe because you know when you're out there in the world that the Earth presents itself as flat. So you've been cheating on the globe your whole life, bro.
Okay, can I just ask a question, bro? You're making some fire analogies. I can't lie. That was pretty.
All right, listen. You ask your question first, and then I'll tell you my observation. Go ahead.
I'll listen. I'm probably just gonna leave afterwards. All right. So how can you explain to me like your idea of gravity, right? Because if our understanding of gravity would be that the Earth, if it was flat, if it magically became flat, for someone that believes that it's a globe, if it magically became flat, then it would crumble back onto itself. And how do you explain gravity in that sense?
Perfect. I got you, bro. I hear you. So I'm going to do an experiment to help it. So I'm going to grab something here. Yeah, I am. I like
What'd you say? How's the Earth flat?
Yeah.
Well, the ocean. Do you think water's flat and level?
Nah.
No.
Nah.
So,
the moon moves the waves.
dude, we didn't say smooth, man. Flat and level, a horizontal plane.
So, like, the ocean doesn't have waves.
Yeah, they have waves, but there's a different property. Smoothness is not flatness. Dude, I dare you to write. Go to when you got Thanksgiving coming up, right? When you go there, be like, that table's not flat because if I take a microscope, there's bumps all over it, and you're gonna be eating outside. Okay, stop being pedantic. Yeah, because you would never talk like this, dude, in real life, dude. This, like, oh, the Earth's not flat because there's waves. It's 193 million mile on the horizontal axis, and it's 3 feet high on the vertical axis, so it's not perfectly flat.
Yeah, but like, how is it flat though? Like, I want to know how it is. I'd like to be educated.
The oceans of the world, there's only one ocean. I mean, we call them different oceans: Arctic, Pacific, Atlantic, but it's all one connected ocean, right? All the water is connected. That water is flat and horizontal. It does not curve into a ball. Most of the surface of the Earth is water, right? So if that water doesn't curve into a ball, then the Earth's not a ball. Water in a bathtub, flat on the surface. Water in a lake, flat on the surface.
It's just making shit up.
Water on the sea, flat on the surface. That's making shit up? We literally, when we want to make flat things in construction, we use a water level.
Yeah, it's called gravity.
Do we use it to make it curved? Go start a construction and be like, oh, what's this level for? Oh, it's to make curved floors.
What the fuck?
Exactly. Sounds stupid, right?
Yeah, it is stupid.
Yeah, because in reality, so you have, like,
comparing a planet,
flat Earth versus globe thing is this: there's one is based upon reality, and the other one's based upon fantasy.
Yeah, the flat Earth is fantasy.
Well, I just mentioned how it is in real world. When you actually go outside into the natural world and use it, navigate it, all these things, that's what actually exists. Things like curving water, curving level, curving all these are just ideas. They don't actually exist out there. See, flat Earth is not on this Discord, it's outside in nature. It's not conceptual, it's not an idea. It's how we actually use and navigate the world. It's how we measure the world.
The Earth was flat. Wouldn't you be able to, like, go into the sky and see the entire planet?
No. Why would you say that? Earth isn't a planet, eh? Earth is not a planet.
Sorry, it's a place. It's
not a plate either. It's not an object in space. There is no outer space. There's no outer space vacuum with shit floating around in it, dude.
Okay, so what is there?
Not that, because that's impossible. Do you know why you know why it's impossible? Because we're breathing air, and if we're breathing air, that means there's air pressure. If there's air pressure, that means it can't be next to a vacuum without a barrier. Because all the pressurized air would fly off into the vacuum. Just like it does in every experiment ever done in the history of mankind, is that high pressure goes to low pressure.
So, like, how does gravity work then?
What does that mean? What do you mean by gravity?
When I drop something.
Okay. Yeah, it falls. And?
Yeah.
Yeah, so?
Wouldn't, like, the flat Earth just curve, like, and rip apart?
What are you talking about? Right. So you're confusing two different ideas. I drop something and it falls, with mass attracts mass turning things into a ball. Those are two separate ideas.
Yeah, but if there's gravity, wouldn't the gravity collapse on itself?
You're trying to combine flat Earth with the
No, you're confusing two different ideas. One is called big G, the other one's called little g. Little g is known empirically. We drop something, it falls, it accelerates at 8.8 meters per second squared. But nobody ever dropped something and said, certainly the Earth has to be a ball because that thing fell to the ground. No one ever said that. That observation does not tell you the shape of the Earth. Now, there's an idea that the big G thing, F equals G times M1 times M2 divided by R squared, which is the Newton's universal law of gravitation. There's that idea that predicts that things would form into balls, like a bunch of free-floating matter in a vacuum would form into a ball. First of all, that's never been observed. Okay? It's never been shown to happen in a lab. And thirdly, it's not even a prediction of the physics. That would be a special case. Because you're going to get an uneven, distorted frickin' blob. The starting frickin' condition would have to be homogeneous. All the particle size will have to be the same. It would have to be isotropic, meaning there isn't more mass in this place than this other place.
Wait, so what is pulling the objects to the ground?
What makes you think there's a pull?
I don't know. They fall. They don't go up.
Oh?
They don't go sideways.
How do you know it's on a push?
What would be pushing it?
What would be pulling it? Why are you
Gravity.
using an analogy of pushing and pulling at all? The current rhetoric is it's not neither of those. The current rhetoric is the distortion of space-time. That the geometry of space itself is changing.
Hey, real quick, I just put 12 different theories of gravity in the side chat. Which one is your favorite?
They need to go on a dartboard. Can you freaking get those on a dartboard?
You probably could with all the division. Gravity bingo cards.
Yeah, the idea that gravity forms things into balls is a poorly conceived idea. And it's not even the modern rhetoric anyway. But that's what they teach everybody in school. Gravity bingo.
Goes up.
Yeah, you can't get, like, it doesn't logically follow because something falls to the ground that the Earth is a ball, okay? You can't make that chain of logic. Doesn't, okay, I went outside, I picked up a frickin' rock, I let it go, it fell to the ground, therefore Earth ball. That's silly. Right? You need a whole sequence of a whole logical chain. And then all you would have is a hypothesis. But if I go, hey, dude, has anybody actually observed gravity forming things into a ball? That's a big no. You can say, hey, I look in the sky, I see a bunch of balls. That doesn't tell you how they formed. So, the point of all that is that even, let's say, you have this whole hypothesis that gravity forms things into balls.
I see you, man. My game installed.
Now check. Yeah. That was Heretic's Razor right there.
Perfect example.
Yep, exact. That was definitely Heretic's Razor.
Find me Heretic's Razor.
Is that people that are dumb that have been bullied by people that are smarter than them want to bully someone too, and they're sick of being bullied, so they come into the flat Earth room and then try to be the intellectual bullies.
That's also a bully reverse cycle.
Yeah, exactly.
Did
Did he say something insulting, like leaving statement there?
What do you mean?
No, I just like if he.
No, he didn't. He didn't. But like, I think he thought he was going to come in and just take a dump all over us, and then like didn't end up being that way.
Yeah.
He probably just thought we were crackpots.
Yeah, for sure. Yeah. You could hear him kind of laughing at the beginning.
Yeah, just like Mansky said, he wasn't taking it seriously, and then it got so not serious that he had to pull a ripcord, jump out of the fucking airplane.
Yep.
Mansky, I know you think you proved globe Earth, but I proved concave Earth. That's right. Here, I'll show you the evidence. See that, Mansky? With the photograph.
Yeah.
That's a digital photo taken of an actual printed photograph taken from an actual negative from an actual camera. That's the airplane wing on the left there. That's the horizon out there. Now you see that horizon? The horizon looks flat, bro. But the problem is it's not flat. Let me show you. So when you put a straight edge up to it, there you go right there. Check that out. That horizon's curved up, buddy. Sorry, buddy. So someone told me you could see curvature of the Earth from an airplane window. So I was like, all right, bro. I happen to have some pictures from an airplane window. So if it's a curve of the Earth from the airplane window, then the Earth is concave. Well, guess the Earth's not a globe there, bud. Damn, sucks, doesn't it?
Didn't show up until better cameras existed.
Yeah. So when someone says, why would they lie? Everyone would have to be in on it. Well, is Kodak in on it? Did Kodak make cameras specifically designed to show the Earth as a globe? To lie because it's actually concave? Is that what happened, Vansky? What do you think, bro?
No, I don't think Kodak is in on it. I was talking to this guy a few months ago, or no, I wasn't talking to him. He just DM'd me, and he said, you guys are pretty much retarded, but he's got like an idea of how the Earth actually is flat. And he was sending me all these links.
Wait, he was saying you're retarded? Is that what you just said?
No, he said the guy, like the flat earthers in this room are retarded.
I don't believe you. Show us a screenshot.
Well, he didn't say retarded, but he said...
So why are you making shit up just to be rude?
Oh my god, dude. It's just...
Well, if you're going to slip in insults, don't be mad when we do it back.
Okay, dude. What did he say exactly?
He didn't say anything because you're making this up.
I'm not.
I thought he was making up, Travis. Pretty standard. Reference to this room from fucking Globe Zealots is prefaced with those guys are retarded.
Well, even flat earthers
Dr.
think that
Phil or
that
Rich
we're
Evans
retarded
or something. No doubt. Was that you?
Yeah. I would say even some flat earthers would say those guys are retarded, but here's why the Earth is flat. So those flat earthers are retarded for thinking the Earth is flat, but let me tell you why the Earth is flat.
So yeah, go ahead, tell your
like
story, man. Yeah, Mansky, what were you going to say? Go ahead, tell us.
No, he wrote me a lot. I'm trying to find what he said exactly about you guys.
Oh, okay. It's all just fucking personal insults.
Yeah.
Or did he have some evidence?
No, it wasn't really that insulting.
Was there any constructive criticism?
Why the fuck can't I find it?
Probably because it's not that important, man.
Now this guy has like a bunch of really interesting theories that you guys don't talk about. Oh, by the way, the guys at 24/7 aren't the best at providing anything more than water's level, etc. So he pretty much clowned on you.
Yeah. Well, we fucking share laser measurements all day.
That's how we
Right
really
on,
need to
it's
claim
a
them.
limited hangout, to be honest. Damn, you guys got clowned on.
But you claimed that he said that we were retarded.
Okay, dude. Come on, read between the lines there.
Okay, but what grade or point did he give?
See, AI is the only intelligent one in this room. He can actually look past the whole retard thing.
What greater point did he give?
Oh, T-Dub's getting fucking triggered now.
Would you kindly answer
Okay, take it back, Travis.
I'm losing interest real fast.
Respond to AI.
Yeah.
This is your moment, Mansky. When the girl is Mansky, the girl has put her face in front of you. She's pouting her eyes, her lips are puckered, and you're sitting there talking about something else rather than taking her and kissing her. Okay, so she's about to break up with you, bro. So get it done. Let's go. Let's go.
We live within / below an electromagnetic field. That's why the stars move in two rotations like we observe, and why the latitude and longitude lines mirror the sky. And he sent me this weird GIF. And then magnetic field versus electric field, you see. Then he sent me a bunch of links.
Bet it was BD or something.
And the kicker is the sun actually does a figure 8, not circles, like almost every flat earther still assumes at this point. Stay tuned. Most people, flat earthers and ball earthers, are quick to assume the two-pole flat Earth would require a Pac-Manning sun, but this isn't true. They'll see when I make the graphics show it along with the explanations. Blah blah blah.
What was the guy called, Mansky?
His username. What's his username?
Oh, his username? New Perspective.
New Perspective. Yeah, we know that guy.
Yeah, we know who he is.
No way!
Yeah.
Oh, but by the way,
allowed in our channels because he keeps rabbling on fucking esoteric shit. He's now angry.
Oh, really?
I don't know. He seems to be working on something pretty big.
What's up, flurfers?
Hey, leave your mum out of this.
What's up, Globetard?
Well, you see, the difference, bro, is that let's say he's correct, that's how the sky works. Okay, let's say that's true. That doesn't change the fact that the surface is flat, and that the gold standards of the surface being flat is that it's benchmarked to water level, which water is flat and level. So he just is mad that he doesn't get to talk about his things here, but he can talk about those things. So
water is not
basically,
flat.
bro,
and has.
Yeah.
And borrowed clips of us, right? He made clips of us for his programming on YouTube.
Oh, in the circle, the sun makes perfect circles, or the sun has to teleport. I mean, those aren't necessarily the positions of everybody that hangs out 24/7. So I don't even know what he's talking about. I think it sounds like he's butthurt, but go ahead.
Who's Butthurt?
You referenced some guys called Ether Cosmology. Do you know them?
Yeah.
Oh,
Shane and
that's not,
Alan.
that's not.
Shane and Space Audits.
Yeah,
Bear.
Alan. I don't think they say the sun makes circles or anything like that.
Did you guys know that there are little retroreflectors on the moon?
There are?
Yeah, man.
Wow, dude! How did they get them there before the moon landing?
Installed by hand, by man.
Yeah, sure.
Did you hear what he just asked you?
Well, quick
course he
question:
did.
if there were no retroreflectors, would they be able to bounce lasers back and forth?
No.
No. So why don't you look up MIT 1961, who was bouncing lasers off the moon many years before the Apollo hoax?
Or the Soviet Crimean Observatory, where they also did the same thing.
Go ahead and link it.
Just look it up. MIT bounces laser off moon, 1961. Google it. Look it up yourself.
Fuck, dude! It's on Wikipedia's retroreflect page on the retroreflectors.
What, 1961 MIT laser, you said?
Yeah, bounce lasers off moon.
No, he's gonna throw his own. Watch, he'll throw his own claim under the bus right when he gets back.
Yeah, he said no, they couldn't be possible. So.
Now, what about Shane and Alan? They're saying what?
What? You weren't listening, Indio?
Yeah, I only heard part of it. I only heard that back end of it.
Mansky has DMs or something from New Perspective, all about how we're shit. We don't go beyond water's level. He's got better arguments. Blah 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 blah.
We don't go beyond water's level. Oh, New Perspective. I mean, I don't know what that would even mean. I wouldn't go by how Mansky's characterizing them. New Perspective's main go-to though is the rotation and trying to land the airplane. I wouldn't go by what Mansky, whatever he said. You know, New Perspectives.
Yeah, right. This is just all on Mansky's word. We're going off, yeah.
Dude, you can see his little avatar or profile picture, his name.
Yeah. My brothers do a great job explaining. Hold on. Let me see. Let me go read the first one.
Tag him indirectly. Maybe he's around.
He might even be listening. Like I said, he has
come in here to defend himself, dude. Is this like a pathetic version of Divide and Conquer, Mansky?
No, I just randomly brought it up because AI was talking about concave Earth. And
what does any of this say about Flat Earth Discord? 24/7.
By the way, the guys at 24/7 aren't the best at providing anything more than water's level, etc. They're right about this, but it's a limited hangout.
Where's that? Which screenshot is that in?
Oh, it's the
the guys at 24/7 aren't the best at providing anything more than water's level. They're right about this, but it's a limited hangout, to be honest. I'll send you links to some servers that go further and aren't overly cautious not to speculate. You can join those from YouTube. What's that a link to?
He sent me a ton of links.
Yeah, we don't speculate. If they want to speculate, feel free.
Well, let's preface this, Indio. He started his gambit with, this guy DM'd me that 24/7 guys are retarded.
Dude, he did. He clowned on you guys.
So somebody I'm on a first name basis with is calling us retarded.
You guys are the water's level bros.
That flat Earth dude knows in real life and like hung out and had beers with like he's calling us start. But it doesn't say anything about him doing that at all. And he posts our freaking videos on his YouTube channel.
Yeah.
And I've hung out with him not only on Discord, but also on X.
Yeah, Mansky heard somebody say 24/7 doesn't. This is what he basically heard. 24/7 limits their points to non-speculative facts that could be substantiated with direct evidence or empiricism. Therefore, they're retarded. I think that's what Mansky heard.
So, Ether Cosmology, which is the name of the Discord that those guys hang out on, is about ether cosmology. So they go into the speculation of how the ether, and they're trying to explain the sun, the stars, and they go through all that shit. But that's their thing. We're not on that thing. At least I'm not. While it's interesting, and like, Nancy, you could actually learn a lot by going to space audits and reading some of their literature reviews that they go over. The homework that you never did, they go over it. You could do it over there. They go over frickin' Michelson-Morley, the Reb compound, like all the experiments which got to where we are now. The Earth is like general relativity and all the shit that goes with it. Tests that showed that the Earth is not in motion, like Harry's failure and Michelson-Morley. They go through all that stuff. Okay.
Right.
We have been focused and always been focused on specifically flat Earth. They're on some other shit. What do we have to do? Some fucking monolith where we all hold hands and say the same shit?
But I mean, too, as well, like we're pointing out that it's not dependent, like what we say, on providing alternatives when they demand that we do, right? Like, well, I say that the sun proves the Earth's globe, so if it's not, you've got to present something else about the sun and the stars and the planets and all that shit, right? Like, we don't have to, but if they want to, they can do it. And probably they just do it because they're interested in it and they want to figure stuff out, right? They're not necessarily presenting it back to Globers as an alternative or as a rebuttal to any Glober argument.
You hit the nail right on the head, dude. They're not presenting it as an alternative. They're not saying, hey, dude, we need to replace their bullshit with ours. They're on some other shit. This is like an independent fucking side quest that has nothing to do with anything.
It's exactly what I thought.
What's exactly what you thought? What you thought?
They just shone a light on the moon, but that doesn't. The retroreflectors prove that we went and put them there.
How?
How else did they get there?
They're not, dude.
How do you know they're there?
We already covered this.
You're not well, bro. You're not well, Twanger. How do we know they're there?
I like how you almost slipped there, dude.
How do we know they're there?
You put the mask up really fast, though. You caught your mask there.
Yeah. How do you know they're there, Twanger?
Because they direct light directly back at us.
Really? In the form of what? How is that detected?
In light, photons.
Yeah. How is it detected?
It's round.
Yeah, cool story, bro.
It's a
nice TV show too. I saw that TV show. So you're talking about, right? The TV show.
This is real, boys. After all.
Twanger, stop trolling, bro.
It looks like we really landed on the moon.
Look, Twanger, you're trying to convince yourself, okay?
Right.
Why does this stupid ideology still exist?
Evidence and saying,
what's the ideology part?
The flat Earth.
Can you tell me what the ideology part is, though? The ideology part? What part is that? Of the flat Earth. What's the ideology part?
Belief in
What makes you think it's a belief?
Because we literally have evidence to prove otherwise.
Well, I have evidence. You have evidence to prove. Well, what is it? I want to hear this. What's the evidence to prove otherwise?
There's a good video from a flat Earth documentary.
That's a good video.
Actually disproves them.
Really? How do you do that?
Yeah.
Yeah, what do you do?
He shined a light
Yeah.
like through a hole from a distance. Here, let me just show you the video.
Yeah, just review it, dude.
How high was the light? How far was
Sounds really technical, bro.
How dark was the hole?
I'm looking up the video real quick.
Why do you have to look up what you already believe?
What?
You're looking up what you already claimed was true retroactively. You believed it first and then looked for the evidence later.
It's a documentary. I let you watch the whole documentary about a flat Earth.
Is this what you based your view of globe Earth on? Is this how you decided that you're on a globe?
Yeah, because we live on a globe.
Yeah, but you said it was listen, bro. You said it was a belief. So if it's a belief, why did people before the globe idea came around? Why did people think the Earth was flat? What was that based on?
Because they probably didn't know what a fucking roundness was.
Okay, so they said, I don't know what roundness is, therefore the Earth is flat. How did they know?
Well, they didn't really know what flat was. If we're talking like what timeline are we talking now, or like
before
the past?
Plato's wrote Timaeus, which is the first reference to the Earth ever being a globe. Before that, before anybody ever thought of it, why did people think the Earth was flat? The Mayans, the Chinese, the Indians, fucking everybody thought the Earth was flat.
I just want to throw this in. Plato's pretty awesome. Thank you.
Yeah, thank you. Plato is usually right.
Yeah, change the subject. It ain't happening. Why did people think the Earth was flat? It's a very simple answer.
I mean, they just did because they weren't educated elsewise.
Oh, they weren't educated.
What was their reasoning?
And the people who built the pyramids were not educated?
Right. What was their reasoning, bro?
This is like an honesty check where you guys can't say the obvious. It's because the Earth looks flat. You know what the answer is. We know what the answer is. But you have to pretend there's no evidence.
What Earth looked like.
They didn't know what Earth looked like, so everyone was blind prior to Plato.
Everyone was blind.
They didn't have the view of space, too.
Did they need it?
Really?
Yeah.
Why do they need a view from space? Well, why would they ever think space exists?
Now bro, this is so.
Right, so that sounds like a concession to me that while you're on the surface, it looks flat.
Yeah, so it's not a belief, bro. Beliefs are acceptance without evidence. Looking flat is evidence that it's flat. What else would it be evidence of? Evidence that it's curved?
It doesn't even look flat. You could see the curvature from the Earth if you look outside.
Really?
You could literally look outside and see the curvature.
Let me see the side of a house, dude. I don't know what you're talking about.
They should be good. They should be good.
Yeah.
So where do we go to see this curve?
I looked outside and I see a ball field. There's a ball field in the back of my house.
Earth is pretty big, and it's definitely very...
ants on a ball. Here we go.
Definitely.
So this is the part where you try to convince us that we can't actually tell if the Earth is a ball. And that it looks flat, that it's a flat-looking ball. This is that part of the.
I mean, you can't with how big it is, yeah. But if you definitely look far enough out into the horizon, you could tell it's curved.
My question is too: when we look at a moon, why does it look round? Huh?
What's the moon got to do with the Earth?
No, it was just a question.
Who cares?
Oh.
Why does your fucking dog look like a dog?
Okay. I care.
Does it
Dumb
make it a
question, I
cat?
guess.
Why does the Earth look round in space?
How do you know that?
Because we literally have evidence.
Who's we? There's no we.
Us as humans. I could literally look it up.
Us as humans. There's no we. You're not involved in any of that shit. In any way. You're not an astronaut, buddy.
I can Google it, though.
So check this out. How do you know that's what the Earth looks like from that point of view? Maybe it looks like something else.
You just blew his mind.
This is
you don't know. You either trust
ask
it.
These new guys. Sorry, I just have to ask. Like, do you think we're sitting here as flat earthers because we forgot to go to Google Images?
No, you just want to be countercultural.
No, now it's a psychological problem.
You just kind of want to be countercultural.
Then why didn't I? Then why didn't I start my argument with I fucking hate the government? Why did I start it with, hey, dude, why did people think the Earth was flat in the past? And I pointed to evidence. Do you want to know what you didn't point to?
You didn't really.
Evidence that that the Earth looks flat isn't evidence it's flat. What's it evidence of?
It doesn't look flat completely. I've even said out in the horizon it's curved.
In what way? In what way is it curved? Can you tell us? Inform us. Is it curved left to right?
What do you mean?
Curved down? You know the horizon means bounding circle? That's the ancient Greek, means bounding circle. That means it's no matter what direction you look, say you're on an island, you can see 3 miles in every direction. Say you could see 3 miles in every direction. That would be a circle. That's why horizon means bounding circle. The horizon's flat. You can do a 360, it's flat. Water's flat. Water's flat and level. Most of the surface of the Earth is water, right? And if that water is not curving, then the Earth's not a ball. It's very simple. If the water's curving, Earth is a ball. If the water's not curving, Earth is not a ball. We know the water's not curving. But it isn't a belief that it's not curving. We can observe this. You've observed this. The difference between us and you is they say there's some point that you can't see where it does start curving, where you can measure to see if that place actually exists, and it doesn't exist.
No.
You know why? Because we checked. You can check too.
Yeah, true.
Yeah,
but,
you can check.
You are missing a huge, and I mean huge part of. You're missing a huge part of the Earth that could possibly hide it being, round. That being, it's fucking huge.
Not when it. Oh my god, you sound familiar. What's your YouTube channel name?
So big.
None. I don't have a fucking YouTube channel.
Round Earther.
Huge is not a size. That's just your opinion.
There's specific numbers that are given to us.
Sorry, I didn't mean to distract there. Continue on. Sorry, India. That was my bad.
Dude, let me see. What is the actual size of the Earth? I keep forgetting.
Because it can only be so big.
You don't even know?
But only so big.
Because it's just big.
Why don't you know
have to
already?
have the exact numbers stored in my head.
Well, how
You're going to come in here defending something, you should know everything about it.
I was just joining. I was exploring. I wasn't.
Yeah, that's fine. Well, I mean, you were quick to assert the Earth was a globe.
Give him a chance to find the.
Now you seem to be backpedaling.
Don't you find it odd that you have to make the argument that the globe is undetectable?
For the record, I'm exploring too.
Yeah.
Don't you think that's like an odd argument?
Just stupid.
I just
not really an argument because I think that I wasn't really here to try to argue. I was just kind of.
You said you tried to claim we have an ideology, which is horseshit.
Yeah, you kind of do.
Okay, so observing the Earth is flat is an ideology. That's an ideology?
Yeah.
Do you know what ideology means?
Yep.
It means not with the senses, dude.
Yep.
It would mean a mental construct, an idea. It comes from. Go ahead, AI. Sorry.
Yeah.
When people come on the job site, the first thing I do with them, I say, "Can you read a tape measure?" If they say no, I go, "Okay, now let me explain the ideology real quick." Then I say, "Can you use a level?" And they say no, and I go, "Okay, let me explain the ideology real quick." I mean, dude, measurements aren't ideology, brother. Yeah, when you're on a job site and you're trying to level a foundation or you're trying to level a floor or put up a wall vertically, is that an ideology?
I feel like you're trying to misguide me.
No, I'm not, dude. You come in here claiming that observing something flat and concluding it's flat is an ideology. Okay, that's just ridiculous.
It doesn't. The Earth doesn't even look flat.
You're already entirely misguided. We're trying to unmisguide you.
At what point is
How
it?
the fuck am I misguided?
At what point is the Earth not?
You live on a spinning sphere with no empirical evidence of it.
Misguided by believing in.
Where does gravity come from? Is it just? Is gravity flat too?
Which gravity?
The fuck you mean which Earth's gravity?
Einstein's or Newtonian gravity? Which gravity are you talking about? There's a whole bunch.
They don't believe in gravity.
They don't believe in gravity? Do you not believe in gravity?
What does that mean, to not believe in gravity?
Yeah. Is that what it requires, belief? Trust?
What's going on in chat? Let me see chat real quick.
So, see, this is the problem, is that you guys conflate two separate ideas. One idea being things fall, and that's called gravity. That's the effect we all observe in nature. But you conflate the cause with the effect. Why things fall? You think it's because there's a magic pulling force that forms things into balls. That's never been demonstrated experimentally. It's never been observed in nature. It's just a bunch of nonsense. Things fall is observed every day. Gravity forming things into balls, that's horseshit. Now, what you should be paying close attention to is the major infirmities, the ideas you have, or you've been taught are, when you actually think about them. The cause, the effect is called the cause. Hey, dude, what's gravity? What forms things into a balls? I don't believe that happens. Oh, drop something. Well, what causes that? Oh, I don't know. What causes something to fall? The thing that forms things into a balls. Well, how do you know that? Drop something. End up in a loop. Circular logic.
Okay, I do have one question. Why do you think that gravity would turn something in the balls?
It's what you guys think. It's what you guys think. It's not what I think. I don't know why anybody thinks that.
What? You said water is flat.
Yeah, the mainstream claim is that Earth is a sphere and all the planets are spheres. It's because gravity pulls mass into that shape. That's the mainstream claim. That's what you believe.
Yep.
Yeah.
Yeah, that's never been observed in nature.
I always figured one of the first things they did on the ISS was take some Cavendish balls, put some water in there with them in a vacuum chamber and showed us water sticking to them. But they never did.
Yeah, they always show us them going to the bathroom for some reason.
Let's hear what Ice has to say. He's about to spiral because he thinks looking up proves things go less into balls. thinks that's the evidence that that's how they form, by just seeing them, and they may be spherical.
No, I'm pointing out that very basic reason to conclude that when the other guy says there's no reason to think that gravity turns things into balls when everything we see in the place where gravity would turn things into balls is a ball.
What?
So,
what place is that? How do we find? Hold on, Ice J Fish. How do we find that place in the first place?
Oh, it's very simple. You know how air pressure, like there's less air the higher you go?
It's not a method of finding something.
No, I'm explaining to you. So the place where I'm talking about is where there's less air. So the higher you go, the less air there is. If you keep going up, ostensibly,
yeah. How does that tell me where the place where there's balls are? Nothing. You're not.
It goes down to basically zero, because if it keeps going down,
that in the place we expect to find a ball, we see the stuff that would make the ball. Okay?
No, we see balls.
Why would we expect in that place to be a? Hold on. Why would we expect that place in 3-dimensional space there to be a ball there?
Because we're looking at distances that are so far away in a place where there wouldn't be any air, which means that large masses, according to gravity, would collapse on themselves into balls, spherical shapes. And that's what we see in the sky.
Okay, that's not a prediction of Newtonian gravity. You're just saying
two separate things.
Thank you,
bro.
and good night. Or I might be
hey, bro, in the side chat. Hey, don't you freaking you weasel little
fucking broken, man.
Little bitch.
You guys are fucking mentally delusional.
That's really a good argument.
Oh well.
Oh, you want to pick up for him? You want to pick up his argument for him?
No, I just want to ask one question. What gave you this conclusion that Earth is flat?
Paying attention to reality and stop living in fantasy land. When you actually observe the world, look, what did it is I actually observed the world instead of taking what the world is on based upon what someone told me. I said, hey, dude, what people are telling me.
So you're saying you were never influenced by anyone?
No, let's go check that. We fact checked.
So you were influenced by someone?
Stop interrupting him, B, man. I'm trying to hear him. In every sentence.
I'll tell you what I was influenced by.
He was interrupting me earlier.
Okay, I'll tell you what I was influenced by. There was in Michigan, there was a news story on the weather, on the local news, that they showed a photograph of Chicago across 52 miles across Lake Michigan, and they said it was a mirage. But it didn't look like a mirage. There was no double image. It wasn't an inferior mirage. Wasn't a superior mirage. Wasn't a Fata Morgana. And then I looked up the math, and the Chicago shouldn't be visible. So I'm like, oh, that's interesting. Then I looked, there's more observations that bust the globe. More and more and more and more and more. That the globe makes certain predictions of what we should see of the world, and none of those predictions are actually in the world.
So wait, can you see Bangladesh from where you are?
No, and you shouldn't.
Exactly. Do you know why?
There's no reason why you
because of the meteorological conditions prohibit it.
That's a transmission
Because when I look at my local weather app and it says visibility 10 miles, that's based upon the meteorological condition in the
guess
area.
what your weather app's based on?
So my weather app is a curve calculator.
Has nothing to do with curvature.
Yes, it can't.
My weather app is a curve calculator. That's what you're saying. Would it need to know my elevation?
Yeah, it would.
So I have to punch before I can use my weather app, and it gives me the visibility. I have to punch in my elevation.
No, what? You're being so fucking disingenuous. It's crazy.
Well, because how far you can see on the globe is based upon how high you are above the surface, right? You can see farther from on top of a mountain, right? I'm seeing over the curve of the Earth. So the visibility would have to be based upon, if it's calculating the curvature, I would need to know my elevation to make that prediction. Yeah, it's not based upon that. It's based upon the transparency of the air. And guess what? The air's not transparent for fucking 9,000 miles or however far away Bangladesh is.
Okay, if the air isn't transparent, how can we see the moon and the stars?
My goodness gracious. Well, you're not looking horizontally, are you, at the moon?
Much easier to look up than it is horizontally. There's less.
And in fact, the sun is 23,000 times less bright on the horizon than it is at noon. Yeah, 23,000
Yeah, where does
times.
it go at night? Where does it go at night then?
Somewhere where you're not.
Is that
away?
That's a crazy.
Okay, so why is there sun in Japan while I don't have sun here?
Same answer I just gave you. The air is not transparent. If I'm underwater, let's say I'm at 400. Let's say I'm at 400 meters under the surface of the ocean, and it's noon. Can I see the sun?
What?
I'm under the water.
Me personally,
it's noon. I'm underwater, and it's noon. I'm 400 meters. Can I see the sun?
It matters how clear the water is.
Oh, really?
Yes.
But not the air.
Guess what air contains? It contains a lot of water.
Yeah.
It's called humidity.
Then there's dust.
Thank you, whatever your name is, for these images. This is
It's called Snell's window.
Yeah.
So
I
you
know
don't
what Snell's window
understand
is.
by your own admission there, V-Man, you just contradicted your other claim.
What
or
do you mean?
assertion. Well, the clarity of the water, right, is relevant to how far you'll see through it. So
I've seen some very clear water, and air is just a very, very
shallow
clear
sea.
Yeah,
water,
the air is a medium
depending
as well.
on variables.
So can you see fish 500 feet below you on super clear water?
All right, friends.
Well,
I'm
I
gonna
can
have to
see
smack
the
the facts
line.
real quick.
What happened in this image, V-Man? Did the Earth fucking shrink? And that's the horizon there, just past the skyscrapers.
That's fog.
Oh shit!
Me personally, I believe it plays peekaboo.
So a high density of water in the atmosphere. You understand that with distance, the light is going to attenuate through the medium. That's why you can see the sun on the horizon. You can look at it because it's passing through all of that gas. So when it's above your head, you can't look at it because there's not so much of density of that medium to distinguish the light. Same reason why you can't see to the bottom of the ocean, or like Indio says, see the sun at noon when you're 400 feet down, because the light can't get through all of that water, even though a small portion of it might be transparent to you. Over distance, it's actually translucent.
Funnily enough, my friend, they actually have a equation that you can do. It's called the Rayleigh atmosphere extinction coefficient, and when you apply it to the ambient atmosphere at the base altitude, so zero altitude, you get pretty much no more than 350 miles that you can see. So the idea of seeing from one coastline to the other coastline of thousands of miles away is impossible. You can't see through that much atmosphere. It's just that simple. Now, you might say, well, hold on, Fred, real quick. So you might say, well, if the Earth was flat, I should be able to see everything I should be able to see within that range. Well, guess what? There's observations off the west coast of California where people are seeing islands and out in a range that's within that range, but greater than the range of the alleged curve of the Earth would allow. So in other words, off the coast of California, you can see everything that's within that range. So if anything, friend, your argument that I should be able to see things beyond what the curvature of Earth would allow is correct. We see those things all the time. So whether you realize it or not, you actually defeated that the Earth was a globe. So good job, the Earth is flat. Doesn't matter. By his own admission, he said, if the Earth was flat, I should see things beyond the curve of the Earth. They should present themselves within my field of view. And I presented him with an example that is true. Therefore, by his own logic, he now concedes the Earth is flat.
And that's based upon the misconception that he can see the moon at nighttime and it's thousands of miles away.
What? Well, he could definitely see the moon.
They don't realize that you're not seeing the surface of the moon. You're seeing the light that comes off the moon.
How else would you see anything?
Exactly. That's what they don't understand. They think they're seeing an object thousands of miles away. No, you're seeing the light travel to you.
That's fair, but the main point here is that he's confused that if I can look straight up and see something that I assume is thousands of miles away, therefore, when I look horizontally, I should see things that are thousands of miles away. But the atmosphere is more dense, the lower altitude, right? So the occlusion rate is higher looking out horizontally than it is looking diagonally, than it is looking straight up.
Yeah, that's why they put telescopes on high mountains so they can avoid the thick part of the atmosphere. They prefer mountains that are 12,000 to 14,000 feet.
Right, so if he's still here, what was his name?
Is it V-Man?
Yeah, he's here.
Yeah, V-Man, I addressed your question about the visuals and why it's different horizontally look vertically. And I also addressed the fact that you can see things out horizontally within your field of view, within that 350 mile range, that supersede the globe geometry. So according to your logic, the Earth is flat, V-Man. What do you have to say about that? All right, he pleads the fifth. The jury convicts. The Earth is flat. I rest my case.
Yeah, I don't know why people are all enamored by MIT people. Hold on, let me find the video. Dude's like, I got a 5-point frickin'. I graduated with a 4.0 average from MIT and I'm stupid. It's fucking funny, dude. Because the way MIT is structured is that if you're like failing the class or if you're not doing good, right, where you're going to get a C or a D, you can switch it to pass fail. You can switch your grade
in the middle, like while you're taking it. Mm-hmm.
Yes. And you can switch it to pass fail. And then if it's pass, that counts as like a 5.0 or 4.0 rather. Yeah, dude.
Oh,
is this why we're ending up with doctors that use ChatGPT?
Yeah.
Probably.
Rusty P thinks we're trolling about the gas pressure gradient. Is that true, Rusty P? Is that what you think?
Depending on the picture that it was about, yes. There's no other way you can explain it without
you
trolling.
think they have a hard boundary? Is that your problem? Is that there's a hard boundary in their little atmosphere?
Yeah, I was just responding to a picture.
Yeah, that's what I'm talking about. I'm looking at the picture, the one that says how.
Yeah, how like gas pressure exists to a vacuum.
Yeah,
there's no.
It's not meant to be a freaking graphical simulation of a gas pressure gradient in space, dude. It's just meant to get people to ask the question: how does it happen? To investigate.
Even then, it's still. It feels like a troll question because at this point everyone should.
How is it a troll
understand it.
question?
Because I think everyone should understand that there is no vacuum next to gas pressure. This
really?
The question itself is kind of a
There's
dumb
no
question.
vacuum of outer space. Yes, I agree. There has to be a vacuum next to gas pressure. Has to exist.
Like it's
in the glow
like
model.
A vacuum. Yeah. Like a vacuum is kind of arbitrary. Like, you know, what we call a.
And why do we use? What is we using the word for?
It's kind of if you have a vacuum at home, is it like space?
This is like you're doing like a word context fallacy. We're not using it in that context.
Yeah, I understand that, but like, do you understand that if you go, like, if you increase in elevation, if you go up a mountain or something like that, that like the gas pressure reduces?
Yeah, we know that. Why is that?
And if you go higher and higher and higher and higher and stuff, like you just have like a gradient.
Okay, cool. Does it reduce to zero?
Not to like 0 point something.
It does well, when does it get to zero? Because if your argument is like there's a gas pressure gradient and it tapers off, like when does it get to zero?
It doesn't have to go to zero. It doesn't ever get to zero.
So it stops at some point, right?
No, it doesn't stop at some point.
No, the gradient stops. It stops being a gradient at some point.
No, it doesn't.
So it goes to zero.
No, it does not.
Doesn't converge to zero at some point.
Not really, no. I don't think.
But you know how gradients work, right? You start with some number, and then you have some other number, and it slowly tapers off to that lower number. What's the lower bound?
Then, I mean, it's just completely different when we talk about.
This is the problem with making that silly argument that if it goes down, why doesn't it just keep going down? Because eventually you have to get to zero. Or some arbitrarily low number that you have no evidence for. And then I go, okay, where's the container there? Well, you can place that container boundary wherever you want, but because the gas pressure has to go down and stop at some point.
It doesn't have to stop. It can fizzle out.
Into what?
Into nothing. There's just
exactly nothing into absolute vacuum. Where's that?
Yeah, there doesn't have to be nothing at all, and there can still be some molecules that float around and shit. I just think,
but then it wouldn't be a vacuum. Even one molecule, if there was one molecule in a fucking light year space, that's still That's still not a perfect vacuum.
Okay, but like who like you think that like a vacuum means only that there's completely nothing there? What scientist is actually like, or like who, like Neil deGrasse Tyson or whatever, is saying that there is absolutely nothing in space, like completely nothing?
Well, who cares what he says, because they make illogical, inconsistent, and contradictory arguments. Okay, they say there's a gas pressure gradient and it tapers down to some low value.
Yes.
But exactly. Yeah, great, and that proves that space exists because
no, it doesn't prove it doesn't prove that it exists. It only explains something that happens when you think about going, for example, up a mountain, for example, and you can use your mind to think about. Okay, so
use your mind.
If I
don't want to use my mind, dude. I want to use empirical evidence. That's what I want to use. So I don't have to imagine shit.
Yeah, but if you stand on like sea level and then you climb up a mountain and the air gets thinner and thinner and
that's
thinner.
That's descriptive. That's great. When does it stop getting thinner?
It never really it never really stops. Like at some point it's so thin that it doesn't.
Is that speculation or do you know that?
Well, it's I guess you can say a speculation from my own experience, yes.
So the difference is you're speculating on when it should stop and when I think it should stop, right? You think it should never stop, even 100 trillion freaking light years away from Earth. There's still a continuing gradient.
No, because there are additional points of information that you have. Yeah. Like it's not just only this one thing that you have like that. Yes, it gets thinner and thinner, but it's like you're a fucking idiot.
The major problem that really exists is the fact that we can talk about it, but nobody can demonstrate it. Can't do this experiment, okay, and insert gas into a vacuum chamber, and the gravity of the Earth hold the gas away from the vacuum at the bottom of the vacuum chamber. Okay, that doesn't happen, but that's what they say is happening on Earth. And I could take my little vacuum chamber and stick it on the surface of the Earth where the gravity is the strongest, and it's not going to hold the gas from the top, away from the top of the chamber where the vacuum is, to the surface of the Earth. I'm not going to measure more gas molecules at the bottom because of gravity. There's no, it's easy to talk about, right? That, hey, we have some gas pressure gradient and it tapers off into whatever value you want to think, 10 to the negative 22 or for deep interstellar space. Great. That's fine. But experimentally, you can't demonstrate any of this shit. That's the problem. Because science, when you guys just keep you guys really need to get this, and this is why you guys constantly get smashed by us, dude. I'm being honest, is because science is empirical, and you can come up with all these hypotheses. You did say something empirical when you go up from the sea level to the top of the mountain, the gas pressure gets lower. So what? What is your evidence that it just goes down to some level that you can fly spacecraft in, or that there's fucking planets in fucking whipping around in a vacuum, right? You see what I'm saying? Is this gas pressure going down? Either it goes down forever or it stops at some point, right? So it has to. But your position is it never stops; it just goes down forever. Where does it stop?
Yeah, basically,
it goes down forever.
Kind of levels out at some point.
So we could so at some point, if we get far enough away, there'll be like 1 atom per cubic fucking light year. And then if we go fucking further away from that, there'd be 1 atom per 10 cubic light years. Right? Continually going down and down. Then 1 atom per 100 fucking cubic light years. That's all speculative. That's speculative nonsense. There's no evidence that it goes down forever.
There's evidence that it does go down.
Forever?
Doesn't have to be forever. Doesn't really matter to
It does matter, because then you're quibbling about where it fucking stops or not.
No, it doesn't have to stop. Like, what are you saying? Like, there's like additional information that you have to take into consideration.
Yeah, that's what I'm taking into consideration. We're trying to figure out: is there a barrier? Is there a barrier that stops the gas from fucking off into some lesser thing region?
No, there is no barrier.
Why not?
There does not have to be a barrier.
Okay, can you demonstrate that in an experiment? That's your hypothesis. Rusty P's hypothesis: we don't need a barrier. Okay.
There does not have to be a barrier.
What's the evidence for what's the evidence in the natural world for the hypothesis?
Okay, so wind, for example.
What's the evidence in the natural world for the hypothesis? What's the evidence the hypothesis is true?
1 gas pressure amount, higher pressure.
Yeah.
Another, a lower pressure being right next to it.
Yeah, what happens?
Yeah.
Yeah, the high goes to the low.
Yeah, wind happens.
Yeah,
exactly.
Thermodynamic systems try to reach equilibrium.
Yes.
Okay, really simple.
Well done.
Okay, so why isn't the gas pressure on Earth trying to reach equilibrium with outer space?
Gravity.
Okay, can you demonstrate that hypothesis in an experiment?
Yeah, I can all depend, like, bro, like
no, the hypothesis that gas pressure can be created by gravity.
Yeah, real life.
So you're going to affirm the consequent.
Like, what do you think? Is like, do you think that people figured out gravity based on gas pressure? That was the first thing that they thought. Oh, we can't figure this shit out, but
they didn't figure out gravity. Okay. There's two values. There's little g and big G, right? Little g we know empirically from just fucking dropping shit. But there's no evidence that gas takes little parabolic fucking arcs and falls back to Earth. And in fact, if you look in any textbook on the kinetic theory of gases, there's no little g in there predicting fucking gas molecules taking parabolic arcs, falling back to Earth.
It doesn't have to.
Like, how do you create gas pressure? You just appeal to gravity.
Yeah, so what?
So say we got a gas molecule heading straight up.
Mm-hmm.
What makes it come back down? What if it's at a 45-degree angle? Does it take a parabolic arc and fall back to Earth?
Can have depends on the energy that it has.
Okay, but at some point, right, it'll fall back to Earth, right? It doesn't have, but at some point though, it'll fall back to Earth, right? If gravity's affecting it.
Correct.
And it's not going to fuck off into the vacuum. The gravity is going to do thermodynamics. Now, this isn't in any theory of gas. This can't be demonstrated in a lab or any experiment. Like I said, Rusty, you can say stuff. You can say, yeah, gravity is what causes the gas pressure. But science is empirical. That is a hypothesis. Gravity creates gas pressure. Demonstrate your hypothesis is true in some fucking experiment. This is why you guys fail, because it always comes down to science is empirical. It's based upon tests of the natural world, in the natural world. And when we go do this test, what do you want to know what's going to happen? Your hypothesis will be falsified.
That's so, yeah. Okay.
Yeah.
Like, it wouldn't the
Get
same
a vacuum
thing apply
chamber,
to you?
put gas inside of it, measure gas pressure at the bottom and not at the top.
Okay.
You know that's stupid. You know that would never happen.
No, you don't. No, because you don't have to do that.
How are you going to demonstrate? How are you going to demonstrate gravity creates gas pressure?
You take a sample. You measure gas pressure at the ground, at sea level, for example.
That doesn't give you the cause.
No, you don't have. You don't have to measure the cause. Like, no people other than fucking flat earthers.
And how do we know it's causing the gas pressure then?
You can derive information based on evidence.
Yeah, you know, our evidence is gas pressure, 15 pounds per square inch at sea level, some other value at the top of a mountain. How do we know what caused the difference?
Again, you can derive information from things you observe or measure. Like, it's if you like what?
Yeah,
what okay,
right. We
like,
have information. We have a bunch of data. We're taking the data and we're trying to interpret it and see what the data says and what it means. Okay.
Yes, okay.
We know we've measured a pressure difference. We want to know why is there a pressure difference? Okay. What causes there to be a pressure difference? Okay, what experiment can we do to see if things falling is the same cause as the gas pressure?
Yeah. Okay. So let's put it to the flat Earth side, maybe.
Oh no, Rusty, no.
Can't do it.
Stop.
Okay.
No, I'm being nice, dude. I freaking lucky I'm not screaming at you, bro. You said gravity creates things falling. That was your demonstration, your analogy. Hey, if I drop something that falls, that's what's creating gas pressure. The same thing that I dropped the freaking bowling ball. The same thing that made that happen creates the gas pressure. How do you know that?
That is a claim that I make that when we see things falling and that we have a great pressure gradient in the atmosphere, that is a claim that I make. Okay, there's gravity.
You don't even know what causes the first one. How are you going to know that whatever causes that is the same thing that causes the second one?
Yeah, no, that is my claim, right? That's what I'm claiming. Now, if we have like a debate about whether the Earth is flat with the flat Earth model and stuff like that, and I'm making the claim, it doesn't matter the flat. I'm making a claim that gravity is what's causing that. Now, if we are putting the two models side by side, like in a fucking Tekken universe versus shit, right?
Yeah.
Now, what causes this thing to happen, what we see in real life, whether the Earth is flat or not? What's causing things to fall down on the flat Earth? Or
nobody knows why things fall, Rusty. Do you understand? You can say why all you want. Nobody knows why.
Okay, so
do you think you know why?
You can't make any
Neither
claims.
can you. You can claim you know why, but you don't. Because I can ask you one simple question. What was the experiment that determined the causal mechanism of a falling object? And you can't tell me one. Nobody can tell me one.
Yeah, I can tell you one.
Oh, okay. Tell me the causal mechanism of a falling object. Go for it.
You take an object, you let go of it, drops it down to the ground.
Okay.
That's an experiment that you can make.
That's the effect. We want to know why.
Okay.
You just gave us the observed natural phenomenon. We want the cause of it.
Yeah.
You gave us a dependent variable. We want the independent variable, Rusty. The cause.
Things of like things that have mass, right? Objects that have mass attract each other. Is that enough? Probably not. Next thing would be
because
you have a
what that I want, because you're sitting here saying we like X causes Y. You don't have evidence for X causes Y. Okay. You're just saying, I could just say the same thing you'd have, and same thing I could say, well, it's magic freaking fairies with rubber bands that cause things to fall. I'd have the same evidence you do. Nothing.
Okay, so the entire world is just...
Who cares what the entire world thinks? I'm talking about evidence. I don't care what the entire world thinks.
Yeah.
If everybody agreed there was magic fucking elf rubber bands, would you be in here fighting for that?
Oh.
And I'd be, the whole world thinks it's magic elves with rubber bands. It's got to be true. The whole world thinks it. The whole world thinks a lot of stupid things. I wouldn't want to fucking place bets on what the mob thinks.
I understand that, but it's like the level of evidence that you require is impossible.
It's not. No. It's a simple experiment.
It's not, apparently.
Yeah, because it's a shit theory. It's not even a theory.
What experiment would
look?
You?
It is so in science. The scientific method determines cause and effect relationships of natural phenomenon. Okay, you have independent and dependent variables. You manipulate the independent variable and see the effect on the dependent variable. Your dependent variable is your observed natural phenomenon. Now, we've known for fucking 200 years how to do the scientific method and figure out when we see a natural phenomenon, if we can isolate the independent variable to figure it, we can even quantify it and come up with a law of nature, right? You don't have that for gravity. It's a shit idea. That's why they're still fighting about it. Is Einstein right? Is Newton right? What about quantum fucking quantum emergent gravity? And this is why there's 70 freaking theories of gravity, right? Because it's fundamentally a shit idea.
What experiment would you consider to prove it to your specifications?
Look, what do you mean prove what?
Gravity.
The cause?
Yeah, the cause.
The same thing that follows the scientific method. You isolate an independent variable and manipulate it, and that would manipulate the effect.
So what would you propose to prove that?
a scientific method experiment, dude?
Yeah, but how would you do it?
Okay, let's say, okay, I'll tell you. So, say your independent variable is mass. Mass causes gravity, whatever the fuck mass is. Another poorly defined fucking thing. So let's say it's mass. Mass causes things to fall. Okay, so we can manipulate, that's our independent variable. So we'll take two different masses. Take a mass that's fucking 100 kilograms. We'll take one that's 1,000,000 kilograms. We drop them both. We see which one falls faster. Right? We manipulated. We want to change the effect. We want to manipulate the independent variable and watch the effect on the dependent variable. That's how we figure out what the cause is. As long as we've eliminated all the other possible confounding variables, we can definitely say, hey, this causes that. Right? So this test, if you do this test, what you'll find is, irregardless of the mass, they all fall at the same rate.
Oh, what the cause is, though.
So your cause, mass, can't be the cause. Because it had no effect on it had no manipulation of the independent variable, had no effect on the dependent variable.
It can still be the cause, but
how can it be the cause if manipulating it doesn't change it?
You know, it can still be an indicator of like different masses, for example, like fall at a different rate or something.
Rusty, let me use an analogy. You want to go on the date, there's a whole bunch of girls, and they're all saying no. And they say, if you change one thing, we'll all go on a date with you. So you change your hairstyle, and they all say no. Now you know that's not the cause of them not going on a date. You change your shoes, they say no. Well, that's not the cause. Then you change your cologne, and then they all go on dates with you. Now you know what causes them not to go on a date with you. You smelled. Okay? It wasn't your shoes, it wasn't your hair. It was your frickin' cologne. Okay? You understand? So if I manipulate mass and it doesn't change the effect, and I still get something falling at 9.8 meters per second squared, then that's not the cause.
Yeah, exactly. Like, that's the point.
Yeah. So mass can't be the cause. So you asked me to tell you how to do it. We're going to drop two different masses. We'll drop two different weights. So we use, okay, weight, mass. We'll drop fucking two different densities. Oh shit, dude. Now we're getting somewhere. Different densities fall at different rates. Shit. But we got a confounding variable. We got the fucking air that surrounds it. Okay. Let's fucking old dude. Fucking beat me to it. How'd you know where I was going, old dude? So this experiment in here is in a vacuum chamber, and they use different elements. So it's just called Bremen Drop Tower. It's 5 stories. Okay. They have a vacuum chamber. They put this shit in a capsule and drop it in the vacuum chamber. Now, they have, and this dude did an experiment and then got kicked out. He's German. He put all these different elements. They're all the same mass, as in, whatever. And whatever that means. And he dropped them. But they didn't all fall at the same rate in the vacuum chamber. So what this tells you is that mass, even though it's the same, if you do a carefully controlled experiment, there's some other variable that manipulates the rate of fall, that manipulates G.
Yep.
So what I'm saying is gravity is fucking unknown, dude. It's just an unknown.
I don't know. Like what you just said is like that's what we understand as gravity. Yes.
Yeah, but
like it's like
the understanding is
unknown shit.
It's more like, it's an understanding that's more like a kid's story. Like they tell people, like, we understand this, but they really don't.
Yeah, well, like like generally people understand that when we come to
in a descriptive way, we understand it. Like we know, like we can make formulas and predict what happens. Like we shoot a cannon, right? Based upon, a formulas, we know where the cannonball is going to land, right? Using little g. But like I said earlier, that's known empirically. We don't need a theory of gravity to make those predictions. We don't need to know why any of that happens.
Of course. Yeah, you can figure it out. Like cavemen can figure shit out.
Yeah, you could actually
like
just feed the data into an
distance.
AI, and the AI could figure out where the fucking cannonball is going to land without
Yeah,
knowing
well,
anything about Newton's laws, right? So,
I mean, yeah, you gotta put the numbers in, but it's not about like the fact that
well, yeah, you could shoot like
there
a
is like
trillion cannonballs, right, and just and punch in the numbers of different the different configurations of the cannon and the cannonball and the distances and where it lands and all that shit, right? You feed it into the AI and fucking you like once it's done being trained, you go, okay, I shot a cannon, it was tilted at 45 degrees, and the cannonball is gonna, it's got this much gunpowder. Cannonball fucking has this much mass. Where's it gonna land? And it would spit out fucking the right answer. But it wouldn't need to use Newton's laws to figure any of that shit out, right?
so no, because a trebuchet can launch a stone 90 kilos or 300 fucking meters, bro.
Yeah,
he's gonna bust that fucking wall, that castle.
I want to see a human trebuchet, dude. I want to see a fucking launch a human being. But
bro, we had one right next to my next village or whatever. They had a fucking trebuchet. They shot shit from it. Damn, that shit goes far. But again, you don't have to you don't have to know anything about like gravity or what like we have today. Of course, you can like look at a stone flying a certain distance based on your trebuchet or your catapult.
Yeah,
but it's like if there is like things that you can derive from that information about like how far things fly.
My only point is that you don't need to know the causal mechanism. Like saying, "Hey, yeah, we understand gravity," but that's two different. Like it's a very poor idea. That's all I'm saying. This is why Newton freaking didn't believe it, because it's a poor. The idea itself is poor. It's conflated. Like I said, big G and little g. There's the so-called universal law of gravitation, where two masses pull each other, but then there's little g. In the real world, we do everything with little g. We're not doing fucking gm1 m2 divided by r fucking squared calculations. We're just calculating little g. So, which is, like I said, is known empirically. So when we jump from that and start saying causes, this causes why? Hey, air pressure, that's caused by gravity. Okay. Well, what do you mean by gravity? Do you mean the fucking big G or the little g gravity? Oh, the little g gravity. Okay. Where's the evidence that fucking little g makes shit like gases fall to the fucking ground at 9.8 meters per second squared? There's no evidence of any of that shit. Or that gas can do thermodynamic work, or that gravity can do thermodynamic work, or that gravity can change. Think of how crazy it is to say that shit. That gravity would have to be, or little g would have to be able to do things like heat up matter and change the phases of matter and turn things from solid to liquid and liquid to fucking gas and like all sorts of shit.
Yeah, man,
if you had a gravity dial, right, and started manipulating your gravity dial, that fucking things would matter would change phase. Because it has to be able to do because the gas, it's a thermodynamic state. You understand? It's a state of matter. So that thermodynamic state has a certain behavior. And saying gravity can overcome its intrinsic fucking behavior of a gas, of what it does, saying, hey, gravity just stops it from doing what it normally does. There's no evidence of that. And that's a freaking tall claim, man.
Yeah, okay, like you don't have to go to this like specific level of shit, right? Like
I think we do for this, yeah. Saying they're fucking got machines fucking floating around fucking 1 million miles away.
Yeah, but it's like you don't have like pretty much with all science, you don't go to the absolute base level of why things happen, right? Like, well, that's actually like what physics does, but at some point it's like you like as a normal person, you basically can't understand what the fuck's happening, right?
Yeah, I understand, but like what we have here, Rusty, is on one hand we have the laws of thermodynamics, which have no known violations, and in fact, if you look at what's been written by scientists in the literature, Einstein said out of the 3 freaking legs of a stool of physics, thermodynamics is one of the legs, and if you took it out, the whole thing would collapse. Fucking Eddington, who was Einstein's buddy that supposedly confirmed his theory, his eclipse theory of fucking bending light. He said anyone that theory goes against the second law of thermodynamics is condemned to the greatest humiliation. So like it's like things like that on one hand. So that's what they say on one hand. And then they say gravity violates the laws of thermodynamics because there is no thermodynamic theory that actually incorporates gravity into it. You can look all through the textbooks, you can ask ChatGPT, you can look wherever you want, but there's no actual testable thermodynamic theory that has ever survived any laboratory experiment. So, like, we have a bunch of hypotheticals. The whole idea that gravity can create gas pressure and alter the thermodynamic behavior of gas is a hypothesis. That hypothesis has no evidence. They'll say things like, well, it happens on Earth, obviously, because it's obvious. There's this outer space thing, and we have gas pressure gradient, so blah, 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 right? No, it's not obvious. You have to be able to demonstrate in science your central claims through experiment. You just don't get a freebie of like, we can't test it, so we get to assume it's true.
Yeah, I mean, you don't have to use the word gravity or whatever. Like, you can use whatever word you want. But
yeah, I agree.
What like, if we go from like a base perspective, like let's say we are back in a fucking cave era or whatever, we don't have any like tools to measure it appropriately. Let's say we go up a mountain and we kind of we can feel it's getting harder and harder to breathe the further up the mountain you go.
You're right, just back to the natural phenomenon, dude. I agree with you. We observed that.
Yeah, of course, but you
why does it matter?
It doesn't. Well,
how is that evidence there's this thing called outer space vacuum?
Because you can observe.
Because we're going to go right back to where we started. Because it goes down forever, or does it stop?
That's the thing. Yes.
Then if it stops, why does it stop?
It doesn't
you
stop.
Right back to the same thing is what causes the gas to stop, right? What causes the gas pressure in the first place?
No,
you're right back at the starting point.
No, that's the thing. When you say it stops, that's not like a real thing. Like it doesn't stop or whatever. Like it doesn't stop. No, it's that's the word stop has no meaning in this discussion.
It means that the vacuum state can't get any lower. That's what it means to stop.
Yeah, but it's meaningless in this discussion. Because that's not what the vacuum of space is.
I'm trying to explain to you why it means something. Because then we're just quibbling about where the fucking boundary is.
Yeah. Well, actually, if you actually do you believe that the vacuum of space actually exists?
No.
Okay, then what's
I'm trying to tell you it's impossible.
Well, okay. So what's the point? What are we even arguing about? Like,
do you think it exists?
Yes, I do.
Why?
Well, that then.
Because you climbed to the top of the mountain and couldn't breathe, so you thought if you go a little bit higher, you're gonna fucking whiz around the ball?
No, it's one point of an information that I experienced.
Yeah,
and that I can think about also because I have a brain that I can think about and say, okay, if I go higher.
So it's hard to breathe up a mountain. Where does your brain take you from here?
Obviously, hypoxia.
No,
I'm trying to figure out what your logic is. It's hard to breathe up a mountain.
Okay, from this specific point of argument, like if you go higher up again, right? If you go increase your elevation, the air gets thinner and thinner, right?
Yep.
Yeah. So what would that tell
When
you.
does it stop getting thinner?
This is your logic.
That's never,
right?
never, ever.
It never
Don't
stops
ask me a
getting thinner.
question and ask
Okay.
us what it tells us. I asked you. You go up a mountain, it's harder to breathe. It gets less and less dense. And the question's for you to finish. It's your logic, dude. You're taking us somewhere. Don't ask us the question.
Okay. I mean, this like alone, like I'm not taking any point of evidence by itself and
This
not
was your evidence.
include it. No, I haven't made. Did I make any claim?
Yeah, we go up a mountain. It gets less and less dense. I'm waiting for the therefore.
Therefore, I didn't say anything after that. But you know.
Okay, so let me ask it like this: what was the point of the analogy being a caveman going up a mountain and he finding it hard to breathe? What was the point?
The point
what does that tell us?
Discussion that we had before about the
What Jedi's
atmosphere,
asking you is, what does that tell us about space by him going up and it's hard to breathe?
I know you want to say
this is okay. Hold on. I think I know where the problem is. So what you're doing is extrapolating. You're going from one pressure area to another one by raising an elevation, and you're extrapolating a continuation of that state, of that change, right? That there's a gradient that continues changing. We're asking you, you're extrapolating to what, to where? Does it end lowering pressure? Does it continue forever? Because if it ends, then there has to be a boundary somewhere. Okay, and even if it goes down forever,
no, that don't.
Right.
Go on.
Well, even if it goes down forever, then like you're gonna have to have some sort of fucking infinite universe, which contradicts the Big Bang. So like,
no,
I'm trying really hard to avoid like some infinite regression fallacy, right? But the point is that are we quibbling about where the air pressure, this extrapolation? Because like I said, like you admitted, is that like, is this hypothetical? And you said, yeah, probably, right? So like where it stops, how does it continue to go down? What rate is it linear? Is it inverse square? Is it adiabatic? Like how does it go down? At what rate? Like how do we know where it stops? Does it go down enough to allow space travel? Does it go down enough so that there's a vacuum sufficient to fly rockets from here to frickin' Mars in? Right? That's what we're talking about. We're talking about outer space that they claim exists. Is what we're talking about.
Yeah, but the thing is, I'm looking at the fact that if we go from sea level higher, like you elevate from that point, gas pressure decreases.
Yeah.
Right?
Yeah. Why are you okay, great. So we have two actually known values. How are we extrapolating it into unknown values?
So there's temperature.
What does that even mean? Like it's
we're extrapolating, dude.
Yeah, of course. Okay, so can you extract some information from that fact? Like,
yeah, we've got gas pressure that changes.
Yeah, we got 15 pounds per square inch of sea level. We got freaking 10 pounds per square inch on top of Mount Everest. Okay, now what?
Okay, like it gets lower and lower the higher you go.
Okay.
Okay.
Continuously, forever?
I mean, is our next question what caused that?
The cause is the point, probably.
Yeah.
So on the...
So what causes gas pressure?
I'm going to ask you that.
A container. It's defined as the force that the gas exerts upon the walls of its container. It's also the thing that keeps the gas here and stops it expanding into an available volume of vacuum if there was one.
But wouldn't the gas pressure be equal everywhere if it was
the temperature equal? Is the gas produced in the same place the whole time? What? There's multiple variables now. Temperature.
It's called thermodynamics. We're not doing thermostatics.
Okay, so if you had, like, if there was a container that was like like a fucking iron or like a glass thing, like a.
Is this container static?
What do you call it? What do you call it? Like the firmament.
Don't worry about that. This container, is the environment static? Does it have variance of temperature, for example? Does the temperature come and go, for example? Is the gas produced inside the container, or have you just added it to the container? Is the gas dispersing into the environment? Is the water in the environment?
Yeah, that's
in your imaginary container.
Fine. Yeah, I can imagine that.
Okay,
of course.
So it'd be like the Earth, then, right? A very, very, very dynamic thermodynamic system. Right? That's what the Earth is. It's a thermodynamic system. Now, within the laws and definitions of thermodynamics, to have this environment, the thermodynamic system must be closed.
Someone hot micing? Or am I going crazy right now?
What the hell's going on?
Why would you enter the chat with an open mic having a conversation with somebody?
I'm talking about a thermodynamic system. For it to exist the way that it does, it must be closed.
Yeah, he was muted. Yeah, go on.
No, that's it. It must be closed.
Yeah. It doesn't have to be closed, though.
Yeah, it does. Or the gas would expand into another available volume if that available volume was vacuous and available space. If the gas is not contained, entropy will increase and the gas will continue to expand because of the energy that's held within the gas is given to it by temperature. So because of the temperature, the gas is always going to move and collide. Because of these random collisions, it's expanding. You need a closed system to keep the gas in.
But if it was expanding, like how would you be able to like live in a in an enclosed environment? Like if you if you like right now, of course, like the sun is putting
the sun.
Energy.
No, we're talking about gas behavior, right?
Yes,
we're talking about how it expands into volumes and how we have pressure. We got to the question after discovering that there's a gas pressure gradient. The question was, what causes that? Well, within thermodynamic law, we're going to require a container to stop the expansion. The consequence of the containment is pressure.
No, but you have
no.
You don't even have to like refer to gravity because
no, we're not talking about gravity. We're talking about what caused gas pressure. And at the moment, I'm waiting for you to concede that yes, containers cause gas pressure.
It does what?
I'm waiting for you to concede that yes, a container, a limitation of volume that holds gas, is the necessary antecedent for gas pressure. It's the consequence of containment. PV equals nRT, the force that the gas exerts upon the walls of its container.
Yeah, but it's not the cause, though.
Sorry, it is not the cause?
It's not.
So it's not the cause. The gas exerting its pressure upon the walls of its fixed environment, a closed system. Like, for example, when you put gas inside a tyre, by consequence of you putting that gas inside that fixed volume, because of the movement of gas and the density of that gas, it will be under pressure because it can't go anywhere.
Yeah, but what's the cause is the pressure itself. It's not a container. In that case, like it's the same.
Again, listen. Force over area. Gas pressure is caused by the force of the gas pressing against the walls of its container. If you don't have a container to press against, you don't have pressure.
Yeah, and then we go back to gravity, and then all of a sudden it's completely different.
You go back to gravity. I'm still waiting for you to concede.
About a, I mean, I
Gas is caused by the force of the gas exerted upon the walls of its container.
Well, the cause thing is the problem that I have right now.
Okay.
Because I was told that you can't really. You can go deeper and deeper and deeper at some point.
No, I can put gas inside a container, and by consequence of that action, the gas is under pressure. Because the way that gas behaves is it wants to expand. It can't. The container's in the fucking way.
Yeah, I understand that. Yeah, I agree with you.
Yeah, good. So that's what happened then. In my little experiment.
If I say that gravity creates a gradient, and someone
then
tells
you
me
can say that, but you would have to demonstrate that in an experiment.
See, like that's the difference. Like,
yeah, you can't do an experiment. I've just given you one, and you keep going, nuh-uh.
No, the demonstration would be pretty fucking obvious if you go up a mountain. Shit,
no, that's you begging the question and affirming the consequent.
No, it's an experiment towards some.
No, it's not an experiment. It's the observation of a phenomena.
Yeah, and okay, what we can use a different word than gravity.
It's not an experiment yet. It's not even a hypothesis until you make a supposition of cause of the phenomena that you witness. At the moment, it's the caveman changing his altitude and finding it hard to breathe or not.
Yeah, which has been done.
Yeah, so that's the phenomena.
And
we agree. Now, what causes that?
Yeah, that's the same thing. Like it's the cause.
Yes, what I asked you 15 minutes ago. Yeah.
Down. Yeah, so like you can't put it down to a cause at some point.
No, we're asking what causes it, and now you're saying no, we can't put it down to cause, even though you want to assert the cause is gravity. Like, can you stumble over any more words?
No, at some point, of course, it would be gravity, but of course, like if you don't accept that, then
it's not whether we accept it; it's whether there's evidence or not.
Yeah, that's the thing. I mean,
you don't have the evidence. So yeah, that's the thing. The real question is, how come you accepted it without evidence? That's the real question. They showed you a diagram in freaking kindergarten. Look, this is how it works. And they drew a circle and they drew a bunch of arrows to the middle of the circle. And they're like, this is what holds the gas down, these arrows. And you're like, okay, teacher, I believe you.
I'm just using a word.
It doesn't matter what you call it.
A concept. Right? Like everyone else does.
Yeah. But what I'm saying is there's no evidence that concept is actual existent in reality.
It depends what evidence you accept.
Experiment.
What's your evidence? What's your evidence?
You accept.
But as you can, first off, you can drop an object, of course, it goes down to the ground.
Oh God.
You can have a satellite.
Are you like in some weird loop, dude?
What are we talking about?
Yes, circular reasoning loop.
Sorry, we're not talking about the behavior of rocks. We're talking about the behavior of gases. So in your analogy, or your demonstration, can you use a gas?
It's a completely different thing, which we just talked about.
Rusty P, the airbender. I want to see you throw gas.
Here's your reasoning. I really want to pass out his reasoning, bro. Like, okay, so he goes, we have a 14.7 at sea level. I climb the mountain and it's like 11, right? PSI. And you say, what causes that? And he goes, gravity. And he goes, and then we say, oh, what's your evidence of that? And he says, well, there's 14.7 PSI at sea level and 11 on top of the mountain. That's my evidence.
No.
It's circular reasoning. Yes, that's what you literally did. I've been listening to you.
Yeah, but we are talking about one specific thing, about the gas pressure. And I'm not saying, like, of course, like there's gravity underlying the whole concept of it. But I'm not saying like it's like if we just look at the gas pressure decreasing the higher you go, you don't have to invoke gravity or whatever. It's just like an observation. Like you don't have to make any you don't have to like what do you say it?
Come to a conclusion?
Yeah, you don't have to draw any conclusions to it.
Okay, so it was a waste of time for the caveman to go up the fucking mountain in the first place then. Not being as we're not coming to any conclusions, otherwise we just observe a change in gas pressure and it's harder to breathe up the mountain. According to you, you don't need to reach any more conclusions.
No, the thing is, if you go again, like if you can observe that you can go up a mountain, right? And you can just increase your elevation and you feel that the gas pressure is decreasing, right?
Mm-hmm.
What would that like for like I mean,
getting further away
right?
from where the gas is produced.
No, it doesn't have to be.
Hold on, you're gaining altitude within your example, going up the top of a mountain. Gas is produced on and within the surface of the Earth. I mean, let's take an observation of our whole environment. It's also cold up a mountain. We should probably take into effect the changes in temperature.
Yeah. Also,
yeah, fucking dynamics. Let's include the temperature as shit. Let's also include where and how the gas is produced and cycled and reabsorbed into the environment.
Yeah, and what like could you like draw some information from that?
Yeah, the further I get away from where the gas is produced, it appears to get less dense. The temperature also appears to decrease. It's cold up a mountain.
Yes.
Yeah, cool.
Yeah.
So we seem to be talking about thermodynamics, temperature held with gas, its behavior relative to where it's produced and its environment, the changes in the environment over time. Sometimes it's warmer up a mountain.
Yeah, but compared to the base of the mountain, and at the same time, probably like colder, right?
Yeah, sometimes, and I say sometimes, like throughout the year, shit changes.
All the fucking time, basically.
Yeah, shit changes. Weather changes. Yeah, all of these things. Yeah, the amount of water held within the gas in the atmosphere changes. Yeah, all of these things, dude.
I understand that, but
good. I'm glad. Why did we start talking about gravity? You haven't even mentioned any of the other observable things. Got cold up that mountain, didn't it?
No, the thing is that you can derive information.
Sorry, we're talking about gas behavior.
Yes.
Yeah, that's going to include the temperature of the gas, isn't it? We understand how different temperatures of gases are going to act differently because of the amount of energy that's held within the gas. Hot air rises, for example, cold air sinks.
Right.
Yeah.
Oh, damn, I got a fucking...
I feel like I'm educating you, your caveman. You're asking what conclusions we reached, dude, and you just want to jump to gravity. Haven't mentioned anything else.
I don't have to. I don't have to do it. It's just like gravity is a name of a thing that people understand, right?
That has nothing to do with gas pressure.
Yes.
You can look through all the books on the criteria gas, and you're not going to see any gravity mentioned in any of it.
Yeah, here we do, though.
Not even within the kinetic theory of gases, it tells you there is no force of attraction between the container walls and the gases. The container wall isn't acting upon the gas and, over space and time or whatever, pulling the gas towards it.
Gas moves freely and randomly in all directions, dude, colliding with itself and the walls of its container. We don't have to talk about gravity because it's not included. It's not observed.
Okay. Well, you claim that. That's fine.
Just cited the kinetic theory of gases. Would you like me to put it in the side chat? There's no mention of the word gravity here. There's also not a G in P equals nRT.
There doesn't have to be. And I haven't even said anything about it.
Have to be gravity in gas behavior, even though you're trying to shoehorn it in, saying it does actually act on gas.
No, I'm saying that we can observe certain things and you don't have to refer to gravity at some point. Like I did it, but
yeah, we understand that. You're making the same arguments over and over again. They're addressed. We don't care what you call it. We don't care about any of that shit. We're talking about its possibility. Is it possible to restrict the behavior of a gas based upon some force? Call it gravity, call it whatever you want. The observation we have is low pressure on the mountain, high pressure on the at a lower elevation. So what? Doesn't logically follow that continues forever or stops at any particular point. We have a surface on the surface of the Earth. That's fine. Where's the other surface?
The other surface?
Yeah, you need another surface, dude. Gas pressure is the force exerted on the walls of the container. If you don't have a surface at the other side of the fucking boundary, the gas just fucks up to forever.
Okay, if you think that, like there's...
It's what's demonstrated in nature. It's not what I think, dude. I can demonstrate this in nature.
Okay, demonstrate it, please. You can just explain it to me. Please explain it to me how gas pressure only is able to exist in a container, please.
Can you demonstrate it in any other way?
You said demonstrate it, right?
No, you demonstrate it.
Yeah, okay. Got a bike?
The claim that you have.
You got a bike?
I have a bike, yes.
Okay, try to pump up the rim.
The what?
The rim. Pump up the rim. Create gas pressure next to the fucking rim without the tire, dude. The rim is one surface, right? There's no opposite surface. Use your pump to pump up the rim.
Okay.
Okay, you can't do that, right? But if I take a tire, I take an opposite boundary, now I can create pressure. Wow. Now you have gas pressure because you have a container. No container, no gas pressure. Container, gas pressure.
What's around you right now?
I don't know, but it's not fucking nothing.
Yeah, but isn't there like a gas pressure thing going on around you right now?
Yeah. The gas that I'm surrounded by is pressing inwards in all directions into the space that I occupy. Yep.
Yeah. And Indio says that if you put pressure into a tire, or whatever he said, that's only the gas pressure. So there's gas pressure existing in a container, of course, which would be the tire. But right now, around us, also there is gas pressure.
Yeah, what causes
existing around it?
Yeah, what causes that?
Well, again, we would go to gravity again, but
no, again we would go to a container. Fuck.
But why? But why? Like you're saying. You're saying
so brainwashed you can't even admit this clear and obvious truth. You require a container. As soon as I asked you what causes the gas pressure that surrounds us, you jump to gravity and completely disavow any mention of the word container.
We have just talked. We have just talked about gas pressure in a container when I guess Indio was it about pumping up his fucking bike tire.
Yeah,
right?
we're looking for another causal mechanism that causes gas pressure that we can demonstrate. Or the claim that you say that we can't demonstrate this. It's called entropy. Every single time we open a container of gas to a lower pressure environment, the entropy increases and the gas fills the space and might equalize in a low volume.
Yes.
You don't have an experiment for your claim, though. That's why Injo put the gas inside a tyre. He did that. You can do that. Now, what can we do for gravity apart from go up a mountain and make big-ass jumps of logic?
To go to gravity, it's just a thing where when you claim gas pressure cannot exist without a container.
Then show another way that can.
But it's like fucking obvious. Like
No, it's not obvious until you demonstrate it. Apparently, it would be obvious to you that there was a container and it has to be demonstrated to you 5 times. So we're going to need demonstration.
Oh my God.
Actual physical reality taking place.
Yes, physical reality is taking place all the fucking time, and you just can't fucking see it.
You're broken. Just give an experiment where you very manipulate gravity to cause the phenomena of pressure.
We're not talking about gravity.
You keep fucking bringing it up. You wanted to 2 minutes ago, then you got upset. Are you really this broken?
I said before that I didn't want to bring up gravity.
And stop bringing it up.
I didn't bring it up. You brought it up.
So the gas around us that we're surrounded by, what was your point?
There's no point.
Oh, so again, he brings up a subject that has no fucking point. I swear it was gravity. Please follow your own fucking words. I am. You're not making any sense, and you keep contradicting yourself.
No, I don't. If we are agreeing that
stop him.
We don't.
Someone.
What are you saying, bro? Like, if we agree that we don't bring up.
You said you didn't want to bring up gravity.
Yes.
So what was the point of us being surrounded by gas? According to you, no point.
The question is on you.
You're just lying.
The question is on you, man. The question is on fucking you.
What? To demonstrate there isn't no other way to cause pressure?
Yeah, you said that like gas pressure can't exist.
You're making a claim it's caused by gravity. That's your claim.
No,
your claim is in violation of the second law of thermodynamics. We've been over and over and over it with you.
No, you are cycling back about the gravity shit. Again, I said
someone else talked to me.
No, you did it. Again, like I said, we go away from the whole like gravity shit from the overall.
You brought up 2 examples: one, a caveman going up a mountain and experiencing it hard to breathe, and then you brought up there's gas surrounding us. At no point in these conversations did you want to bring up gravity.
Yes, I especially said because you bring it you bring it up all the way.
Like all the time. Fucking self, dude. Have some fucking humility. Like, please, I'm begging to your better nature.
Yeah, I understand. Like, come on, like
I'm gonna go walk my invisible dog. Someone else can talk to you.
Yeah, go on. Is there any flat earther still here that wants to debate?
What are we debating exactly? Ideas versus evidence?
Yeah. Again, the same thing that who was that person before me that left? So I guess he misunderstood the whole fucking debate. Or he deflected. I don't understand.
Who, Jedi? Who are you talking about?
Jedi. Yep, yeah. He, like Jedi, yeah, probably. Which is the person that I was debating about against. I mean. It seemed like he was
like I told you, this is a common thing that happens. You have ideas. We have evidence. You won't let go of your ideas. When you first heard the idea of outer space and that gravity creates gas pressure, how did you evaluate whether that claim was true or not? Like, what did you do?
That was the thing where we ended up at the end of our debate. Like, I was trying to say that, okay, we don't use that word. We don't use the word gravity.
Why aren't you addressing what I said? That has nothing to do with what I'm talking about. I'm asking how you evaluated it in the first place.
Well, we had that debate topic at the beginning of our discussion that I had with them, but
talk about you. When you first heard it, when you were a little kid, what did you do to evaluate its truth?
I just look around at reality. It's not specifically gravity, but
you looked around at reality, and you concluded that there's no container for the Earth.
That's not the conclusion that I made when I was a kid.
I just want to know where you get the idea that somehow gas pressure is the way you think it is for the reason you think it is.
Could you form a conclusive question, please?
And I just want to know why you think that gas pressure is the way it is for the reason you think it is. And you can't tell me the reason. You're actually trying to reject your own reasoning. You're trying to throw gravity under the bus and say, hey, let's not use that word.
Okay,
so no other mechanism you can point to say, hey, we have gas pressure without a container.
Well, that's actually kind of what it is. It's the best explanation that I have for how if you want to say gas pressure, of course, but everything around the Earth, like how the physics work, kind of. Yeah, gravity is
We're
kind of
giving you the physics. They don't work.
Well, they kind of give the best explanation.
But the best explanation has no evidence. So if that's the best explanation, it's like, I don't know what to tell you. If your best explanation has no supporting evidence, I don't know what to tell you, dude.
Well, there hasn't been any other big explanation or big evidence thing that has been coming out that explains the word any differently. So
that explains the gas pressure gradient.
Yeah, gas pressure gradient.
Here's one.
Pretty conclusive.
That gases are created on the surface of the Earth. And what you have is diffusion, the diffusing of gases from the surface, and that's why there's a gas pressure gradient.
Okay, I haven't really experienced that. That things.
What are you talking about? It would be exactly like what you experience now.
If gases are being expulsed from the Earth.
Not only that, but they're being created on the surface of the Earth, as in, because of thermodynamic processes, chemical reactions, things like that, gases are created on the surface of the Earth. Right? So when you have so what happens when you have a chemical reaction that turns some group of molecules into some other group of molecules, and then it emits a gas? That gas pressure in that region goes up, right? But then the gas diffuses into the surrounding area, and you will have a gas pressure gradient from the point of the chemical reaction going out radially from there.
Yeah, so?
Yeah, there's your explanation.
All right, I mean,
and funny,
I wasn't asking.
This is what the Chinese thought way back in the day. They had a name for it. It was called the air wind or something like that.
Yeah, but like do you think that we live in an enclosed space?
Yeah. So we have to. And that's what we've been trying to tell you for 2 hours now, is that we have to. It's not opinion.
Yeah, but
like opinion. The second law of thermodynamics is a natural law. It's a law of nature. It's not an opinion. It's not what I think. I go, hey, what does the second law predict? It predicts this. Okay, that's what's going to happen.
Yeah, but it doesn't. It's not a law that applies to your worldview.
What are you talking about? I'm talking about the second law right now. You're not. You're making up your own bullshit.
No, if you would be in an enclosed space, at some point the energy would increase more and more and more, and you would just fucking die because it's getting hotter and hotter.
Because temperature radiates infrared radiation, so the energy would. So, for instance, if you take a blowtorch and you heat up poker, it doesn't heat up forever. It'll reach a certain level of equilibrium where it stops heating up. Right? 500 degrees Celsius, whatever it is. It'll reach an equilibrium.
Yeah,
but the Earth is a system that is in constant flux. It is dynamic. It's never going to reach equilibrium. Probably not in your lifetime, at least. And it radiates heat through electromagnetic radiation. So it's never going to keep, the temperature's not going to go up and up and up forever.
Well, if it's, I mean, in real life, as like if you are a glober, of course, that makes sense. But if you are if you think that the Earth is enclosed in a, I don't know, like a dome or something like that, then that whole system doesn't make fucking sense.
Is that like your argument? So your like counter argument to what I said was, if you're a flat earther, that whole argument doesn't make sense. That's your counter argument.
Yeah, if you think that the Earth is enclosed in a dome or whatever,
it don't make fucking sense. That's your argument. Great argument. It don't make sense. Great argument.
It doesn't make, like, scientifically, it doesn't make sense. Yes.
I just told you why it does make sense. I gave you the reason.
Okay, so where is the energy going again?
It's being radiated. Radiated. What is radiation? Electromagnetic radiation.
Yeah, so go on.
And it's being radiated away from the Earth.
From the Earth. Away from the Earth. Okay.
Away from the Earth. Like the electromagnetic radiation. So
yeah, I understand that.
You have a closed system, bro. Okay, you have closed systems and open systems. Okay.
What is the Earth?
In a closed system, energy can pass, but matter can't. In an open system, matter and energy passes. Okay. So we're in a closed system, as in the energy can pass, but the matter can't.
All right.
Now, do you understand? So we can emit radiation. We can take in radiation. We take in radiation from the sun. We emit radiation. It's called radiative cooling, in fact.
Yeah, but again, like if you would be able to...
Okay, you're going to tell me that we're not using physics now?
No, but if you have like a...
Is that physics, dude? Yes or no? Is that the common modern version of physics, of thermodynamics?
I'm saying about physics, though. Like, there's no fucking
thermodynamics.
Point. Yes, I understand that.
How can heat transfer? There's 3 ways. Can you tell me the ways?
What?
There's 3 ways for heat to transfer. Can you tell me the ways?
Right, no, radiation probably is one of them.
Radiation, convection, and conduction. Okay.
But Wait a minute.
Anything with a temperature emits radiation.
I gotta go.
All right.
We're gonna wait.
I'll see you later.
5 minutes.
It was very convenient.
If Earth is flat, why won't the sea leak to space and evaporate fully?
Say that again.
Earth is flat, why won't the seawater leak to space and evaporate fully in the vacuum?
Because outer space is fake and the air
Okay,
is
somebody
contained,
is laughing, I'm leaving.
it has to evacuate into a thing that doesn't exist. That's why.
Well, it's just ironic. That's all. Oh, bro, don't be a.
Wait. You're
snowflake.
saying space doesn't exist?
Yeah, we don't think that the Earth is a disk in outer space. That's not what we're saying.
You don't believe that
so
there is
outer
vacuum
space,
outside the space in the space?
if outer space doesn't exist, there's no vacuum for all of the air and water to rush off into.
But yesterday when I asked about seawater, why doesn't seawater go outside the earth and stuff? Somebody here who was a moderator told me, yeah, outer space is like a vacuum, and inside the vacuum, water evaporates immediately, and I don't know, stuff like this. So,
That's the story, right?
But you're saying there's
the
no outer
story
space.
is that the sphere Earth is surrounded by a vacuum, right? But in reality, when you have water in a vacuum, it evaporates. Yeah, that makes sense. So
Yeah, okay, but
outer
why doesn't the
space
water
doesn't
evaporate?
exist because outer space is a vacuum. You have water on Earth, right? So there's no vacuum.
Yeah,
Because
but
in a
why
vacuum,
water on Earth? But why doesn't the water in the edges of the flat Earth leak and go like fall?
There's a misunderstanding.
Fake. So there's no
Yeah, there's
disk in outer space. You're inside of
right.
a.
There's a misunderstanding.
Yeah.
Clear it up for him.
Since outer space is fake, there's no disk in outer space, so there's no water falling off and leaking into outer space. It's a contained system. Water is contained, the gas is contained, there's no vacuum.
What are the stars that we see at night then?
They're lights, and I don't know what they're made of, and I don't know what they are. I don't know how high they are. I know that they're there because I look and see they're there.
Oh, I think that was too much for him.
I broke the script and he doesn't know what else to say. Damn. Leave.
Yeah, I have a question too. So, like, if gravity is supposedly holding or creating the container, why can't it be performed on Earth, like on the surface? Why can't they reconstruct that experiment?
I don't know.
You'd think they could, right? So they could have like a significantly sized vacuum chamber and just insert the tiniest little bit of gas into it, right? And it should all just like settle at the bottom.
Yeah, like
and do what?
Well, gravity's stronger the closer you get to the Earth, right? That's where so it should be easier to create a container using gravity down on Earth than it would be closer to space.
Right. So I think that they'd say that like so the kinetic energy that the gas has, right, is they can't though, can they? So they're saying that the kinetic energy the gas has at the surface is greater than the gravitational influence. I will say.
Yeah, that's how you have evaporation, right?
Right.
Yeah.
Because gas molecules moving at how fast is it? Like 500? Is it 500 meters a second or something like that?
Way more than
Gas
that, man.
particle?
Thousands.
More than that? Oh, thousands. Okay. Well, yeah, I'm way off. There you go. Yeah.
It depends. It depends. I mean, like if you cool down a gas and you see it clumping together like in a sink, like let's say you take frozen oxygen, plunk it in your sink, and you watch it sublimate or something, you're going to see it go from a solid state to a vapor, and it's going to bypass the liquid state altogether instantaneously. And as those molecules heat up, I mean, they're just going to go faster and faster and faster until they equilibrate with the environment. So when it leaves your sink, they're not going to be moving very fast, but if they're allowed to continue to heat up, they're just going to keep going and zooming. Like, you won't be able to see them.
Right. So I guess they're saying that so the gas's kinetic energy is very great, but as it ascends, it gains potential gravity energy. Right?
Yeah. I don't know what to call it. I'll go with that too, man. What do you call it when you pick up a rock from the ground? You lift it up high.
Yep. Potential energy.
Yeah. The rock isn't moving and you're holding it. You're holding it. And they could maybe like set it on a shelf and the shelf is now holding it. Mic check. Am I coming in? Was I just getting cut off there?
My shit made me jump out also. So I think it was Discord.
Okay, so I was saying, like, people ask how does an apple fall from a tree? I was going through the process of, well, somebody takes a seed, the seed turns into a sprig, which turns into a tree, the tree grows, and then it bears fruit. The apple literally came out of the ground and was lifted up. And then when the apple detaches from the stem, it falls back to the earth where it came from. So the cycle's complete. But people don't think of energy like this. They don't think of the transfer of energy in these terms at all. So like if you were to pick up a rock and you were to place it on a shelf, maybe on a ledge, and a guy a million years later came and saw the rock on there, knocked it off the ledge and it fell to the ground, he would have no idea that rock had all the potential energy built up from what was required from somebody a million years prior, expending heat and calories to pick up that rock off the ground and lift it up, increase its energy state, and stick it onto a shelf. People don't think of gravitation in these terms. And I'm old enough to remember when that's how it used to be taught in school, honestly. I mean, it's not saying that we know what it is. Nobody's attributing like space-time or mass attracting mass causes. It's really just an exchange of energy.
Yeah, like an elastic band, but without the elastic material.
Yeah.
Yeah, basically nothing moves, right? Nothing falls without some type of energy exchange, some type
That's right.
It has to be forced out of its natural state of rest by some sort of energy exchange, essentially.
There's still there's people still looking at it as a mystery and coming up with alternatives to what's been presented over the last couple of 100 years, right? Or few 100 years.
Yeah.
I mean, I just read an article the other day about it they're considering it to be more of an entropic effect, right?
Love it.
Like there's just all these different ideas about it. They're still throwing it around, like like it's a ball to be played with, right?
Yeah. Yeah, I mean it's funny that they call it an entropic effect when currently when it's been described by people coming into our Discord as a negative entropic effect. It's reversing the entropy of gas molecules. Which is funny because gas molecules expand without work, right? It's like saying that picking up the rock and putting it on the shelf was done without work. Gas molecules expand from the source without exchanging energy with the environment.
That's fucking gosh.
Think about that for a minute. So it's not analogous. Like when the sun releases like UV light and it slams into a rock and the rock chirps off some kind of nitrogen molecule that then like flies up into the air. Is that the same thing as picking up a rock and putting it on a shelf? Well, the funny thing is gravity doesn't pull down on that nitrogen molecule. But it does pull down on the rock. The nitrogen molecule expands without expending any energy into its environment, without that exchange. But the rock that you pick up absolutely does. So it's weird, man. Like gas molecules are weird. Unbonded matter seems to obey a different set of principles than solid matter or bonded matter. I mean, they call it the different states of matter, right? So the different states have different principles that apply. Go ahead, T-Dub.
Well, it's just I was listening to Richard Feynman speak, the other day, and he though he's advocate for the idea of gravity, blah blah. Even though he'd probably tell you at the end of the day, hey, look, I got no idea what it is, right? But he was talking about the electromagnetic force. He's saying how intricately that is, inside everything, right? Like, and it's like dictating everything. He's like he really loved that force, and he's saying it dictates our reality. He was saying like everything's held together by it, everything or other things are repelled by it, right? Like he's during his little speech on it, on that, he wasn't discussing gravity. It was like gravity took a back seat, or wasn't even invited to the party. You know what I mean?
It's funny. That's true. He is like that, and a lot of engineers and scientists seem to have that same sentiment. I mean, I happen to know quite a few engineering graduates from Rensselaer Polytechnic, and one of them was telling me that anytime gravitation or gravity was brought up on any of his exams, you just ignored it. Ever really thought about it like that? He was an aerospace engineer, and imagine that. Imagine being an aerospace engineer. Imagine taking graduate level engineering exams and not considering gravity to the extent that people do here when they come in and talk to us.
Well, I guess in that field, you're really only concerned about the effect, in the environment that whatever you're building is going to be operating within. I guess you're not really concerned about overarching, cause, right? You just want your device to operate correctly and safely as possible.
Right.
And you really only need to be concerned about the effects. As long as you understand what's going to happen to your device within a specific environment, that's all you need to really account for, right?
Yeah, you could consider gravitation as an effect, as the phenomenon that's observed, and we don't know the actual cause. But what it does describe is a statistical distribution of density, which is not necessarily related to the atmosphere. Because you can't predict, you can't take the inverse square law, apply it to what the mass of Earth is supposed to be, and then predict how much the atmosphere thins out from the center of the Earth to the surface and the surface out to space. Because what we observe in this gradation, this thinning out of the air, does not comport to the inverse square law at all based off of the mass of the gases as it's currently understood. And the ad hoc rescue devices, well, it's a dynamic system, the globers will say, and they sound like us, and be like, yeah, they're at different regions of the atmosphere, you have different effects happening, and at some point you get to the thermosphere where suddenly it gets hot again. It was warm at the surface, and then it got extremely cold, and then it started getting warmer again. So you have a real mess. You have this non-uniformity of everything stretching from the surface all the way up into whatever does not comport to the inverse square law at all. What I find funny too is when they say that, well, the gravitation of Earth allows you to accelerate tangential to a supposed curvature of the Earth. As long as you move in one direction fast enough from a specific height, and your speed your velocity according to that height, you're going to be falling forward. Your gravitational vector is no longer inward towards the center of the Earth. It's going to be tangential to the curvature of the Earth.
Yeah. Where's the satellites that are that are orbiting against the rotation of the Earth?
Yeah. So what about all the gas molecules? They expand in all directions. They go this way and that way and all over. Let's say you have a source of gas production from the surface, as it's currently known. It's where gases are produced on the surface of Earth. You've got a bunch that are going to be flying somewhat tangential to the surface of the Earth at thousands of meters per second. Are they going to be doing geodesic arcs? Well, and the Glober would say, well, yeah, they will until they collide with other gas molecules. And here's what's really funny. I'm also old enough to remember being taught that gas molecules are so small that the chances of them bumping into another gas molecule is basically infinitesimal. Such as, you don't even have to consider it in most circumstances, except for, very specific cases, laboratory conditions, and things like that. But in nature, you're not going to expect it to happen. But nowadays, you read about gas molecules and it suddenly feels like it's a bumper car full of 10-year-olds just slamming their cars into each other on a track, every which way in that. And this is what prevents their own claim holding consistently of gas molecules no longer traveling in straight lines linearly, but taking geodesic paths. Before we can even we don't have a chance to falsify that because it's going to collide into another gas molecule. So they make their own claim unfalsifiable by now saying the gas molecules are bumping into each other like 10-year-olds in a bumper car track. That, 30 years ago, they weren't saying that in school when I was young. They weren't saying that. They were saying that space is so far spread apart and the atoms, the molecules are so tiny, the gas molecules in the air never even know each other exists. Like, just passing by each other. So, it's funny to see the narratives change. You live long enough and you start to see these changes. Like when I was young, NASA images were always composites, artistic renditions, and everybody knew that that NASA was a big art house. And somewhere around, I would say maybe the mid to late 90s to early 2000s, with the last of the space shuttles and the beginning of the ISS, things started to change. NASA stopped putting these captions underneath these images. I mean, I was a big NASA junkie growing up. We lived in a NASA household. I've got postcards from the Houston Space Flight Center from like the 1980s. I got family members that used to work in astronomy, radio astronomy, satellites. So it's just really interesting, man. Like I was locked into this. I remember being young, dude. I remember like when they said that the first image of Pluto was coming in. Maybe it had already come in by this point. I hadn't seen it yet, but regardless, it was brand new when I remember this happening. And I remember thinking to myself, I was already skeptical, like NASA being a big, gigantic art house. Like my mom and dad would talk about this and we'd bicker back and forth. My dad used to think like I do, if you know what I mean. My mom was the one who was connected to NASA and in working capacity at one point. But I remember thinking, wow, wouldn't it be funny if like somehow Pluto, the dog, like found its way on the planet's surface of Pluto when they show us the image? And then I looked at the image. It was like in like a Sky and Telescope magazine or something. And then I turned the page and there it freaking was. I'm like, you gotta be kidding. It's a silhouette of a freaking Pluto dog on Pluto. You gotta be kidding me. You know, I was in my teens or something. I remember looking at that and I mean, I was like, this is just stupid. I still believed in outer space. I still believed in the Big Bang. I still believed in satellites and astronauts and space shuttles and all that stuff, the moon landing. It was all near and dear to my heart. But I was like, what the heck is wrong with these NASA people, these artists? This is just not right. Like, you guys, NASA, you got to hire some more honest artists because this is terrible. It's so on the nose. And then fast forward on like 15 years when one of the blue marble images of Earth came out with the clouds that had SCX written in the clouds, just like what happened in Lion King, which I think came out a few years prior, the movie with the SCX with the leaves.
Right.
You know, I'm like, oh my gosh, this is so stupid. You guys, again and again, and my belief started to crack at that point.
And it seems like a recurring trend. I mean, we like around holiday events, and we get images released from the space agencies, like Halloween. Oh, we just happened to find this skull-shaped galaxy. Like look at, or nebula or whatever. Like, look at this quasar that's emitting light like a Christmas tree.
Wait,
Right?
didn't they say Uranus? Didn't they say Uranus stank or something like that? It had like smelled like gas, like a farts or some shit like that. I remember reading about that.
Yeah, that it smells like
methane or something.
Yeah, they're literal.
Smells like farts.
Uranus that open up like sulfuric fart smells. Yeah, like what? Oh gosh,
Yeah.
it's gotten worse over the years. I got to
It'd be
say,
like if
peak
they
NASA was the 1980s and early 90s, and it just got worse.
right. It'd be like if they turned around and said, like, scientists have just discovered that Saturn's rings actually contains a lot of gold, and ironically enough, embedded in it is a giant diamond.
Oh man.
If you ask the internet the question just right, you can get it to say that Jupiter, Saturn, Uranus, and Neptune rain diamonds.
And now, like, black holes are
They what?
hairy.
Oh yeah, the hairy black holes.
It just keeps digging further into the barrel of degeneracy. It's unbelievable.
Well, didn't Walt Disney and they had like Satanists like Jack Parsons, like didn't they have a what was the Nazi, the German, his name escapes
Von
me.
Braun.
Yeah. Didn't they have didn't like Walt Disney have a lot to do with NASA, right? Or did I read that wrong?
Disney and Von Braun were best buddies.
And then you had like Jack Parsons, who was like a known occultist who was like known for doing like sex rituals and followed that
Friends
Thelema.
with what was his name? Friends with the
Aleister Crowley.
Crowley. Yeah, thank you.
Yeah, Crowley. Yeah.
Impregnate a woman, like
on the blood moon.
Yeah. Oh, jeez, dude. It's so sick. I mean, that's why JPL's called Jet Propulsion and not Jack Parsons Laboratory, as it was originally named. They had to divest themselves a little bit from that, but they still retain all their freaking weirdness.
Another thing I always found interesting was the fact that NASA, like, so when they do their countdown, they would do like the T minus, they do like T minus 10, 9, and then like if you add T to NASA, it would spell Satan. I always thought that was kind of weird. Maybe it's just coincidence.
Yeah. Yeah, they minus the T. Yeah.
Tsukuyomi in the chat seems to be interested. Asking questions about the sky and the luminaries in general. It's a mystery, man. I don't know if he's listening, if he can hear us talking, but if not on here on YouTube.
He wasn't in the BC. He just didn't open his microphone.
Okay. I mean, for everybody else, I mean, my personal take is the sky is so beyond our comprehension. You really have to scale it back. Like, you have to scale it back. No, the moon landings didn't happen, so we didn't go there. No, we don't have Voyager space probes going out beyond the solar system. That's not true either. Scale it back. Scale it back about 100 years. There's a starting point to scale it back further. We don't know anything about these things in the sky at night. The celestials, what their distances are, what their composition is, how they manifest, or anything like that. We don't know if the way they manifest is completely observer dependent or not. If there's a medium, an exotic medium up there that is responsible for its apparent observer dependent behavior, or if it's medium independent and has more to do with our perception, the interplay between the biology of our eyes and our brains.
We're in
We
a
don't
video
know
game,
if,
bro. We're in a
huh?
video game on some kid's computer in his basement. This is all
No.
in the Matrix.
Flat, if that's the case. You know, people say that they can use the stars to navigate by, but to what degree of accuracy and how do you validate it? Do the stars, like Polaris, really shift 69 miles per degree? Is that the same everywhere? Is it symmetrical? Is it asymmetrical? How do you account for the distance when you're in the middle of the Pacific? 2,000 miles from land in all directions. 4,000 miles from land in all directions. How do you even begin? Oh, you're going to use GPS? Well, that's circular logic. Go ahead. Someone open their mic. Oh. You know, we use the sun to account for time. Universal time, UT. You have what the sun does when it goes from one point in the sky and returns to that same exact point in the sky after about 365 days and some change. You've got clocks. You've got really precise atomic clocks, like your microwave. Your microwave clock keeps time to like the 10,000th decimal of a second or something ridiculous. And the sun seems to be less reliable, is more variable than your microwave clock. Every now and then you'll catch a glimpse of this. You'll see it in the news, like, oh my gosh, is Earth speeding up in its rotation? Is Earth speeding up in its revolution around the sun? What is going on? I'll make a big deal out of microseconds or nanoseconds, whatever. Maybe more variable than that.
It's okay. When their clock starts getting off, they start saying things like, well, the tsunami caused the Earth's rotation to go backwards a fraction of a second, even though nobody knows.
They'll say that, but here's the thing. I think, and I may be wrong, somebody please correct me. I think they actually take their atomic clocks, which are, I would want to believe are super accurate, but there's some reasons to believe that they may not be, you know, due to like electron orbital decay or whatever. Assuming that they are extremely accurate, I think they actually correct them for the sun. When there's a discrepancy between the atomic clock and the sun, they refer to nature as the true reference, and they adjust their atomic clock back to match the sun. I mean, for practical purposes, it would make sense to do, right? Because if you were to let the discrepancy ride out long enough, you can't correct the sun to the atomic clock. Eventually, you're going to have the clock like showing it's morning when it's midnight. So, yeah, they adjust their atomic clocks to the sun. I don't think I'm wrong about that. UTC versus UT1, I think is where it is, and this gets into the equation of time. How we keep track of time. If the sun is variable and if the clocks are variable, then do we have any accurate accounting for time? When you start looking into relativity, reference frames are all observer-centric, relative. There's no absolute time either. There's no absolute frame of reference. There's no absolute frame of reference for you to conduct celestial navigation, which requires time. How do you do longitude without a clock? There's no absolute frame of reference, therefore, when looking at the stars without a clock and just recording their angles. Everybody sees a star in a consistent but unique position relative to them. Just like looking at the sun's reflection off the water at your feet.
Bro, this server, what?
Hey, look, it's a dude with a freaking like GTA 2.0.
Yeah, bro, I'm
Avatar.
CJ, bro, Carl Jensen.
Wow. Do these guys listen in and like to butt in right at the most opportune time? I don't know. Sure seems to be, though.
I'm Donald Trump, and I approve this message.
This guy basically joined the server last week. If you guys don't make judicious use of the notes section for users, I recommend doing it. Take 5 seconds, click on their profile, add a note, date the note. Date it. You'll never know when you see it again. And you'll be glad that you did when you do.
Oh, I haven't been dating it, but I've been just putting in a really basic profile, like visitor, speaker, noise bomber, whatever, this little. But I don't always do it, but I've been trying to do it more regularly.
Yeah. I started doing it a couple years ago, and it took a long time, but it's starting to pay off. Okay, we got somebody in the chat, Surreal791. UTC is based on 0 degrees longitude, Greenwich, not the North Pole. Yeah, I'd imagine so, that it's based off of Greenwich, not the North Pole. I don't know why you would think I would think it'd be off the North Pole. Longitude is more or less a function of time. And it's not based off Greenwich, so Surreal791, it's based off of the time that the sun is at its zenith over Greenwich.
How do they decide what's the eastern and western hemispheres?
I would assume
it's east and west of Greenwich.
Yeah. And then plus the way they have made the two lines in the sky to identify the 4 quarters of the sky, where the line the stars pretty much make a straight line, and then wherever that is associated with Greenwich, that would be the east and west. So if Scorpio is over Greenwich, then east and west of Scorpio, respectively.
I remember watching something about, I didn't fully understand it, but apparently our tropics are misnamed that they shouldn't be called that anymore, or something. That's from a time in the past when those circles coincided with those constellations, but they no longer do, or something. So Capricorn and Cancer's like incorrect.
Oh yeah,
but we still call them that.
Bill Nye explained that in one of his videos back when we were kids. I remember that.
I like the idea that it's based off of maps that might be 12,000 years old. Because it's going to be when the sun rises in the east on the equinox, in whatever constellation it was at that particular. Was it based off the equinox? It'd be based off the solstice. Excuse me, duh. Like the sun rising in the solstice, 90 degrees, not 90, well, just off 90s would be like whatever degrees that would be. 90 minus 23.4. So you're looking
if I
east.
remember it being described, it would be
The sun is in that
summer in Alema,
Cancer.
and the constellation that sits in that spot. That's the identifier. And so it's shifted over, I think it's a 2,000 year span.
Is it 2000? Okay, so maybe thousands of years ago, the sun used to rise on the solstice and be where the Tropic of Cancer would be at that particular point. And it's no longer the case.
I'll see if I can find the video.
And the same with the Capricorn. There's so much like I got this great book, and you guys have probably heard of it too. The Maps of the Ancient Sea Kings by Charles Hapgood. If that name rings a bell, it's because he did all this research into old maps and found that Christopher Columbus took maps, which he got from the Sultan of the Ottoman Empire, who had just recently conquered the Byzantine Empire. So the Sultan got his map from the Byzantine, the Eastern Orthodox Christians. So Christopher Columbus was working off of Roman maps, Eastern Orthodox Christian maps that had mapped out Antarctica, parts of the coastline of Antarctica, as well as parts of Brazil. And it was validated by the U.S. Air Force, mapping agency. Some colonel, he wrote to Air Force or something, and Air Force wrote back. And they got all these letters in the back of the book, their correspondence, saying, yeah, it looks like it could be true. It has to be true. Some of these maps from deep ancient history are pretty mysterious. Maybe somebody went there at one point and surveyed it. So these traditions, they would use celestial navigation. So the Tropic of Cancer and Capricorn probably just kind of stuck from whatever age that was. Probably goes back to the Phoenicians, whoever they were. Somewhere in New Hampshire, there's a serpent mound. There's they call it the Stonehenge of North America in the state of New Hampshire. They believe that it was a Phoenician settlement from 3,000 years ago. Yeah, crazy stuff, guys. I almost think that North and South America might have been one of the biggest secrets that all the kings and the upper class, the aristocracy of ancient empires knew about, but never really talked about. Maybe this was a place you could go to get away from your empire. Kind of like a Bohemian Grove.
You also have Jekyll Island being a Canaanite island.
Oh, I didn't hear about that. Yeah, the Canaanites are related to the Phoenicians. Right.
Yeah, and over the, I think it's the dining hall, or underneath the dining hall in the basement was an altar. So, where the signing of the Federal Reserves happened was over
a
Canaanite altar.
Now, all these Epstein files have come out, which I would love to talk about as much as it's off topic, though. The ancient demons of old never left. They're here. The mask just dropped.
The 13 bloodlines? They're like the Illuminati bloodlines?
We're talking deeper history than that. Anyway.
What's your opinion on the Admiral Byrd and the Antarctica thing? Do you think he actually like found something, or was that just a false story to send people down rabbit holes or something?
I don't trust him because he falsified his expeditions to the North Pole that took place 20 years prior to all this. He lied based off of what I've researched. He lied about his sextant readings and his positioning. And the royal societies that backed him also backed his lies. And this has been completely destroyed, for his claims destroyed forensically. I've got a write-up about this in some sources in our home server. Presentation too. So yeah, I don't trust Admiral Byrd. I don't believe a single thing he says. I don't think anyone should. No, in his fake expedition to the North Pole could have been used as a leverage against him to be a propaganda tool for post-World War II accomplishments, advancing the notion that America's hegemonic power should not be challenged. Those Antarctic expeditions directly preceded the space program. We're part of the same psychological operations program headed by the president to cement American hegemony and power, this projection of prestige around the world. So, yeah. You know, it's not like I'm hand-wave dismissing these claims. It's no, I've got good reason to dismiss these claims. Not with the hand wave, it's more with a chainsaw and a mallet. See, I've got a minute here if I can pull up something about all this that I posted elsewhere. Let's see. pull it up. Never mind. There's a chance I was conflating Byrd with Admiral Perry.
Yeah, I mean, Byrd was the one that supposedly went to Antarctica during Operation High Jump, and there was like rumors. I don't know if he had stuff in his diary said that there's like another world in like basically like a concave Earth, basically that like another civilization.
Do you know the history of that
under there.
diary, dude? That diary's a fabrication, like by his brother.
I believe that. Yeah, I can believe that for sure.
Yeah. So like, I just no.
Well, that's like when everything like Antarctica got like super like secret, right? I mean, that's when shortly after all the nations signed the agreement, right? Whatever the treaty is, shortly after that. So like basically that Antarctica is just like a no-go neutral zone for science and
Yep. Oh, okay. So yeah, I was right. It wasn't Perry. It was Byrd. Yeah, his North Pole. Most people don't know that he's credited with flying to the North Pole.
Yeah, no, I didn't know that.
Yeah, let me pull this up. Yeah, and jeez, freaking lunatic. All right, do I have it? No, I don't have anything available right now that I posted. Yeah, so as I was saying before, so he claims to have like flown his airplane over the North Pole, and then he's got this diary, but some really smart chronologers, astronomers, Dennis Rollins from DIOI, for example, dug into his numbers and discovered forensically that Admiral Byrd and his helpers backed into the sextant readings that Admiral Byrd used to claim that he flew over the North Pole. He didn't actually take them, because if he did, he would have gotten different numbers, different angles, and different times. He messed up. And so if this happened in like the 1920s, like 1929 or something, right? And since he had the backing of the entire like Western world, at least North America, behind him, these prestigious royal societies, these American institutes, these organizations knowing full well of the fraud that existed, why would Admiral Byrd be selected then to go to Antarctica and make similar claims? If not there being leverage that could be used against him. We own you, Admiral Byrd. We helped you falsify your Northern Pole expeditions. We convinced the public that you really went there when you didn't. You're going to pretend to go to the South for us. We'll make you one of the most famous men in history, and all your relatives and, your friends, everybody's going to worship you as a hero. So we not only control you, we're not only going to beat you with a stick, but we'll feed you a carrot.
What do you think the motive was? Like why they would want him to do that? Just to be a propaganda machine? Just
It's a perfect guy to do it. He was already a hero. I'm going to post some links to substantiate what I'm talking about here. Then I have to get going. Yeah, I'm doing that. I'm going to drop some links and I'm going to run. So actually, I have to help cook some dinner. So hang tight. Save these. Go look at them later. It's a damn chat. Here we go. Here they are. Right. Gotta get going. Wish I could stay.
They knew it was a sphere. They knew what the Quran was actually referring to before it was discovered, like by science. They already believed. So we don't look at science and we apply that to strengthen our belief. No, this is before science. They already knew. So we're not using science to whatever. We already knew that. Okay.
Well, discovering the globe is not a scientific endeavor. It is a matter of measurement.
No. Here's the thing, because measurements can actually be wrong, so that's why that's why there's science to like observe it, so that we can eliminate like errors and mistakes. That's why there's observation, so that there's no like brainer.
Well, no, I would say observations can be wrong. That's why we measure.
So that means that your eyes can lie to you?
Right, so that's why we measure things, to make sure that we're not being deceived by our bias, by our senses.
No, I'm talking about your eyes themselves, your vision. Does your vision lie to you?
Your vision doesn't lie to you. You lie to your vision.
Okay, cool. So if you see something and it's truly there, then yeah, you do know the truth. There's no brainer. Your eyes don't lie to you.
Right. All right, so nobody sees the globe, like you established earlier.
Huh? No. Allah doesn't need to see the globe. Or Muhammad doesn't need to see the globe to believe it, because Allah tells him. And everything Allah says is true.
And you're saying the only place in the Quran that we can find out that Earth is a globe is by using this particular word to mean wrapping the Earth, the same word that can be used to wrap a flat thing, like a tray of food.
Again, I told you, the exclusive use for this word is a reference to things that are a sphere. Also, we're not only dependent on this verse. We have many other verses, and we also have hadiths, which are directly from Prophet Muhammad.
No, this word has multiple uses.
No, during the context.
Yeah, and wrapping a turban around a head, I mean, you can wrap anything in a dome shape around a flat surface too.
My friend, is turban a sphere? Are you seriously?
No, it's not a sphere.
Turban is not a sphere.
Yeah, a wrapped turban is not a sphere.
Is a sphere round?
Yeah, is a half a ball round?
Yes, it's round.
Yeah, a dome has a flat surface.
Okay, but it's round. Like, you don't look at the specific spot and you say, okay, because it's round on the side.
Round on top.
It's not going to be, because everything that curves, it has at least microscopically a flat surface. But we don't look at this little thing. We look at the whole picture. And we see that it's round. It's a sphere. So a turban is a sphere. It's round.
No, it's not. You can remove the turban off your head very carefully and place it on a flat surface, and it's not going to roll.
Oh my God, my friend, we are we are talking about the turban itself when it's wrapped, not when it's unwrapped and placed flat.
No, not unwrapped. You can very carefully lift it wrapped off your head so as not to disturb the folds and place it down on a table, and it's not going to roll because it's not a sphere.
My friend, things that okay, Listen, again, I told you, it doesn't have to be a perfect sphere to fit in the definition. All we have to understand is that it's circular. Is it a circle that wraps around your head?
I mean, is a round table flat and a circle?
Oh my god. My friend, is it a circle that wraps around your head?
Yeah, circles are flat.
Okay, thank you. So it's a circle that wraps around your head. Thank you very much.
Yeah, a flat circle.
Cool. Thank you very much. Flat circle.
Yeah, circles are flat.
By your logic, wait. By your logic, because by your logic, you are not flat, but I can smash you and I can make you flat like a paper. So by your logic, then that means that you're also technically flat.
Well, what is a sphere but a flat, or what is a circle but a flat sphere, right?
Huh? No, I'm telling you, like a circle.
Yeah, circles have no third dimension. They're flat.
No,
but
my
Earth,
God, no.
Earth measures flat, but it has mountains and valleys.
We are talking about we're talking about shape. We're not talking about any dimension. Don't jump now. We're jumping now. We're talking about shape, not dimension. Even like, how is this relevant?
Well, if I go to a planetarium to go see stars inside of a domed room, the sky is wrapped around the flat surface that I'm standing on.
Yeah, I don't get what you're saying. But anyways, what do you have to use? I'm curious. Like, why do you have to use the Quran to strengthen your case? Do you actually believe the Quran? That's very good. That's very good, brother. You become Muslim.
The worldview of people from that day in that part of the world was that the earth is flat. That is indisputable. There were fringe Greeks and Gnostics who thought the earth was a globe, who received their knowledge from Jewish mysticism.
Yeah. And there's idiots who believe other things. Does that make it? Okay? Let's say someone believes that the Earth is a donut. Let's say 2,000 years ago, someone believed the Earth is a donut, and this became a very famous belief. Everyone began to believe it. Everyone began to believe it, right? But then someone comes later, and he uses that as a metaphor, even though he doesn't actually mean to be literally a donut. Would you say that because of that, they are wrong?
I would say that's a false analogy. For the reason you mentioned earlier, we can only see and experience a flat and motionless Earth. So describing the Earth as flat and motionless is just describing observable reality. We cannot see the globe. If I were to say Earth is a donut after everybody sees and experiences a flat Earth, and I say that Earth is a donut, I'm going to need to provide some tangible proof, some evidence, perhaps some measurements.
Okay, and I told you, I think you didn't listen to what I said, because I said, what if someone uses it as a metaphor, not literally?
Well, no, flat Earth is not a belief. Unlike a donut, flat Earth is a description of reality. You and I both see and experience a flat and motionless Earth.
Hello, guys.
Okay, cool. So if there is a field, and half of the field is like it has like grass, the other side doesn't have grass. Are you going to look at this little bit that has grass and not the other side, and you're going to say, okay, because this is that means it's all going to be grass?
Can I ask you guys a question? Can I ask you guys a question?
Ask me.
Okay, so I'm assuming all of the people here are actually flat earthers.
Fuck no.
Yeah, you're in the flat Earth realm. I mean, what do you mean by a field that has grass on one side and no grass on the other? Do you mean like a pancake that has syrup on top and no syrup on the bottom?
Stop giving me these NPC analogies or whatever. Listen to me. I'm telling you, you need to look at the bigger picture, right? So if there's a circle, and a little bit of that circle. Okay, for example, look at a circle, right? Do you agree that circles are also flat somewhat at microscopically?
I mean, a circle is two-dimensional, so yeah, it doesn't have height.
Okay, let's say something that's a sphere, and it's like a circle, and it's in the 3D shape. Would you say that, okay, for like a turbine, would you say that turbine has like a flat surface?
I would say that the turbine has a circular base that goes around your head.
Okay, and that circular base is also like microscopically flat, right?
No, I mean, the turbine is basically a bowl.
Okay, and if we look at, let's just say, at the edge of the ball, and we zoom in, we can see it's like a straight line. If we zoom in a lot, right? It's made of straight lines, but are slowly bending, which makes it curve, right?
Well, it's curving in 2 dimensions, not 3. The surface, because you can take a bowl and lay it face down on a table, much like you could take a turbine that is unwrapped and place it on the table. Where the table contacts the turbine is the same as where a table contacts a bowl, and that contact area draws a circle, which is flat.
Okay, cool. So when I gave the example of a turbine, you seem to take it way too seriously, like way too like scientifically. That's we're not doing that. Okay, what I'm saying here is that as long as it looks like a sphere and it's circular, and we're not using any dimension bullshit, and we're just looking at shape, then my analogy,
well, then it's a hemisphere.
It's completely successful.
Well, it's a hemisphere with a flat surface.
Oh my gosh! I don't think there's a point. Like I don't know what you're doing.
Well, we measure the Earth flat. We have laser tests. We have long distance observations and infrared. We have radar and radio microwave tests. We can see too far for Earth to be a globe, and we can prove it.
Okay, cool. But here's the thing. If you want to completely seal your belief and claim that it's a fact, then you should actually show me a little picture of Earth from far away being completely flat. Show me that. I want to observe it.
Would you like to see high altitude infrared footage from an airplane?
I don't give a crap. I want to see the whole thing. The whole Earth being flat. Show me an image from space.
An image from space? What makes you think outer space exists the way you believe? Earth is not a flat planet. So flat Earth is actually the floor for outer space above it.
So there's no space. You're telling me that we exist inside nothing? We exist inside ourselves or whatever?
We exist within God's created realm. And we know that when we dig down deep, that it gets denser and denser and denser and hotter. And when we go up, it gets less dense and colder and colder.
Okay. So,
right? And all the stars and all the planets, the moon and sun, are above the Earth at all times.
Okay. So, let's say I live, okay, I don't know how to say it. Okay, let's just go back to what we were talking about. Why are you using the Quran for your case?
I'm not. You asked me if I knew anything about flat Earth, and you brought up the Quran, and I mentioned the Quran describes flat Earth as a carpet.
Yeah, and then I refuted that. You give me another argument.
I wouldn't say so. You made my point very clear that the Quran describes Earth as flat, and it comports with what we see, and that when you wrap something, you can also wrap other things than spheres.
Yeah, well, yes, you can wrap anything you want, even if it's something flat. But I'm telling you, you're ignoring the actual definition of what the word actually refers to in Arabic, which is to only wrap something that's a sphere.
In what other context can that word be used? Can you provide another sentence where you're wrapping a sphere in reality using that word?
Yes. We could say like a ball. Like a ball. You could wrap a ball.
And you'd only use that word?
For what? For only a ball? No.
And you'd never use that word to wrap something to put in the fridge?
You could do that, yes.
Right, so...
Is it curved?
I mean, I don't know if the sky is curved. I don't really think it is.
Okay, so when I'm using this word, right? This word is not literally referring to anything that has to be perfectly sphere. As long as you get the idea, then you're good. You will understand that it's a sphere. Also, I can
to the ancients, the sky looked like a dome.
I don't care what they say. This is about the Quran. I don't care who says. Okay.
Well, it's obviously, and so thinking of the celestial sphere. I mean, this idea came from the Greeks and the Babylonians. And you could say that the celestial sphere wraps a flat Earth.
My friend, the Babylonians, they also come up with the idea that God exists. The Quran does as well. Does that mean the Quran is wrong?
Not suggesting that. I'm talking about the flow of ideas from culture to culture through history.
Okay, cool. So what does it sound like to you? Night wraps into day. Day wraps into night. A continuous, seamless blending. That's exactly what happens on a sphere rotating. The light source.
Well, that's just one interpretation. You don't have to imagine a sphere.
Well, this is the classical interpretation. It's universal. There's no way. There's no other way. Maybe there is another way.
You can also wrap a box.
Well, I don't care. I don't care about the box. We're talking about something that's a sphere.
How do you know it's a sphere from that definition when you can use the same word to wrap a box?
Oh my God, my friend. Because of the word, we can only wrap things that are a sphere, that have sphere shape.
You can wrap a box.
Oh my God. Okay, whatever. You know what? Here. I will give you a website. I will give you a source. You should read it about this verse, and it will explain to you. What you want?
Oh, you can post it, but I need to understand how this reconciles with our measurements of flat Earth, because I can present to you laser tests and long distance observations. They don't show a globe as possible.
Oh, are you really trying to prove that the Earth is flat? Are you really?
I'm not trying to prove anything. I'm just telling you that we have evidence that Earth is flat and not a globe.
Okay, present it to me then.
I trust globe measurements, not...
What evidence? What evidence?
The evidence are all
let me go find some. I'll post it in chat.
Okay.
I need a few minutes.
Okay.
Hey, sure. They only have like measurements. They don't have any like pictures or anything.
Well, pictures aren't good evidence. You need data to go with the pictures and video.
Okay. Do you agree to this? Measurements can be mistaken. Just as simply yes or no.
Obviously, yeah.
Okay, cool. And your eyes cannot lie to you. You can lie to your eyes, but your eyes won't lie to you. So
no, it will.
Reality is objective.
That means that the only option that's infallible is observing it, which is an image, a picture, not some measurements that have a chance of being wrong.
No, I mean, pictures can be falsified, right? People have been faking pictures for 150 years.
I'm talking about a real picture. I don't care about any falsified.
A real picture. Well, that's what I'm talking about. Telling the difference between a real picture, like what I'm about to show you, versus pictures that you can't determine are real, like those from NASA.
My friend, I'm talking about a literal picture, like a picture. You know what I mean? Like an image. Show me that. Can flat earthers not afford paying for a rocket to launch themselves or whatever? And get a picture from there? Because I think one picture can completely change you guys. Like it will. Just one picture, it's gonna change everything. As long as it's not, as long as it's true, like it's honest. But then you guys use the excuse that space doesn't exist and you can't go there, so that you can't get a picture. Because you know you cooked after that.
All right, this is a long-distance laser test that was conducted. It's conducted in 2 places on Earth. The first place was Lake Balaton in Hungary. The second place was Lake Isel in the Netherlands. I'm going to post an infographic that describes what the video. Okay, so what you're going to see in this video is you're going to see, now I want you to focus on the measurements that were taken at Lake Isel in the Netherlands. They set up a laser. The laser was mounted to a GPS-enabled aiming device that was custom built using CNC machines that has millirad accuracy. They shine this laser a distance of 24.94 miles. That's just over 40 kilometers from one side of the lake to the other. The laser was visible from 1.5 meters above the water's surface on the other side. Now, if Earth is a globe, do you have any idea how much the globe should be blocking that laser's path? And the answer is 90.8 meters. In other words, for that laser to shine and hit the target on the other side of the lake, if Earth is a globe, there would be a hump of water 90.8 meters high in between the laser and the target. But that hump of water for the globe was not there. The laser was shined with pinpoint accuracy from one point to another, and the globe did not get in the way. Here's another infographic if you're interested. Oops. Same one. Let me back up. Now, this test was conducted by physicists, by engineers. The group is called Field Engineers Corps. They've gone all over the place with this custom-built laser costing around $30,000, conducting these long-distance laser tests. And I believe that these are the longest-range laser tests in history for the purpose of measuring the Earth. It's interesting to me that nobody who believes in the globe can present such rigorous evidence as this. This is something that anybody can conceivably do. The barrier to entry is not very high. you can go make long distance laser measurements at the same exact place. Now, what's the barrier to entry for NASA photos, for pictures from space? The barrier to entry is insurmountably high. You need to become an astronaut, which means you have to have a master's degree in a STEM field. You might need some flight time, so you might need to learn how to pilot airplanes. You need to go through the physical exams and the psychological exams for NASA. And then once you become an astronaut, you need to be able to freely, independently verify the images that were shown to you before you became an astronaut somehow. So you might need to go up in the space station. You might need to go up in a space shuttle or do something like this. Now, what we're presenting as evidence, the barriers to entry is not as high. We're not going to a place that is an environment that is considered to be unique and special. We're just going to somewhere on Earth with a lake. Now, what's unique and special about space is how they claim space is a violation of thermodynamics, of natural laws that we can demonstrate on Earth. And what I mean by that is space is considered to be an ever-expanding vacuum. And yet we have an atmosphere, we have a pressurized environment that exists adjacent to this vacuum without that gas, without that pressurization expanding to fill the void. This is the only instance they claim that this is possible in an environment that nobody can really go to test to see if it exists in the way they say it does, except for a handful of astronauts. So what I'm trying to understand is if Earth is a globe, if the Quran states that Earth is a globe, and you believe in the Quran, how does that reconcile with these flat Earth measurements? And of course he left. Well, that's what you get when somebody's best evidence for the globe is the Quran. All right, I got to head into my office, so I'm going to go on mute. Hope you guys have a good day.
Yo. I was invited.
Oh,
I was invited. How old is that DM? That was today.
Yeah.
November 12th. 9:37.
Right.
Yes. Here I am. Be here or be square. Okay, I'm posting in the main, and I'm gonna post in the main server in the announcements to get their ass in here.
Or else.
So you have event perms? You can run events now?
Yeah.
Word.
I'm not too sure about broadcasting it in the politics server as an event while an event is running. I got to figure that one out.
Yeah, doesn't it like auto delete even politics server Discord links?
Yeah.
That's the stupidest thing. They can't make the bot make an exception for their own server. Don't advertise our server in our server.
Yeah, exactly.
Were you in here when I talked to Stone last night when we were talking to Stone?
I don't know. Was it in politics?
It was in here, yeah. I think it was in here. I don't know where the frick I was, dude. I don't even know anymore.
I know we had an event in here a couple of days ago.
No, it was English Hub. So we were talking about the Shiva thing some more, and because he was talking to Kevin Samuels while he was interacting with Shiva, because the airplane test was actually his test, and he would not. Stone was like, Shiva would not bring him in, dude. Even though he was going to comply with all the diktats and all that stuff, he would not let Man of Stone in. Dude's trying to stack the deck, man. Trying to bring in a bunch of dummies. Not that Kevin Samuel's a dummy. I'm just saying is that he was just trying to stack the deck. But anyway.
The person who actually came up with that test was willing to be on there, and he said no to him and said no and said yes to a person who was just going to like regurgitate it. That's so weird.
I just said no, dodged him.
Wow.
Him, just like they dodged Yoder, right? They dodged Yoder. Yoder was actually can apply with their I call them diktats, right? we have this is our criteria. You must comply. He was even going to comply conditionally. That the biological information was going to be secure. That's my understanding. Because why biographical rather, not biological.
I didn't know. Yeah, I didn't know Yoder was going to do it. Okay, that's interesting. Yeah.
I think he was going to do it. I think he said he was going to.
Yeah.
They wouldn't even talk about it though. That was the thing in my messaging. I'm like, what the hell does the biographical information have to do with the scientific method? How is this relevant to the experiment? And they never said anything. They said, thanks for replying. Bye. That was it.
Yeah, that's weird because then they had people that had pseudonyms that were there.
Oh, yeah, because they got death threats from flat earthers, right?
Has he produced any evidence of that?
Of course not.
Dude, if I was a scientist, I'd give myself a death threat so I could get out of doing it.
Look, McToon is an annoyance. Why would anyone want him offed? I mean, if Whitsitt did, I'd understand it because of the stuff he said about Whitsitt. Stalking him, talking about his family, talking about his children, all that stuff. I mean, not offing him, maybe catching a beating, but freaking death threats. Bullcrap. Just like he lied. I mean, just like he lied about being banned from our server. Those are just a blatant lie. And that he's been saying it on X, and he says it in other places that he's banned from 24/7. No, he's not. He's not banned. He's never been banned. Why would I ban him? Why would I ban the frickin' Globetard Dunning-Kruger frickin' hero? Why would I ban him? Then how are we going to stomp on him if he's banned? But McToon is all about narrative. I swear, like he's just all he does is spin. 90% of what he says comes out of his mouth is narrative spin. But I don't want to talk about them because they're not important.
Oh, I was allowed to post it. The link. Maybe we'll get some customers.
Also, death threats from Democ don't count.
Yes. That's just Tuesday, man. Like, what are you talking about?
It's like I received a death threat. What? From
dude, freaking Democ death threats himself. Death threats from Democ, dude. Well, first of all, maybe you should take his death threat seriously because he does get a little unhinged sometimes. But he just throws that out there. That's just like normal Tuesday. As inventive as Globers are about like inventing their own flat Earth in their head, Democ is 10 times more inventive about inventing like the consequences of a globe. They're so funny. He comes up with some stuff, man. Just like if you had a globe, then you just go see this whole thing of nonsense that would happen. It's funny. He's very inventive when it comes to that. Dude, he don't remember saying it, but I heard him say it one time. He said, you can't have water on a globe. He said, you have to have a container. You ever try to eat soup off of a globe? He said, he don't remember saying that, but he said that a long time ago. It was so funny. I was dying. But he's got a point, right? You got to have a liquid. You need it in a container. You can't have, you can't. And he's like, I want some soup, right? I need a
Not me,
container,
dude. I like.
bowl.
No, I like have a nice ball of cornflakes in the morning. It's just great.
A ball of cornflake? Dude, I'm making sports bottles with frickin' that are a globe.
Man, I'm trying to remember some. He really would come up with some great ones. I mean, side view, of course. And can you do that in a lab?
Yep.
Yeah, that Shiva Summit thing was absolutely painful. Just, a completely spun story, almost arguably worse than TFE or whatever the hell that was, but arguably the exact same tactic.
Yeah, definitely the same tactic, right? I'm gonna do something, and the real mission is to disparage flat earthers and show the whole world that they're dishonest idiots that don't really want to know the truth. That's his real goal. That's what he thinks he's gonna do. That's what Duffy thought he was gonna do, is that he was gonna do this Antarctica thing, and no flat earthers would sign up, and no one would go there, and they would do whatever, right? That's what he thought would happen.
Okay, so what do they think that the flat earthers are running from? Like the constant monthly threats of a meteor crash coming from some weird Oort cloud billions of galaxies away. The continuous false promise of civilian flights to space, the constant BS about colonization. It's just there's only a handful of things that belief system really offers, and none of those have ever been fucking provided. Ever.
I'm still waiting for the space hotel, man. Think that it was supposed to be this year.
Me too, dude.
2025 with the space hotel?
Bro, I wanted to Jake Paul the space elevator, just get to the bottom and just press all the buttons right before everybody goes up. You know what I mean? Take that.
Well, you'll get younger as you go higher out of the gravitational well, right? So you'll age less. So you'll make it to the top before you're 100.
It's just an absolute spanked religion. That's all it is. Peer pressure from dead people. Somebody said it's a ball one day, and then somebody's like, yeah, it's a ball. And then they just kept running with it for some reason. Because 2 sticks and a dude in the desert? Give me a fucking break. I can get the same results on my basement floor with fucking paper towel tubes.
Bro.
So, what the fuck?
Bro, you just coined a phrase, brother. 2 sticks, 1 dude. Man, why is all the globe stuff got to be so sexual innuendo? It's hilarious.
Lesbians should be a natural ally because they're against balls, and they should just be on our side, just naturally.
Well, my question to them is if they're like, well, we're going to colonize space one day. And I'm like, what, are you going to go there and be depressed too, you globy? He's going to go there and be depressed, you fucking idiot.
No, they dream of cat alien wives.
I don't know if there's enough Xanax to last the trip there, you globies. Like, I don't get it. I don't know what they're hanging on to and what makes them hang on to it so tightly. It's like, bro, you're not going to space, man. Like, is that it? Is that what they're hanging on to? Or is it just like anything, like the input? Like, I don't get it, dude. I just really don't get it.
Dude, I've had them say that they don't want to lose space. I said, yeah, but you're never going to space in your lifetime. But they're like, yeah, but it's just the idea of it, and like maybe people in the future will. I'm like, dude, who cares about what people in the future are doing? Like they have to imagine in the future their great grandkids are going to be starfighter pilots or something, you know, challenging the Kodan Armada.
Yeah, and first contact was made.
I used to get so tripped up about those pyramids they saw on Mars or whatever, or like the face, you know, and I'd be like, man, people used to live there. I bet somehow we got over here.
Bro, they're spending millions of dollars to just find like one little thing of bacteria, and it's like, bro, do you know how much life is down here? Like, it's all right here, bro. Like, you know, like if you just want some like culture, like I can make you some yogurt. So, like, if you want some bacteria, like, holy shit, it's super strange, bro. There's nothing out there. Like, even in their system, in their model, in their little creepy story, there's fucking nothing out there, dude. There's literally nothing. It's wild, and they're still like, it's worth it. I want to believe.
There's so much nothing that there must be something.
Yeah, they're turning stuff into things. Like, yeah, true. That logic, dude, more cheese is less cheese. The more Swiss cheese you have, the more holes the Swiss cheese has. The more holes, the less cheese. So more cheese, less cheese.
I actually had a student the other day, what's today, Wednesday? He asked it on Monday. While I was drawing on the board, I was drawing some section, drawing with some trees and, you know, basically just doing a tutorial of orthographic view, because you still have students drawing a elevation view and trying to shrink trees in the back. Anyway, he randomly asked me, he goes, sir, is the earth flat? I go, that's an interesting question. What do you mean? And he answers, well, you know, the ice wall. I was like, ice wall? What ice wall? He's like, you know, Antarctica. And I was like, Antarctica's an ice wall? He's like, well, yeah. And I was like, you've been there? He's like, no. But in front of the whole class, you know, everybody starts quieting down and eavesdropping on the whole thing. But they also, I don't know, I hope they noticed that I didn't really say anything at all, but simply just ask questions. They're getting more bold about asking or speaking up. Or, I mean, don't get me wrong, I'm talking about star forts and old architecture sometimes, or, you know, even buried architecture situations that I find even in our hometown. But I don't know. It was an interesting take, because I've never had a student just blatantly ask in the middle of class. I'd say it's there's an uptick.
That's good. Yeah, that they asked it, and yeah, you just taking it seriously and then questioning further. It's a good response.
Oh, that's what it was. Yeah. He goes, well, wasn't there somebody who went to Antarctica? And I was like, who? Admiral Byrd or Captain Cook, or who are you talking about? You know, he starts smiling because he goes, oh, you do know about it. I'm like, know about what?
Yeah, do you guys want me to invite the people from English Hub over here?
Are they globies?
Yeah, there's I think a few of them in there actually.
Yeah, I was just
there. Well, I just got into it with B-Man and a friend that he had about rockets in space. So they're amped up right now over in English Hub.
It's time to crash a party.
I can go tell him to come over. I don't think anybody's. I don't even know if there's anybody. I was listening over on YouTube. I was on the phone.
Yeah, if it's fizzled out, definitely bring them over.
Yeah, I got you.
Yeah,
I got you.
Did you hear me with B-Man last?
Oh yeah, I did. That's pretty good.
Yeah, I'm gonna come over.
Who is B-Man? Is that Robert Utah?
No, he said he used to listen in on our old server, but he's like in his 20s, so I think he's mistaken. But he's a young kid glober. He likes to throw out claims with no evidence.
Dude, I like to throw out claims with no evidence too. Thrown out.
Yeah, I've talked to B-Man in the past. It's been a while.
I mean, he's a nice kid and all. I mean, he's not, I guess he doesn't like Indio, but...
What? Who doesn't like Indio?
He said the guy that has the Asian guy with the white goatee, he's got a avatar. He's really mean.
You're such a dick.
Yeah, I don't think he's coming over. He's talking with his friend right now, talking about Polaris.
Hate that guy. Imagine having to see him every day in the mirror.
Bro, India, I was talking about you, by the way. He said you were being a big meanie to him.
Well,
wow, yeah, you made a big impression on him.
Gotta do it again.
Well, hopefully he comes over.
I probably wasn't listening, and I was getting irritated that he was just like waiting to talk, which is typically what the kids do.
Yeah. Oh my goodness, that Life Forever guy. Holy. Hold on.
That's what he was doing just a little bit ago. Like, I asked him, I was like, what did I just tell you? Repeat what I just said. And he didn't know.
Let me... What is it?
How did I guess? The people that say I'm mean are the people that I don't tolerate, like, ignoring me. I do get mean to them. Because they're being rude. If you're in a conversation with somebody in real life and they're ignoring you, that's rude, dude. Like,
he mentioned you, then he mentioned Matrix. He said he talked with a lot of us. I don't even remember him. He said he talked with me, though, but I don't remember.
Well, Matrix is pretty rough sometimes.
I feel like he's normally like that, only if they're being dishonest. I mean, granted, a lot of us are like that when people are being dishonest.
Plus, he gets a little bit of a handicap being Australian and all.
We all can't be like Flatloid.
Dude, is that a mental handicap or a technology handicap?
That's a loaded question. He means well. But yeah, I mean, he's passionate. I was trying to think of the meanest flat earther, and I think, what's his name? Justin? He was a mod back in 24/7. He would just like rip somebody a new one for no reason. Like, dude, relax. Oh, Vlad can get pretty mad too. But almost for no reason.
guess you went around for Ace McSuper Loud. He would literally
No.
the BC. including the flat earthers.
No,
Are
it
you a
wasn't right,
teacher?
that one.
Are you a teacher, Flatlight?
Yeah, I teach architecture.
Oh, you do. Cool. What part of the United States, if you don't mind me asking?
The Third Coast, Central Texas.
Oh, nice.
You mean the southern provinces of Canada, actually.
Oh, finally found it. Okay. You guys are gonna love this. No screenshot. Damn, I didn't think it was from 7 o'clock this morning. I had to scroll back so far. I'm gonna post it up in the side chat right now for you guys.
That was observational science.
So I'm just trying to get from him. Oh no, he left. He was over at English Hub right now. Oh wait, is he still there? Oh no, yeah, he's gone. Never mind. I was arguing with him the whole time. He just kept calling us dumb the whole time. Said that we're ignoring observational science. I was like, what is that? He wouldn't answer me the whole time. Oh no, let me see.
He didn't leave. He's in Ask a Christian. He's in the Ask a Christian channel.
But
Go
that guy is
figure.
a dude.
He's just an atheist troll, man.
Was that the same guy from this morning who was saying that a circle equals a globe?
Oh, I don't know if he said that to me.
It was hilarious. I mean, he quoted it, Job, verbatim, super nicely. And he's like, yeah, a circle equals a globe.
I had a guy earlier also. He said that he was going to give me the scientific method for a triangle. Because he said that the triangle geometry is science. He never did that either, unfortunately.
Yeah, some of them are really hard to explain science to. And honestly, in my lecture courses, I don't know, I kind of double down on it in terms of making sure the class actually knows what the word objective or subjective means, but also, defining science and pseudoscience. Because we talk about it honestly a lot in architectural theory, at least in modern architecture. There's a lot of different sustainability theories, if you will. For instance, it's kind of like the stuff we talk about here in terms of sure, you can have battery cars, right, or battery houses, but at what cost to the power supply or the power plant that's truly burning coal or gasoline or natural gas anyway? But it definitely comes up, right? What is science versus pseudoscience? A lot of people start to realize when I start to go, yeah, that theoretical physics class, that's what it is. Sure, maybe they're basing it off of actual science in some cases, but it starts to get a little woohoo if you ask me. We have this in a lot of cases. You'll have, practical physics and theoretical physics, but the same thing happens in architecture. You'll have different schools that focus more on the pragmatics and the practicalities of design, such as Japanese architecture and an interlocking system that requires no extra hardware. Or, modernism in a way, postmodernism still really, and the rejection of the international style of the 1920s. It's kind of still going, I think. But people are waking up. I'm starting to ask questions for sure. And I think that's why I particularly like architecture, because it does give me the ability to really talk about anything. Sometimes even how level the earth is. especially when we draw it in perspective. Fun, and it's a really good outlet.
Did I ever tell you about the Trinity Church in Boston?
I think you'd have mentioned it once. I'll look that up.
My friend had the guy that invented the steel cantilever bridge. He went to a architecture and engineering school. Back then they were combined. It was like an art, architecture, and engineering. It was a combined school, like where you went to learn all those things. And he made a glass etching, right? So you etch in the glass of the Trinity Church, and my friend had it. My friend, and I don't know if he got drunk and broke it or sold it or what the hell he did with it. But I was like, dude, this is like, I'm like, this is a glass etching of the Trinity Church from like freaking 1912 or something. And then I looked the guy up, and it was like the guy invented the steel cantilever structure. I think a bridge. It was like the first time that they were ever used. He invented the technology, and he had an original work of the guy. Have you ever seen the Trinity Church? It's quite nice.
Yeah, I'm looking at it right now. Super old world looking. Yeah, it's kind of got a Romanesque look with the half circle arches instead of any pointies.
It's like in a giant courtyard, and like right across from it's the Copley Library, which is a whole nother thing altogether.
I think it's got that checkered pattern at the top too. It's extremely ornate, and it's got I forget what those are called. I should know. Almost like little like guppers, if you will, on the edges or the ridges of the top roof.
Yeah,
it's much more like a French architecture thing or French style. Honestly, the base looks kind of weak compared to the rest. You'd think there'd be more. There's only like a small stepping. And that's crazy. That's beautiful. You had a piece of glass from that?
A piece of glass that the guy that invented the bridge, he etched. He etched it into he etched the drawing into glass, and then what they would do is that's how they would print. They'd print the like posters. Right. They would rub ink on the glass. You know what I mean? Mm-hmm. The ink would go in the grooves of the glass. They used to be called ink prints or something like that. Glass ink prints. So he must have did it as like some project when he was going to school, because it had like so in the bottom right corner, it had his name and what he made it for and the date and what it was of. It was like a little freaking metal placard thing. It was about pretty big. It was like maybe like 18 inches by 3 feet.
Posted up some more highlights in the side chat if anybody wants to look at those.
We use mathematical sciences to calculate geometric features. Just throw science in there. That'll work.
When you find your belief
goes against the greatest minds.
Fucking dude, is this dude bricked?
I'm telling you, guys missed out today, man. Over in the English Hub, it was going crazy over there.
Yeah, there's some gold nuggets, man.
The definition of brainwashed.
The funny thing is, 100% this person's an atheist. 100% certain. And it really like grinds my gears when I hear atheists say something's right or wrong. Like, motherfucker, you don't believe in right and wrong. That doesn't exist, dude. bunch of chemical reactions in your brain isn't right and wrong. There's no right and wrong in your chemical reactions. When you find your belief is not a belief, and your position goes against the greatest human minds in history, you know something is terribly wrong. This comment will break all of you.
Bro, he was copying, pasting that statement like 40 times in the side chat. Like I was going crazy.
Oh my God. If you were never born, how would you feel?
This guy's high, man.
Yeah, that was funny. That was good. Good stuff.
You know, he was being serious, right?
Oh, yeah, for sure. 100%.
That was actually him releasing some trauma right there.
Exactly. It's like when Mimas would say, this is actually just a therapy session. And Globy's just constantly projecting left and right.
I heard a physicist say that mathematics was a natural science. I almost like, shit.
I discovered a wild 2 and 4 yesterday in the woods.
I stepped in number 2.
That counts. That's math.
Yeah, did you guys already go over that video with Dr. or PhD, whatever, Shiva, whatever that dude's name was?
Most wish I didn't.
In detail. And
damn, I missed it.
Hold on. I gotta say something. Everybody freaking sub to On the Levels Clip channel, man. There's good stuff on there.
Yeah, can you post it up in the side chat for me?
Yeah, I'll post this channel and I'll post the link to the breakdown of Shiva.
Yes, please. Yeah, I missed it.
For getting me the links. Everybody's doing their part. She did all the work. I'm just pretending I did something.
Because I remember somebody said they were going to be going over it, but I was like, oh man, I don't even know when that's going to be. I'm probably going to be working. Oh yeah, there you go. All right, cool.
So, Majin has created a channel and there are like a bunch of clips, but there's only 20 subs, and that's a catastrophe. There should be way more than 20 subs because he's got lots of videos up there. So they're clips from the live stream ranging in between 30 minutes and 5 hours.
Oh shit, 5 hours. I was about to say.
Oh, this? Yeah, this is because his video was 2 hours. It was 2.5 hours.
Oh, okay.
So it took that amount of time to go through it.
Yeah, I'm trying to listen to this.
Science Summit. But we also veered off a couple times where we weren't actually talking about it. So
I'm gonna go like 2 times speed or something to get through this. There's no way I can. 5 hours is.
I mean, you could probably just start listening at the freaking end, like in the middle. Quite honestly, I would just skim through it.
Okay. It's like 2 Lord of the Ring movies right here.
He's also got playlists that he made for different people. So he's got one playlist, Amicable Conversations, Globe Zealot Naughty Corner. I don't know what that means.
That sounds like a fun one.
Hey, hi, Overlord, taking your job, whatever that means for playlist. Yoder, the Indio Files, and just episodes. I don't know what that means. So he's got a bunch of. He's organized it in playlists, which is pretty great.
Wait, who is this guy?
Majin, Majin.
Asian.
He doesn't ever
Asian.
talk. I think he might be foreigner, but I'm not sure.
Oh, that's the guy. He has an anime profile picture too, doesn't he? The guy with like the short black hair.
I don't know.
I'm like, I only ever remember people by their.
He's always he's around a lot. I'm just glad he's doing it. Someone finally. I mean, we've been talking about this for a long time, and no one wanted,
Seriously, because I do not have that kind of time.
Responsibility, of making a clip channel. I was actually talking about you, Flat Lloyd, like, because that's like a thing. Like, I was talking to somebody about this. How, like, I've always said, like, we'll help you do whatever you want to do, but we're not going to do it for you, because people come up with ideas and then they're like, hey, I have this great idea. Now you go do it. Like, no, we do it yourself. We'll help you do it. We'll do everything we can. And I use an example. Like, nobody told you to go start a secondary channel. You just did that shit. Right. And, and look where it is now.
For the most part. I mean, CB was like, dude, we need another channel. And I was like, well, I do have this computer right next to me. So that day, I just started making it into a OBS station.
Yeah, but you get almost as many viewers as Helio does.
It's getting up there,
I run both of them at the same
There's
time.
a lot of subs.
Like, well, I mean, because yours is presented a little bit different. Helio's is like you can see just your screen layout's a little bit different.
Right.
So people probably just prefer that layout. And then you guys are staggered, so even if like Helio misses something when he's down, it'll be on yours.
Exactly.
It's super useful.
Unless Eli has a really good point.
That's going to be more than freaking. That's at least 3 streams, dude. What are you talking about?
I did notice that. Because I checked myself and I was like, no way. Did that really happen? And I know it definitely happened to him twice, and I couldn't believe it. So I've been trying to stagger it a little bit better too.
Oh, it's happened with Helio shitloads of times.
Isn't the flat Earth?
And like, I don't know if you do this, Helio, but like,
is this like for real?
Thinking that Helio, he's like, oh my god, they're having a great conversation. I'm going to restart the stream, and then he freaking misses the freaking good parts.
Is this about flat Earth?
Yeah, man.
Like for real?
Yeah. We were all taught the globe. You were taught the globe too, right?
And what?
You were taught the globe also, right?
No, please. I don't want to be gaslighted, please.
So you weren't
that scared of this question?
Yes, I was.
Right. We were too. But have you ever actually tested that globe for what you see in reality?
I mean, I want to go to the moon in like 10 years.
I mean,
I want to pay like the ticket to go to the moon, and I'll see that.
Like we're talking about planets. You're like, I want to run away from the Earth and go to the moon.
Yeah, I'm going to Mars in like 7-8 years. So I'll tell you. Yeah.
Gosh, I've been looking for someone who actually thinks they're going to Mars. So you really think you're going to Mars?
Yes, if I have money.
How long do you think? When do you think you're doing this?
In 8 years.
8
Is it going to take
years?
8 years to get there too?
So you were saying it's never going to happen.
I didn't say anything. I've just been looking for a few months now for like a real person who actually believes that
I've been looking
story.
for you too. Yeah. I've been looking.
Do you actually believe that though? Are you just like joshing us, or do you actually believe you're going to Mars?
It's my belief, yeah. It's one of my beliefs.
Why do you believe that?
I guess I come to the wrong channel.
No, we're asking you why. We want to understand why you believe that's a possibility.
Yeah, technology is advancing.
Like, which technology now indicates that you're going to Mars?
Which technology?
Is it the moon base? Oh shit, we don't have a moon base. Is it the people that are hanging out on the moon? Oh shit, there's no people on the moon. Is it because people can survive?
I'll tell you. Wait.
For a long time.
Calm down.
Do you remember that?
Calm down. When I look at the sky,
I am calm. Shut up. I am the biosphere. Do you remember the biosphere project, or was it
when I look at the
biodome?
sky, I see like satellites and planes and
No, you don't.
everything
Okay, stop,
on the
dude.
sky.
No, you don't. You're not seeing something the
That's
size of a
why
refrigerator
I'm telling you
3,000
that.
miles away. Come on. Stop
What?
it. So,
what did you say?
do you remember the biodome thing? Or are you too young for that?
I don't know what you're talking about.
They made this biodome on Earth, and they were testing to see if people could survive on the long trip to Mars. And they put them in this biodome. What'd they last 2 weeks?
Okay.
Yeah, dude, you're not lasting. Like, you're not going to Mars, dude. You wouldn't last.
Okay. Okay, well, where do you want to
Because you're going to have to produce all your own oxygen. You can't bring it with you, so you have to produce your own oxygen, own food, own water. You gotta make all this stuff.
I mean, I don't know about that. That's something science should know. That's something that my astronaut suit should have. I would probably carry like some kind of tank with me, right? I'm not a scientist, so I can't explain you that. You should probably ask a scientist. What?
Ask the scientists?
Yes, or read a book or
you
something.
ask the scientists, and some scientists, which they do, say going to Mars is bullshit.
I mean,
do you know who doesn't say it's bullshit?
I'm not
It's
just
Elon
talking
Musk.
about.
Elon Musk is the only person that says it's not bullshit.
I'm not
Everybody
just
else
talking
says it's
about
bullshit.
Mars. I'm saying like the flat Earth thing you're talking. This channel.
Hold on, dude.
I mean, I think there's a lot of experiments you can do on Earth that prove the flat Earth is wrong.
Oh, like what? We just talked about that.
Like a light.
I just asked you if you did any.
I'm gonna tell you, but do you don't want to let me talk?
Yeah, but Flatloid Wright just asked you if you did any of them, and you said no.
Did what?
Any experiments to test
I mean,
the globe?
I don't need to do them because I don't believe that we're living on the flat Earth.
No,
but
you
if you
believe
it, there's a lot of experiments like putting like a light kilometers away, and putting like a target, and if the light is above the target, it means the Earth is the globe.
Yeah, but we've done these with lasers, 40 kilometers.
And what was the?
So the laser started at
The result was it's flat.
Yeah, the result was it's flat.
I mean, I've seen like a lot of that say otherwise. That say
no, you're lying. Post it.
I'm
Post
lying?
in the chat right. Post in the chat right now. One of them. You said you've seen a lot. So surely you can post one.
I mean,
post
I'm
one.
I'm not arguing
you've
with
seen
you.
a lot of them. V. Post one.
I've seen a lot of them.
Then post one of them.
I didn't save the link of any of them.
Oh yeah. Where did they do it?
I can send you if you want.
Yeah,
I can
then
search for
describe it. Then if you can't post us the link, describe it to us. Where did they do it?
Where?
Yeah, where?
Oh, in Earth.
Where on Earth did they do it?
Like a lot of places. United States.
Yeah, name which one. The one you're thinking. The one. Do this. Do this. Imagine in your mind the best one, the one that proves the globe the most. Where did they do that test? How long was it? What laser did they use?
I think the best one is from space.
Talk about the one on Earth that you said you saw.
On Earth, that I think I saw. I think they were in the U.S.
They're in the. You think? How long was the distance they shined the laser?
I mean, I didn't do the experiment. I don't know. I'm not a scientist.
But you saw a video, dude, and you think
you shouldn't ask me. You should ask like the scientists. I don't know about.
Yeah. So, why don't you ask the scientist to post the video in the chat?
I don't know about the details.
You don't need to be a scientist to make a measurement.
So let me get this right. This is your position. Laser tests have been proved the Earth is a globe. You don't know the details, but you're sure there's a whole bunch of them.
A whole bunch of what?
Let's go with that. Let's
Just
go with
saying
that.
a whole bunch of things to prove that the Earth isn't flat.
No, you said there's a bunch of tests, these light tests. That's what you said.
No, there's a bunch of proof.
Okay. Well, I'm going to give you proof that the Earth is not a globe right now, and I'm going to give you details.
Okay, please give me.
Okay. So
I'm not trying to argue with you.
Okay, let me finish. So, one of the tests that was done, they went to Lake IJsselmeer, which is in the Netherlands. It's a saltwater lake that they enclosed from the sea. Okay, so it's sea level water. They took a laser 10 meters above the water. They beamed it 40 kilometers, and at the other end, the laser was measured to be 1.5 meters above the surface of the water. Now, if the Earth was a globe, that laser should have been 127 meters off the surface of the water.
Okay, and where was this? Where was this
Lake
again?
IJsselmeer in the Netherlands. That's what I started with. Were you not paying attention? I literally started with the location.
I mean, I'm sorry. I'm a little tired.
Okay, I'm sorry. So Dandelion just posted a video of it in the chat. If you don't want to watch a video of them doing it, that's long, I can just post the report that was generated. So they did 5 of these tests. They did 3, and then 2 weeks later they did 2 and replicated the first 3. The longest 2 of the first 3.
But it was like a little above, right? The later was a little above.
A little above what?
You said it was like 1 point something meters?
It started at 2 meters and ended at 1.5 meters.
So it
hard to aim a
like
laser across 40 kilometers exactly. Do you know where the laser should have been if the Earth was a globe? You shouldn't have seen the laser unless you were on top of a 42-story building.
Okay.
Yeah, 42-story building. They're pretty tall, right? So that's the only place you should have been able to see the laser from is from up there. But they saw at 4 feet above the sea level. Not 400 feet, 4 feet. Not 127 meters, 1.5 meters.
Okay, and you think that's enough to prove that the Earth is flat?
Well, it's different than what the globe predicts by 2 orders of magnitude.
It's undeniable proof, bro.
It's 2 orders of magnitude, right? So it's way outside any measurement error, any uncertainty. It's way outside what the globe predicts. Not a little bit outside. It's not close. 2 orders of magnitude. You understand what that means, right?
Dude, he's got you. Just admit defeat.
Shut up, tourist. We don't need a fucking heckler.
Well, I don't even know.
So that's just one test, right? So during this test, they also brought meteorological stations where they measured the weather conditions, right? So what they did, they just tested the globe. What does the globe predict? We're going to do the test. What are the results? Now, they got the result they got. This has been replicated, though. This isn't like this is a one-off event. It's a bunch of laser tests that are across way too far distances than the globe allows because the curve of the Earth should be in the way, right? So these tests have been done over water, B. Now, any individual test doesn't prove the Earth is flat. It's the logic that proves the Earth is flat. The surface of the Earth is covered mostly in water. And if that water does not curve, right, then the Earth must be flat. If the oceans of the world don't curve...
Do you know, what's your name? Sorry, India, right?
Why are you interrupting? Am I talking to you?
This is an important addition to your discussion. That's why I'm interrupting. Yes. The FACO model. I've been listening to your FACO argument in the Netherlands lake, right? Do you know about Snell's law?
Yeah.
Or do you know if they knew about Snell's law?
Yes, I know about Snell's law, Fermat's principle, complex refractive indexes. Dude, don't even try. You're not the smartest person in the room, dude. If you picked the wrong topic to try to be the smartest person in the room.
I'm not trying to be the smartest person in the room. I'm simply saying, do you think the FACO model accounted for a proper refraction? Did they apply Snell's law correctly? Yes
It
or no?
doesn't matter. Doesn't matter.
Why does it matter?
Because even if you applied the gold standard refraction, it would only move the laser down 5 meters.
Right. So this is
so you need 100. You need to move it down another 122 meters.
Right. So all of your conclusion is invalid.
So I just want to ask this. What else?
Okay,
What else do you
shut up. Why are my conclusions invalid?
Because you think the refraction was negligible because you misapplied the Snell's law.
No, I just said standard refraction. I just said standard. The standard refraction prediction would move the laser down 5 meters.
So let me ask you a question.
The prediction is 127 meters. Minus 5 meters is 122 meters. Where'd the other 122 meters come from? Where'd they go?
Where did they go? The negligible refraction index.
Look, it has to match a radius of 65,000 miles, bro.
If you don't understand it, right? Just say you don't understand it, and I can explain it.
Oh my gosh, are you not even hearing him? In addition, I put the report in the chat there where it explains how they took what the refraction into account. It's like he's not even listening. He's just trying to reframe the conversation.
I'm gonna prove your Dunning-Kruger pretender clownery. Okay, so Snell's law. Snell's law. Shut up. Snell's law is not equivalent. You cannot use Snell's law in a gradient refractive index media, which is what the air would be. It's not mathematically valid.
Why not?
Look, I'll post it in the chat.
No, you explain it.
No, I'm going to post the paper in the chat because sine theta is not equivalent, right? Because you don't have a well-defined boundary in a gradient index media. I'm going to post the paper.
Okay. Do you know what? Do you know what's less of a mathematical model?
Don't ask me a question, bro.
Required.
Snell's law.
You don't even need to do this advanced mathematics to deploy model.
Bro,
right?
Snell's law is you're trying to run away from your claim now. Now that you got
I'm not trying to run away from it. We can.
You totally are. You totally are. Now you're trying to say it doesn't matter. First, you were trying to pretend like Indio didn't understand when clearly you don't understand.
Shut the fuck up. All right. Let's hear it. Explain it fully. Snell's law. Go ahead. Let's see.
Snell's law is a special case of Fermat's principle, which is well-defined.
It's negligible.
Dude, shut up.
No,
Snell's law, Dunning-Kruger, is a special case of Fermat's principle. True or false? True or false?
Dunning-Kruger?
Snell's law is a special case of Fermat's principle, the principle of least time.
Did you just say Snell's law is Dunning-Kruger?
Snell's law, yes or no? Is Snell's law a special case of Fermat's principle?
I'm not joking, dude. He just literally said Snell's law is Dunning-Kruger. Why?
For the third time, yes or no? Is Snell's law a special case of Fermat's principle?
Did you just say Snell's law was Dunning-Kruger?
I told you Dunning-Kruger, you dunce.
Or Dunning-Kruger.
No. That's what he just said. I heard him say it.
Yeah, we record this. Now you're embarrassing yourself.
I'm not embarrassed.
The little bot up there, the little YouTube thing, all this is recorded. Anyone can just rewind and see what I said 3 times.
Okay. Go for it. Go do it.
What little credibility you had, you just shot away.
What credibility? I'm not claiming to know its own entirety, but even I can tell you're talking out of your ass.
Oh yeah, okay. So I'm posting.
So you don't have a comprehensive understanding of Snell's law. You don't have a comprehensive understanding of the mathematics.
You're not disagreeing with me.
You say the refraction was negligible because you don't understand how it was. So the Fekko model fails.
So explain to me how it works then. Explain to me how it works. Give me the model that accurately predicts refraction. Go.
Why do you want it to explain to you? Go look it up.
How would you know? How would you know? How would you know if I'm using the wrong model? How would you know if I'm using the wrong model if you don't know what the right one is?
Because I just listened to the fucking video.
How do you know that's wrong if you don't know what's right?
She's a dumb fuck like you as well.
How do you know that's wrong if you don't know what's right? Yeah,
because
that's right.
they also use the Optical model in that video they just posted.
How do you know
in
it's
the
wrong if
Netherlands.
you don't know it's right?
I just looked at the video that she just posted, the 55-minute video that she posted.
Okay,
that's
and
the Optical model, right?
And it's wrong. Why?
Because it misapplies Snell's law, same as what I
then
just said
show us the
earlier.
right application.
Why do I need to do that? I don't need to spend money to disprove this shit.
Because you don't
do
know
your
what the right
research.
application is. You can't use Snell's law even in this context.
Okay. All right, listen, dumb fuckers. All right.
No,
I don't need to do all of these.
You say that.
Okay, peace out,
yeah.
Harris. Peace out.
Yeah, you're about done.
Hey, Harris, listen, Harris, I'll let you speak again if you post any application of Snell's law at all in any context in the chat.
Look, if you can even define Snell's law without reading
I love the fact that you guys really believed it and you're very...
Yeah, we don't care about your social commentary.
enthusiastic about it.
Zip
and
it. We
really
don't care about you. Either bring globe evidence or shut up, bro. We don't care about your social
Ringo, bro, I'm trying to be positive here. You're being negative.
No, you're giving social commentary about flat earthers. We don't care. We want the globe evidence or shut up.
I'm just trying to be positive. I'm sorry.
No, you're talking about us saying, you guys really believe this. No, don't talk about us guys. Talk about the topic. We're not the topic.
I'm sorry. I was just trying to be positive.
Yeah, shut up.
Every flat earther has
You're
their own
failing.
different-
You're
And now
failing.
you're
That's what
doing
you're
it,
trying to do. You failed.
Now you're doing the very thing I just told him not to do.
Dude, I'm a flat earther as well. I'm allowed to say what I believe.
You are. What's the best evidence for a flat earth that you've seen?
No current found.
I mean, if the Earth was flat, wouldn't tornadoes and hurricanes be impossible because they only occur on a globe Earth?
That's idiotic.
Dude, what the fuck?
That's idiotic, dude.
Well, it's one of their arguments for globe Earth.
Is that hurricanes and tornadoes are impossible on a flat Earth?
Tornadoes and hurricanes, yeah.
No, that's not the argument. The argument is they only spin in one direction. And that proves the Earth is spinning. You don't even know the fucking argument of your own side.
I'm a flat earther, but now I'm going to be a glober out of
just like Taurus, right? You never were like you couldn't tell me what single flat Earth argument.
Christopher Columbus, when he was sailing and looking around for the Americas,
just go on mute, dude. Fucking troll army, dude. They all called each other. Come in there, let's troll the flat earthers. Do you know what you guys aren't doing? You're not producing evidence of a globe. That's what you're not doing. So Harris, we're gonna try you again. We're gonna try you again, and you're gonna answer a simple question. Do you know what the model of the standard refraction model used by surveyors is? Oh. Yeah, you're unmuted, Harris. You can get out of your DMs and come back in here.
Oh, I'm unmuted?
Yeah, you're out. Get out of your DMs with your little buddies here.
Fucking echo chamber,
Your
dude.
fellatio party that you're having with your buddies. Okay.
Dude, this is literally an echo chamber of some illiterate Americans.
No, it's bro.
You're all
Harris, it's not echo chamber. It's echo chambers. We have echo chambers. We have three servers. We have three servers, so it's echo chambers.
You're sweating. Fucking idiots.
We have echo chambers, buddy. Get it right.
Illiterates. Read a book. Did you pass high school?
Yeah.
What's the highest qualification you
I went further in academia than you did, Harris.
Did you go to college?
Yeah, and I graduated.
Really?
Actually, in fact,
what was the qualification you got? What was the field in?
3, 4.
What was the dandelion? Or whatever his name is.
6 flat earthers in here graduated university.
What course was it? Socialism?
And Harris, you didn't. Harris, you didn't.
No, I did.
I can tell you. No, you didn't.
Yeah,
oh yeah.
What was the course? What was your course, by the way? Was it flat earthery?
What was my class?
Yeah, what was the course that you graduated from that your qualification was?
Course. You take lots of courses in university, Harris.
I fucking thought so. She said, you didn't graduate from university. Fucking liar.
You take lot. Please. You take lots of
Yeah.
courses at the
So
university.
don't pretend like you graduated from high school. I don't think you even graduated from high school. You don't know any
You can't even tell me anything about Snell's law.
I don't need to engage with
Which is taught in high school.
You don't even know what basic calculus is.
Snell's law is taught in high school.
Have you taken calculus before?
Yes.
You know what integration is? Do you know what differential?
Yes.
Right.
I know what derivatives are. So this is. So did you see the paper I posted? So using the calculus of variations, it proves that Snell's law can't be used in an index
you're just
index reflection
the video.
medium.
I looked at this 50-minute video.
It's not the video; it's the paper I posted, Harris.
And I know distinctly that what the principal error that they made. Right, the principal error is they misapplied Snell's law, which gave them far too little bending, so they concluded that refraction was negligible.
Give us the right application.
Why the fuck do I have to do have to waste my energy and my education entertaining dumb fucks like you? No, you get a diploma. You do the
I have one. I have a few.
Do it. So I don't need to do a play.
No, Harris, it's really simple.
Do you want me to show you, right, a far more easier experiment that you can conduct without anything, right? Oh, you don't need any high-powered laser, okay?
Yeah, you're trying to change the subject, Harris.
No. I'm just showing you.
Harris,
I can
Harris,
base arithmetic.
Harris, how do you? What refraction needs to exist to get that experiment?
I'm not going to have an impact.
Don't interrupt me.
With you.
Don't interrupt me. I'm going to ban you.
You're not an intellectual person,
3,
right?
2.
I will not engage.
Yeah, that's right. You will not engage.
Let's talk to the Christopher Columbus guy. True self.
Yeah. That's
Hold on. I'm gonna finish my thought though.
Okay, do.
Because he was trying to mute me by filibustering. Okay. I want to know for anybody in this chat if they calculated refraction wrong. What refraction has to exist to get their experimental result? That was the question I was going to ask them. Which refraction has to exist for them to measure that? For them to get a beam at 1.5 meters off the surface of the water over a distance of 40 kilometers. What atmospheric refraction has to exist? And how did that same atmospheric condition happen again 3 weeks later? If you can answer those questions, then maybe I'll take you seriously. But carrying on.
Wait, me?
Yeah, Columbus boy.
Oh, I thought the other guy, because he sounded smarter.
Oh my gosh, really? You thought he sounded smart because he gave no evidence, True Cell. He only kept making claims, kept trying to insult us, so on and so forth. He didn't understand what he was talking about. He wouldn't answer the question that Indio just asked, which was an amazing question. You can't just look at, he obviously did not look at, he looked at neither the video nor the PDF summary of the FE core experiment, because if he looked at it, he would see that they accounted for refraction that was already accounted for. So he had no idea what he was talking about. His purpose was to fool people who are not examining the evidence in an objective way, who are just interested in emotional appeal, fallacies, and arguments about the person, into thinking that he had the upper hand in the conversation when he never had the upper hand in the conversation. He never presented any information. What information did Harris present that made you think that he sounded smart, True Cell?
He used big words, but I do got 4 questions, though. Four honest questions.
I got a question. Have you ever heard in the land of the blind, the one-eyed man is king?
No, that sounds cool, though.
Yeah, you're a blind person, and you think the one-eyed man
that doesn't sound
king.
cool. Okay, I got 4 questions though. One is, I thought flat earthers don't believe in the Earth is spinning or gravity.
No. Flat earthers isn't the topic.
But it's my
I
question.
thought you were a flat earther.
Yeah, exactly.
So
okay, wait.
Just ask yourself what flat earthers believe.
Okay, wait. 2 is there a dome around the Earth, and space is fake, and you can't exit out of space?
That's a bunch of questions. No one knows if there's a dome. but we do know it's contained. And space is fake because it's impossible
to get to, right?
No, it's just impossible to exist in the way they say it exists.
What do you mean? We can see stars and like planets and stuff from telescopes.
Yeah, can you see how far away they are away?
I don't know. Maybe you could calculate it.
How?
I don't know. I'm not a math guy.
Okay, so you don't know. So this is the problem. Is that what they say is those things are in a giant vacuum and that we have air pressure next to that vacuum. But we know from experiment and real world experience that you can't have air pressure next to a vacuum without some sort of barrier separating them. So if you want to say planets and stars exist in some vacuum, there's no way you're going to get to them because there must be a barrier preventing you from getting there if they're in a vacuum.
Okay. And three,
and we know because this is called the second law of thermodynamics, which has no known violations in the history of mankind. So what we have is the second law on one hand and what it says, and people showing you images on a screen saying they're violating that. And then if you ask them, they'll say gravity creates the gas pressure. And you say, okay, demonstrate that with an experiment. And they can't. They can only talk about it. And then if you look at the kinetic theory of gases, there's no gravity in that to describe what gas behavior is.
Right.
Because gas is unaffected by gravity.
That makes sense. Okay, I think last question is...
It's not that it's fake, it's that it can't exist, period.
Okay.
Violation of natural law.
I get it. Then, like,
the dome is more of a claim about the shape of what the barrier is. We don't know what the fucking shape is. Could be a fucking pyramid. Could be a fucking, I don't know, a rough fucking surface. Could who knows?
Yeah.
Who knows?
No,
even solid material. Like, I don't know.
Right. And then my second
question, dude. We only talk about what we can prove. We don't talk about speculation. We don't speculate here.
Right.
We only deal with what we can prove. Dome, we can't prove that. Gas pressure went out of container, yeah, we can prove that all day long. Go try to pump up your bike tire without a fucking tire.
True. Yeah, that makes sense. But how does no one fall off the Earth if it's flat? Is there like an ice wall?
Fall to where?
Huh?
Why would anybody fall anywhere?
If it's flat, wouldn't there be like an edge? You know, like a coin kind of situation? No? I mean,
I just told you there's no space. That means Earth is not a space disk. And why would you fall? The whole idea of falling is, there's this thing called gravity. Okay? Why would I fall off the edge of the Earth? Where would I fall to?
So are you saying there'd be a barrier?
Where would I fall to? Can you answer where I would fall to?
I don't know, like off the Earth somewhere.
To where? Would I fall to space? Would I fall to space?
I suppose. Perhaps. I guess that makes sense.
Can't fall to space. There's no edge of the Earth. There's no fucking big void universe where there's a bunch of fucking objects inside.
But if it's flat Earth, like you say, there is an edge.
You got questions, I'm answering them.
Yeah.
Earth is not some fucking object in a giant fucking void. Okay? Get that idea out of your head. That's like thinking like the universe is inside of something. What's the universe inside of?
Probably God or something. I don't know.
The universe is inside. What's God inside of?
The Christian God.
Okay, what's inside of that? What's that inside of?
I mean, the Christian God is...
with this? No matter what you say, I can ask what that's inside of.
Well, the thing is, God has no beginning, so it kind of stops it there.
Wait. Well,
it wouldn't be God if you had a beginning.
No, God,
like the universe has a beginning.
I'm talking about frickin' space, dude. Metrical space.
Hey, so I have a question for you, though.
No. Wait. Okay. I fucking hate when you guys do that shit. We're getting right to the fucking point.
So, like,
what is the universe inside of, right? Does the universe have an edge?
No, it's apparently infinite according to NASA.
No, it's not infinite according to NASA. They say it's 90 billion fucking light years in diameter.
That's pretty big.
Okay, what's outside of it? What's it inside?
What's inside the universe?
Yeah, where's the edge? The question you just asked me, I'm asking you. Where's your edge?
Like, in my mind, for the Earth?
In the modern cosmology, the cosmology you believe in, where's the edge of the universe?
I don't know.
Well, then it don't exist then. Universe don't exist.
The universe doesn't exist.
Well, obviously it doesn't exist because you can't tell me where the edge is.
Well, yeah, because I'm not like some
But
space
it has
guy.
to have an edge, right?
I suppose, yeah.
Because everything has an edge, right? Everything?
True. Yeah.
Really?
Yeah.
No. No. Everything does not have an edge, and it was proven a long time ago that you can't actually prove with math, geometry, logic, that there's a boundary on anything. It's called Zeno's paradox. Because you can subdivide shit by half for forever, and you can never reach the boundary condition. So using discrete mathematics, you can never actually prove there's a boundary. And that's what you're using when you say, hey, where's the edge? Hey, if I walk a certain distance in some direction, where does the Earth stop and become something else? There is no place where that happens. The only way you leave this Earth to get outside is when your heart stops beating.
I see.
Okay? There is no physical boundary to the Earth in which you can go fucking to. You can't go knock on where the dome meets the Earth. You can't. The Earth is not a disk in space. It's not the third disk from the sun. It's not a space pizza. So what you've done is that you... Did he bounce?
Oh yeah, I guess he did. Oh, that's too bad. Well, at least he was able to at least have a back and forth more than Harris.
Okay, Colonel Brad, he freaking crashed and burned.
All right, so my question is...
Your voice sounds oddly familiar.
Who knows?
Have you been in here before?
I don't think so.
Okay.
So as far as that go, as far as the Earth being round or Earth being flat, how do you kind of account for flights like air travel being faster if you follow supposed curvature of the Earth rather than a straight line?
What does that mean?
So the time difference between flying at in kind of an arc around what would be a spherical Earth, the curvature of the Earth. How do you account for that if it's flat? How
There's
it would
nothing
be
to
faster
account for. Everything you're saying is factually incorrect.
What's factually incorrect?
Because you're confusing the projection of a coordinate system with the fucking actual Earth. So if you take the projection of a spherical coordinate system like latitude and longitude, and you project it onto a grid and map those points, a straight line is going to become a curved line. And if I take a curved path and a polar coordinate system and map it to that, it's going to show a straight line. But planes don't actually fly like that. Planes actually fly in international and domestic flight corridors. So they don't fly point to point in the first place. That's why I said everything you said is factually wrong. It's totally abstract. You looked around the web and frickin' looked at some Flight 24 projection onto a frickin' Mercator map, and we're like, hey, it's taking a curved path. It's not taking a curved path. It's a projection of the coordinate system. Its location in that coordinate system is a curved path, because that coordinate system, latitude and longitude, does not exist on the surface of the Earth. You understand that?
Yeah.
Latitude and longitude are not points on the ground. Contrary to popular belief, they're in the sky. And what that coordinate system represents is when you're under a certain set of stars at a certain time. That's what that coordinate system is. So if I asked you, find your latitude and longitude using only the ground and nothing in the sky, it is an impossible task. You can't do it. No one can do it because there's no reference to the ground within that coordinate system. The reference is secondary. Right. We make the celestial sphere coordinate system, and then we assign locations on the Earth to be underneath it.
Right.
And they used to actually write this in books at the end of the 19th century. This is what they would say. They wouldn't say you're on the equator. They would say you're under the equator, or that you're under the tropic of Capricorn, or that you're under the the Tropic of Cancer. This is how they would write it down. They wouldn't say you're on it. They would say you're under it.
All right.
So when you take that coordinate system, right, of a plane is flying somewhere relative to the stars, and then you take some flat Mercator map, which is also made with that coordinate system, but turned into a cylinder, and then you map the celestial sphere to a cylinder coordinate system, and then you place it on a square grid, you end up with a curved fucking path. That's what it looks like. But that's just what it looks like. But if you were above the plane looking down on it, it wouldn't look like that.
All right.
This is confusing the map with the territory. This is a known fallacy. It's called the map territory problem. Look, don't feel bad because a lot of people don't understand.
Oh no, I'm here to learn
cartography and coordinates and differential geometry and all these little subtopics. They're presented with it in a very oversimplified rendition of what's actually going on. Because I can post right now in the chat pilots inside the cockpit showing their flight route on a polar projection, and it shows it's completely straight. Right? They're in the fucking cockpit looking at their fucking sky chart.
Yeah.
So but if they took that, right, their map, and they were like, oh, let's put this on the Mercator map, it would then be curved.
Yeah.
Yeah, I'll show it. I'll show it just for everybody. You can look at it too if you'd like. Just gonna find it real quick. That's the video, but I'll post a screenshot of the map. That's a clip of that section of the video. That's a screenshot of them looking at their map, right? And this is a straight line right across the map. And I think they're flying, could be like Buenos Aires to, I can't remember exactly. Oh, did I post that in the wrong thing? Yeah, I did. Hold on a second. We posted the video. I didn't post the clip from the video. Anybody else want to chime in? It's weird how it didn't embed right.
I can't wait to China take over, man. That's gonna be so awesome.
Oh, wow, oh, you want to be unmuted, tourist? See if you can contain yourself, dude. Here, talk. Eddie, who wants to talk to tourist, man? Tourist needs a freaking.
Hi, tourist.
Thank you. Most gracious of you to give me my tongue back.
Were you the one who your flat Earth evidence was Christopher Columbus?
No, dude. I got muted for no reason. That guy talked over me.
That was a guy called Trayless.
Yeah, that's the guy that left. Yeah. That's the guy that had 4 questions.
Well, you guys are brothers in arms, man. He was also a flat earther. You guys both are.
I'm a different kind of flat earther.
Like the globe kind?
Well, no. And then you'd be a globetard, wouldn't you?
What made you a flat earther tourist?
I don't know. Flat Earth to me is more of a philosophy that rejects constructionist dogma. But, I mean, you know, more power to you if you want to take it, like, insanely literally, you know? Because, I mean, that still aligns.
So you're
He's like, where do I go with that?
Wait a sec. Does this ring a bell? Does this ring a bell, tourist? Earth is flat, Jack, flatter than a flapjack. We bout a flat smack. Globers, get your backs packed. I'm with my flat pack. Globes in the trash sack as I move an equidistant map upon my snapback. Flat smacking everybody in Joe's crab shack.
Damn, better than Eric Dubay.
That's from,
Was that you?
Well, that's from Channel 5. But yeah, I have been known to rap that occasionally in this channel.
Oh, so you didn't write that?
No, that's from like the Flat Earth conference that Channel 5 went to.
Oh, is it? Oh, okay. Because I saw you post it one day and I saved it.
Yeah, dude.
Alright, so that's not you.
Fucking legendary.
I liked T-Dub's performance of it. That was great.
Yeah, dude, it needs a rendition.
I don't know. Harris is back. He's claiming he wants to go through this model step by step. I don't even know what model they're talking about.
Oh, yeah, this should be funny. I really want to entertain this. Ah, hell yeah. Okay, Harris. Tell us the refraction conditions that existed to make this observation possible, these measurements. And then I got it again 3 weeks later.
So, do you have a scientific calculator with you right now?
I don't need a scientific calculator.
Then how could you follow my calculations alongside step by step?
I don't need to follow your calculations, dude. I need to know I need to know the model, the variables that you're going to use.
I will use it to be consistent. I will use the original measurements.
What are your variables?
What variables? The measurements that they were taken?
Calculate refraction that can account for this observation.
I will follow exactly what the original...
Look, the fact is, they measured the laser 1.5 meters off the fucking ground. How did it get down there?
What? The fuck are you talking about?
They measured the laser 1.5 meters off the water. It's supposed to be at 127. Why are you interrupting me? Why are you interrupting me?
I'm going to explain
You're going to go back on mute. Last chance, dude. Don't interrupt me again, dude.
Why are you scared? Why are you scared?
Let me finish my sentence.
Let me explain it.
No,
Let me explain
I didn't finish my sentence.
You unmuted me so I can explain it and go through the
I didn't finish my sentence, dude.
I don't need to hear you yapping.
You're very bad. Yeah, you're very bad at taking turns, Harris.
I don't care.
Can
I
you
don't
hear
need to
me?
give you guys any respect.
Yeah. Okay. Well, then you don't need. Yeah.
Home mom has nothing to do better.
Mm-hmm.
I love when they get muted right when in the middle of a sentence.
Yeah. Yeah. Yeah, he has problems taking turns speaking. We're trying to have coherent conversations here. Gosh. His cohorts, his compatriots were much more civilized and better able to hold a conversation.
The funny thing, they consider him the smart one of them.
I know when that guy said he was smart, I'm like, oh my goodness. I mean, he's just, that was crazy.
He used big words.
He said that, yeah. When I said, what made you think he was smart? He said, because he used big words. Yeah, that was funny.
Was that the sesquipedalian authority fallacy? Dude, what big word did he even use? Refraction.
Yeah, I think so. 3
Probably
syllables.
calculus. I
Yeah.
think calculus is the longest.
I was going to say that.
Oh, he also said integral. Or no, he said integration.
Dude, I think he was just
He only got
covetous.
3 syllables.
I think he was covetous of the capaciousness of your capus cavernosa.
Well, Drace and Carmen must be the smartest because they got that word that has like 27 syllables in it.
Yep, definitively. Were we answering something for Colonel Brad, or did he get answered?
Honestly, I can't really think of any other questions that would really draw anything right now. I'm pretty tired.
Yeah, that's cool. I'm pretty tired too.
Have you ever considered that the Earth looks flat because it actually is flat?
I don't know.
So crazy, huh? It's crazy. Flat things look flat. Wow. Like, don't you find it odd that that's the crazy claim that the Earth looks flat because it is flat, and that's considered the delusional claim? When if you say the Earth looks flat but it's curved, that's not delusional. I think that's odd.
Well,
No, if you evaluate it just the same way as you evaluate everything else, like this, say you were in some other topic, and this is how the topic went: is that the truth was the opposite of what it appeared to be, in that you had to reject the impression that you got for some theory. You would probably never accept it in another context, and most people wouldn't. But for some reason, in the context of flat Earth versus globe, people are very willing to accept experiences which are 180 degrees, or accept claims which are 180 degrees from their experience.
as far as seeing it's flat, what about when you're at high altitude and it appears that there's a bit of a curve to it?
There's no curve at high altitude.
Yeah, but if you're at high altitudes and you look out and it appears as if there's a curve.
Yeah, nobody says that, and it shouldn't. Even an airplane is nowhere near high enough. You got to remember, they say the ball's 8,000 miles in diameter. Airplane flies at 10 miles. You're 1/800th above the surface. No plane would ever go high enough. Even the ISS, where they say that is at 250 miles, that would only see 3% of the surface of the Earth if you could see the entire circle of the horizon. But you're only going to see a sliver of that, right? Whatever your field of view is. Say it's 60 degrees. Now you're only seeing like less than 0.5% of the surface of the Earth. How are you ever going to see the curve of the Earth when you're seeing such a small fraction of it?
I don't know. The video.
Even mainstream claims you can't see curve from an airplane. It's not just us. There's a famous video of Neil deGrasse Tyson. Remember Felix Baumgartner? Do you know who that is?
I don't know.
He had the world record for the highest skydive. He jumped from 128,000 feet.
He had a video, right? It was like
yeah. Red Bull. It's called the Red Bull jump. Yeah. He died in another accident just recently. I think this year too. He died of doing some other crazy thing. But he skydived from 128,000 feet. And Neil deGrasse Tyson gave a conference and was talking about that jump and said there's no way you could see the curvature of the Earth from that elevation. And that's way higher than an airplane. That's more than two times higher than an airplane flies. So it's not nowhere even near high enough. Because you got to remember, that you have to see a significant portion of the Earth to see the curve of the Earth, because you have to see it as a circle, right? And if you're so close to the surface and you're looking across it, every point on the horizon is equidistant from you. It can only ever appear as a straight line until you're far enough away from it, where you're seeing the Earth as a circle around, which is pretty far away. My estimation is like over 1,000 miles. I mean, there's hundreds and thousands of pictures of people taking pictures out of airplane windows that show no curve. And Dandelion posted Felix Baumgartner. The other thing that's important about the Baumgartner jump that people don't realize is that part of the video they made of it, so they take video from looking at the same shot, like looking out the window, when they're 10 feet off the ground and he's standing in the door, right? And the horizon cuts him right at midline. Well, right before he jumps out, he's at the door again, and the horizon's cutting him right at the midline. Well, according to the globe, the horizon should be dipped down 6 degrees. Right? That's 12 solar diameters. That's 12 widths of the sun. That horizon should be dipped down. It shouldn't be still lined up to his torso.
Yeah.
Okay.
Yeah, so people aren't actually seeing any curve at high altitude. What made you think that they were?
I don't know. The videos kind of looked like it.
Well, the human eye is not capable of seeing past like 5,000 meters accurately.
Yeah. Yeah, I don't know. Like I said, I didn't really have that good questions. I'm tired. And
no, I mean, that's fine, dude. We're not, there's no pressure. We're here 24/7. So if you look in the chat, so what I was just talking about, the horizon cutting him in half right at the waist, it's in the same place. So this is 128,000 feet and 10 feet. If he's going up higher and the Earth's a ball, that horizon should be going down, down, down as he's rising above the ball instead of staying at the same level. Because one of the arguments we hear from globers, right, is that if you go up in a plane and you try to measure the horizon has a dip. It's dipped down, which proves the Earth is a ball. But this is evidence that that actually doesn't happen. In fact, the horizon is not the edge of the Earth at all. The horizon is purely an effect created by the meteorological conditions, purely optical, which is easy to demonstrate. Because if you go to the beach and you go repeated days, you'll see that the horizon will appear to be different distances on different days, which means it can't be the physical edge of the Earth unless the Earth is getting bigger and smaller. When I say physical edge, I mean a visual edge where the curvature starts, right? That's the end of the curvature. You can't see any ocean past it because the Earth is curving down and around into a ball. But if that location moves around and it's 10 miles one day, 3 miles another day, and 30 miles another day, that can't be the curve of the Earth. It has to be visual. So a lot of the premises of the globe that the horizon itself is the edge of the Earth, it's just wrong in the first place. Like, I can see the curve of the Earth from the airplane. Yeah, I mean, that assumes that that horizon is the edge of the ball that you can see. The limit of your vision is the edge of the ball, and that's determined by that. But there's even a NASA paper published that the horizon, a high altitude, is not measurable as a location because it's too opaque. It's too what would you call it? It's too diffuse. It's not well defined enough. Even if you're an airplane, even if you're in an airplane and you're like over a pristine freaking ocean in the most perfect weather conditions, when you look at the horizon's a little blurred.
a lot blurred.
Yeah.
At 200 kilometers, I could hide a 100-meter object. You never see it.
Probably bigger than that if the color was a certain color. Painted it white or blue, you'd probably never see it. You'd probably be 1,000 meters tall and you couldn't see it.
Yep.
I got a college class in the morning. I should probably head to bed.
All right.
It's good to talk to you. Yeah.
It's nice to meet you guys. I'll have to pop in here another time. When I'm more awake, you know. All right. See ya.
Peace.
Yep. Bye-bye. There's no globe.
We live on a globe. The Earth was spinning. He'd never get to sleep. Who said we live on a globe?
Moving in multiple vectors would be worse than seasickness.
I bet it was Mansky that said that, wasn't it? He wanted to have the last word. There's no globe, Colonel Brad.
What stage agree for you and Mansky?
The best one.
Is denial the best one?
It's not just a river in Africa.
Acceptance. I accept the Earth as a globe.
Okay, so denial then.
I think he's in testing. He's testing the realistic solutions, and then he just said, I accept the Earth as a globe. That's not a realistic solution, buddy. Mansky, at least you'll never admit this, but I know that even if you realize the Earth is flat, you could never tell anybody because of the amount of ridicule you'd suffer. And that would lower your social status, and that would upset you greatly, so you never do that.
I could believe the Earth is flat and never tell anyone.
Yeah, you could, including us.
I don't care if I tell you, but I'm not going to go around telling people in real life.
Why? Doesn't matter, remember?
Because they'll think I'm fucking crazy.
Why would they think you're crazy? It doesn't matter.
Man, I sport my cap around everywhere. It says, the Earth is flat. Didn't you know that? I wear it everywhere, man. Nobody says a word to me. That's cool. And everyone's friendly.
Mansky would call the police. We got a flat earther out here walking around with a hat on. Fuck.
Hilarious. I also wear, like today I was wearing it, and but at the same time I'm wearing a Star Wars shirt. It's got a big stormtrooper on it.
Dude, I love it. I love it, man. Dude, you're making me like, you know how they got like a NASA shirts with a globe? A NASA shirt with a freaking flat earth space pizza. I bet you'd sell a ton of them. I gotta start my t-shirt company, man. I got a bunch of freaking t-shirts I've thought of.
Have you talked to Allison Angel, fitness trader girl or whatever?
No.
He never really talked a whole lot in Flat Earth Fridays, but she goes by Allie Angel on X, Twitter, whatever. And she has like a trueearther .com website that she sells like she sells shirts and she prints them as you order them, right? Like she's got this whole system set up for it and everything. And so I bought a few shirts from her, and my wife wears my shit all the time when we go to the immigration buildings. So I got one that looks like a Coca-Cola bottle, but it says Flat Earth. It's the real thing. She wears it all the freaking time. It's hilarious.
I love it, dude.
That one, and then
I'm slacking.
That one, and then there's another one that she wears. It's a little sheep, like a little cartoon sheep with a mask on, and it says "Think while it's still legal."
Yeah, like you can start a company, basically an online store, and that another person will basically print your T-shirts for you. You just got to come up with a design.
Yep.
Which I plan on doing, actually. I just haven't done it yet. But I got two good. I got one really good one. I'm not gonna tell you guys. I'll steal the idea. Dude, normies would buy this one, especially if I make two versions. Especially around here, because like college nerds would like get it. You know what I mean? We'd get it too. Like people around here, we'd get it, but like, it's just funny. It's just kind of funny.
Yeah, I posted up a picture of the shirt my brother got me for Christmas one year because I told him I was a flat earther. I like the shirt, but he just has the freaking pizza earth on there, man. I was like, damn it. I wish that wasn't on there.
Yeah.
I know, man. That ruins it.
Yeah,
Is there pineapple on that pizza?
No, not even pineapple on it.
I think it's intentional like that, though. I think that's created by some retard.
I think it's intentional too.
Even if it was just the words
flat
that were
earther, is he just trolling you?
Oh no, nobody else in my family and friends. Nobody is. I try talking with most of them. You know, I'll bring it up once, give them some basic proofs, and I'll never bring it up again after that unless they want to talk about it with me.
Dude, you gotta make a 2-minute pitch. After that, they're lost. Basically, yeah, I'm telling you, dude. I listen. I know. Okay, when you told them, as you're telling them, you can see them fading. They can't keep up, dude, because they never thought about it. You're giving them stuff that's making their brain explode. Right? I'm serious, man.
No, it's true.
That hamster wheel starts running so fast, dude, that they can't, like, because people, they think complexly. They don't think, you say something to them, right? And they think, oh, the consequences of this, okay, that would mean the earth is flat. But then their mind don't stop there. Then they start thinking about the ramifications of that. And then you drop another fact on them. And their mind starts wanting even more. They're going at freaking light speed in their freaking brain. So you can't dump too much information on them, dude. You got to make it, because literally you can see it in their eyes that they can't.
They check out.
They can't keep up. Dude. They check. They have to check out, man. It's like a self-preservation thing.
No, I'm willing to hear you out about your like how you measure it flat. Sure, we can get into that at some point. I genuinely am more curious about the other stuff, though. That's why I came to ask.
We talk about flat Earth in here and our measurements, so you're in for a treat.
Yeah.
So one such measurement was at Lake IJssel in the Netherlands. A group called FE Core Field Engineers Core, they're an independent research group. They conducted a long-distance laser engineering test over Lake IJssel. This measures about 25 miles across, or 40 kilometers. So they positioned their laser at one end, 1.5 meters high. They positioned a target at the other end, 1.5 meters high. They took measurements of the water, of the surface, I should say, and of the air. And the laser was able to shine a beam onto its target. The target was able to see the beam, and not just like a beam dispersion, but the actual centroid, the very middle of the beam. So if Earth is a globe, there'd be 90 meters of curve, of a hump in the way. Instead, there were no meters.
You look, bro, I'm probably too much of a sheep. My brain is too small to understand, like, how the measurement like that works, because like that doesn't make sense to me. I don't know, like, genuinely, I don't know how that proves it.
I think like some basic context, is that what you're looking for about what we mean by flat Earth?
Yeah. Treat me like I'm an actual like baby.
Hold on one second, my wife's just calling me. Back in a second.
Oh, good, bro. Treat me like I'm a baby, bro. Like, treat me like I don't know shit, because I probably don't, and probably don't. Because like I understand, like obviously a lot of the world is flat, like from our perspective, right? Also, the I find really interesting, the photos of Earth are like Photoshop from space, right? I find that interesting. But I don't understand what you mean with this laser thing. Like, I don't understand like how that denotes it. Like, you're gonna have to explain the context as to why that would be proof.
Do you realize you just said treat me like a baby, and then talk about space, and then return flabbergasted to lasers not having curvature on the surface?
Yeah.
Where are you going?
I'm just having a conversation with you, man. Is that so hard to believe? Like,
What's the radius of the sphere that you believe in?
I don't know.
What's the distance to the horizon on the sphere you believe in?
I don't know. I haven't come here to argue that the Earth is round.
So how do you falsify the claims that
I'm not
you've
trying to
been told?
falsify anything that you've telling me. I'm not trying to falsify it at all. Stop assuming that I am. I've told you how many times now?
Okay, so
how many times now, man? How many times?
The radius value is 3,959 miles.
Sure.
So that would mean that the distance to the horizon should be 1.2 times the square root of the observation height in feet. That'll give you the distance to the horizon in miles. If you go out and you make your own observation and you see farther than what that claims, you are not looking at the radius value of the Earth that they claim. And then when you watch the horizon change distances to you, then you are not looking at a sphere, you're looking over a flat plane with visibility changing your distance based on the environment.
That doesn't make sense.
Your sphere from school is falsified by math and reality. You being on a sphere is falsified by reality itself. The horizon being the conjunction of the earth and the sky, objects are supposed to be disappearing bottom up due to the ground, its shape, causing obstruction, similar to you and your buddy standing on a hill. Walk away from each other, and the hill is now in between the two of you, and your feet are covered, and then your waist is covered, and now you're only staring at each other's heads, peeking over the hill.
Yeah.
It doesn't happen with the horizon. You can see like boats disappear bottom up. There's plenty of reasons and why that happens, and it is not the case that it has to be due to the ground. You could put a little sailboat on a driveway that's flat and then lay down on the ground and watch the boat disappear bottom up because the heat from the concrete begins to distort the base of the boat. You can put a coffee can on the floor in your house, walk away and lay down, And then you'll see that as you get further away from the coffee can, the base of that coffee can will disappear because its angular size is shrinking.
Yeah. Like, bro, I don't know, like, I don't know shit about measuring anything. You know what I mean? Like,
this is even easier than that, right? Because, like, I'll give you an example. If we have a 10.
You're watching 24/7 Flat Earth Discord live.